Enjoy.
Everyone, can you hear me okay? Yeah. I'm Mitya Argunov. I'm a co-founder of Draw Protocol and sorry. Doesn't change. Okay, that works. And today we're going to speak about how we unlock liquidity for the modular economy. At Drop, we believe that abundant liquidity is super important for the ecosystems to flourish. So we're going to explore three things. Can you go to the next slide? So we're going to explore three things. First is what is the most successful example of the ecosystem built around an abundant liquidity. Second, about what are the things that we can learn from this successful example and how we could use it for the modular liquidity. So what is what is this most successful ecosystem? And it is not changing still. Can you go to the next one? What is the most most successful ecosystem built around abundant liquidity? That's Ethereum. And go to the next slide. Yeah, that's. Sorry?
Tell next slide when you would like change.
Okay. So Ethereum is obviously super successful. So let's dive into its story and see how it evolved. Ethereum started as a proof of work chain, and then DeFi summer happened on Ethereum. And DeFi summer was the period when a huge lending borrowing market was created on Ethereum. That was before staking launch. And staking was launched with very significant UX difficulties. So you have to have 32 ETH to start staking. You have to spin off your own validators. It's pretty prohibitive. So when LST started on Ethereum, they solved a super important UX problem. And that was a very important part of their success. But they also clicked into the pre-existing DeFi ecosystem that was like perfect fit for an LST. And leverage looping became a killer use case for LSTs on Ethereum. That created a lot of growth around it, so people could get way more yield than they could get from native staking by default. And that's how the ecosystem evolved. And it resulted, on the next slide, in basically three super important things. First, it's high capital efficiency. People now leveraging multiple different DeFi tools could get very reasonable yield, around 10% APR, with good risk profile, let's say. Then the whole app ecosystem around it is really booming. There are multiple billions of TVL, millions of active users in the ecosystem. And all of this doesn't come at the cost of security. So staking ratio in Ethereum is pretty high now, around 30%, and it keeps growing and growing. So all these factors are aligned about joint incentives. All the players in the ecosystem, validators, users, builders of the applications, are aligned around growing liquidity in the ecosystem, using ETH as a main asset, and basically building the success together. So what we can learn from the success on the next slide. What we can learn for the modular economy from Ethereum success. On the next slide, here's basically the answer. How we can replicate it, and how we can basically create a similar dynamics around TIA and using exactly the same tools as in ETH. And next slide. Basically, we don't. And we don't because all these factors of Ethereum success were, in fact, path dependent. So there was no DeFi summer on TIA. Staking is very simple in all the Cosmos SDK chains. And DeFi is pretty small compared to Ethereum. So we really need to go in a different way. Modular economy is unique. We need to create unique ways how to grow it, and start with the first principles on the next slide. So let's think first principles and analyze what are the desired outcomes that we need for Celestia. And as we saw in Ethereum, we need high capital efficiency, so high yield for tier holders. We need the validators that whose incentives are aligned and high staking participation. And we need app builders that have easy access to liquidity. And let's look at the current state on the ecosystem on the next slide. And it's basically opposite to it, because 70% of TIO is currently locked in staking, and there is very little incentives for anyone staking TIA now to use it for other use cases, because they're just not as appealing. And this is a problem, because once this liquidity is locked, it's not used in the apps are starving, therefore the whole DeFi ecosystem is not as appealing as it could be, and therefore there's still no incentive for the users to unlock the liquidity. So how do we solve this incentives problem? Let's explore how we can do it on the next slide. So for the modular liquidity, let's think about incentives alignment on the next slide. There are three main categories of the participants in the ecosystems. In the ecosystems, there are tier holders, there are validators, and there are rollup builders and app builders. So let's, on the next slides, look at the tier holders first. So what do they need? They need basically high yield. And currently, the yield that they're getting from staking is kind of the optimal solution for them. So let's explore how we can get incentives around liquidity to get them even higher yield on the next slide. And the idea is that this is where LSTs really come into play, that there are two sources of yield. There is staking yield, there's DeFi yield. Once you combine them, launching a derivative based on the stake token, you can now get even higher yield for the token holders. But the issue currently is that the DeFi ecosystem is pretty minimal, and therefore it's not just appealing for the people to participate in these use cases. So how do we solve for that? We need to kickstart it and basically create a flywheel effect around the key applications that are using TIA. And there are multiple ways how this flywheel effect can be created. And we'll not dive into this at this conversation, but feel free to come talk to us at our booth, and we can explore some of these examples. But the basic point is that you create tightly integrated use cases around DeFi that are using TIA and stake TIA as a token, and therefore you incentivize unlocking liquidity. So that's one incentive solved. And on the next slide, there's a second important group to care about, which is validators. What validators need, they essentially need a growth opportunity. And validators make money when the whole ecosystem is successful. But the current situation is when 70% of TIA tokens are with the validators. They're kind of interested in, let's say, maintaining status quo. So let's explore how we can use liquidity to change these incentives so that validators can participate more in the ecosystem growth. So on the next slide, here is the solution for it. So imagine there is a situation where a validator can still maintain their relationships with their community, with their stakers, but make their staked asset liquid, so that for the token holders, it's an opportunity to participate in the ecosystem growth. And that's possible if you integrate it into the LST protocol, so that validator position can become liquid without sacrificing the delegation for this validator. So once this is possible, validators can directly participate in the growth of the ecosystem, and the stakers do not have to choose anymore between their preferred validator and providing liquidity to the apps. So that's the second incentive resolved. And on the third one, maybe the most important one on the next slide, is the app builders. So app builders in the sovereign economy build sovereign rollups. And they care about sovereignty, means control of their stack, control of their environment. They care about liquidity access, and they care about participating in the value that is creating on the rollup very directly. And currently, talking about LSTs, theoretically that means in the world of 1,000 rollups, every sovereign rollup could have their own LST, because that's the most control that they can have over liquidity. But that also means that the liquidity gets very, very fragmented, and that kind of defies the purpose. So on the next slide, the possible solution for it is uh, is joining rollup liquidity with the large liquidity pools, which works as following. When a token, a liquid stake token is bridged to a rollup, on the rollup that can be a custom representation of the token that is native to the rollup, that is customized to the use cases that are present on the rollup, and the rollup builder have full control of this liquidity. But when the token is bridged back, it can participate in the large liquidity pools, and therefore we can solve for liquidity fragmentation as well. So this is the third group for which we solve the incentives. And on the next slide, that's the future that we are building towards. So we have these three key groups of the participants of the ecosystem. They're T holders, they're validators, they're rollups that are working together to grow the ecosystem and participate in its success. That's what Drop enables. And on the next slide, that's how we envision this blooming ecosystem with abundant liquidity, with many happy participants, and huge success. So we invite everyone to work together with us on this. And yeah, feel free to talk to us on our booth how we can work together on it. Thanks.
Okay, thank you, Mitya, for this great presentation. We'll go, I think, straight into the first panel of the day, which is about migrating to Celestia. I think this is one of my favorite panels of the entire summit, so I hope people will be watching this one. We have Mike from Lyra, we have Kenny from Manta, Zon from Nisha, Victor from Hashflow, and Nikita from Barter, and moderated by Ishida from Astra, of course. So a lot of portfolio companies here on the stage for us, which we always like. So yeah, give it up for this panel. I'm speaking. Okay, great. So, second try. So this is a panel about migrating to Celestia. In my opinion, one of the most interesting panels of this Modular Summit. So we're starting the day off right. We have Mike from Lyra, we have Kenny from Manta, Zon from Nisha, Victor from Hashflow, and Nikita from Barter, moderated by Ishita from Astria. So give it up for them, please.
Hello?
Okay.
It's on.
Okay. Let's get started. I'm Ishita. I work at Astria. We're building a shared sequencer. And we are going to be talking about building on Celestia, building infrastructure in crypto in general, and some other things for builders to think about. Before we get started, would love to get our panelists to do an intro of yourselves, your project, and what excites you to build in crypto.
Yeah, hi, everyone. I'm Kenny, and I'm one of the founders of Manta Network. We're the first general-purpose modularized L2 using Celestia for data availability. We've been building for the past 3 years, no, actually 4 years now, and a team of around 65 people all around the world. And what keeps me interested and continuing to build in this space is I think we're still very far from it, but I do believe that the future of finance has to be globalized, and that globalization requires some level of decentralization rather than some centralized authority. And so I think that we're slowly making steps to achieve that goal, and so I'm excited to be here.
Hola, friends. My name is Zon. I'm one of the co-founders of Inisha. Inisha is a network for interwoven rollups. We're holistically trying to rebuild how multi-chain networks should look, feel, and operate along the product, architecture, and economic stacks. All of the layer 2s on Inisha use Celestia for DA by default, and we don't use any other DA provider. One of the main reasons that I choose to work in this industry is I think it's just the most entertaining industry to be a part of. And I am terminally addicted to Twitter.com.
Hey everyone, Mike from Lyra here. One of the founders. We build decentralized derivatives, options, perpetuals, and structured products. Yeah, so we have an OP stack rollup that uses Celestia for DA, which is really good economically. We can talk a little bit about that later. In terms of why I'm excited to build in crypto, I guess, yeah, similar to the other panelists, it's a fun place to be. It's never boring. So, yeah, definitely keeps me up at night sometimes.
Hi everyone, my name is Nikita. I am one of the co-founders of Barter. Barter started as a solver on CowSwap over 1 year ago, and we are trying to solve a lot of issues that are happening in DeFi and blockchain, including efficient routing, liquidity fragmentation, and MEV, and many more. And I'm excited to build in crypto because, in particular, like in DeFi specifically, because this is such an important market niche. Like whenever we engage with centralized entities and centralized exchanges, market makers, different companies, there are always like unfair advantages and this lack of transparency. And DeFi, you know, addresses a lot of real-world problems, and this is why we feel like we should be doing this.
Hey everyone, my name is Victor. I'm one of the co-founders of Hashflow. For the past few years, Hashflow has been innovating different ways to build trading experiences for user-centric trading experiences to protect traders. And we're continuing our journey. There's more I'm going to talk about later today. But before that, the reason I'm excited to be in this space is because I feel like in this day and age, people are starting to lose trust in software providers and businesses and institutions. And I think that trust has to be rebuilt by, at first, very, very solid software. And I think we're going to start with finance. The work we're doing today is going to start with finance, but it can be expanded to many aspects of social life. And I think what we're doing today is going to be very important tomorrow in that regard. So very excited about that.
Okay, so let's do a few project-specific questions first. For Zon, Kenny, and Mike, could you get into why it was important for you to pick Celestia for your respective projects? And as more DA layers go live, do you plan on extending support to them?
Yeah, sure. So maybe I'll go first. So we were the first, I think, the first general purpose VM using Celestia, and this was during a time when, data availability was still very conceptualized, right? I think even today, in terms of liveness, right, only Celestia is purely mainnet, and there's a lot of options out there coming out. I think Avail, Eigenlayer, I don't know if Near's still doing it or not, but there's definitely a lot of optionality here, and honestly, I kind of see a trend of that availability kind of extending from the commodity generation of L2s into potentially the commodity generation of DA, and I think that gives a lot of opportunity for infrastructure players to, rather than sticking to one specific DA solution, looking for alternatives in order to ultimately improve resiliency, right? Even right now when we're using Celestia, one of the things is, one of the safeguards is Ethereum DA fallback. And what that means is essentially if there's any issues with any type of synchronization or uptime on the Celestia side, we still have full fallback to Ethereum, which is still an advantage right now, especially post-proto-dank sharding era. There's not going to be too much of a difference felt by the user financially when they're paying these gas fees. But in the future, I see this very much as an ecosystem of DA layers whereby you have various strategic movements of fallback such that if one goes down, you've still got 2, 3. Maybe you can arbitrage between the prices, optimize for user experience from the financial payment side, right? And so there's a lot of ways to play with that. And so I do see a world where various different DA solutions can be used in order to provide that best-in-class user experience on the infrastructure level.
Nice. Let me give you a quick rundown of Initia's infrastructure and then where Celestia fits in and why. Essentially, on Initia, we have a Cosmos SDK-based layer 1 that acts as the orchestration layer. It orchestrates interoperability, security, liquidity rewards for the network of interwoven rollups on Initia. We have the OP init stack, which is our optimistic rollup framework that's built in the Cosmos SDK. And then layer 2s that are full-fledged Cosmos SDK chains with EVM, MoveVM, and WASM VM on top. So pick your favorite smart contracting language, change everything about the rollup itself on the SDK side, and then through the layer 1, you're basically given everything you need. And so when we were building out this system, we didn't want to focus on specializing the DA layer or dealing with things like state bloat for the layer 1. It really acts as this orchestration layer. So for all of the rollups on Initia in the future, they need a secure, fast, and safe place to store this data. And Celestia is also a Cosmos SDK chain. So there's a little bit of brotherhood in there. And it's a very easy connection to start posting blobs to Celestia from basically any other Cosmos chain. And so with that in mind, as well as Celestia's NMT design, which allows you to basically have namespaces that are segmented out for different blob sections. For every one of these rollups on Initia, we can create a separate blob area and then post data for that specific subset. And what that allows us to do in the future is if there are things like fraud-proof challenges or scenarios where we need to go and fetch information for a specific rollup, the NMTs really help us when doing so. So we have a feature if there's a rollback where we can state sync from DA and basically rebuild an entire chain state. And we can do that just because of Celestia. And Celestia is, of course, the only live DA. One of the things we wanted to do when building Initia's architecture was remove choice overload. Right now, within the modular landscape, when you're thinking about launching a chain, you have like a goddamn billion options between all these fungible DA layers, like 10 interoperability solutions, all these oracles. And on Initia, we just basically enshrine one good partner from each of these deep into the chain's infrastructure. And then, people don't ever need to make these choices again because it just works. And so Celestia just works for us.
Yeah, cool, thanks. For us, it was really out of necessity. So we built Lyra V2 last year and launched a roll-up in December. I guess a little bit of background on derivatives are quite call data intensive, and we had a protocol which consumed just a ton of data. So when we started posting blocks onto Ethereum L1 in December last year, we ended up losing like 37, maybe 38 ETH in the month, and for us, that's just not viable. I don't think if you've raised 9 figures of capital, you can really run that sort of loss on a monthly basis. So we ended up getting connected with the Celestia team like just before Christmas, and we were like, we got a really big problem that we need to solve really quickly because we can't run this for more than a few months. So ended up moving over and starting to post blobs onto Celestia, and since then, pretty happy to report that we've actually been marginally profitable on the sequencer side. So it's been a massive swing from Ethereum L1. I think this was the pre-4844, pre-span batch sort of Ethereum, so it's probably not as bad now, but we are still seeing issues like recently, I think blob space saturated, and you saw big spikes on Arbitrum gas. So the question for us going forward is like, is Ethereum ever going to be able to actually provide a truly scalable, in-house DA solution? And I think the answer to that is probably no, and therefore, something like Celestia has a spot long-term in giving teams kind of the space they need to often innovate and add more features. Going back to derivatives again, they are quite call data intensive, and when you're trying to build a system that can rival a centralized counterpart, you're talking about like portfolio margining, 50, 100, 200, maybe 500 different instruments in one account. That's just too much data to post on Ethereum L1, even in the context of blobs. So yeah, we've been really happy since we moved over, and definitely looking forward to continue pushing the boundaries.
So with DYDX leading the charge here, and Lyra is another example, and on the consumer side, we're now seeing some NFT projects that have built up this momentum and now are moving on to their own roll-ups. Would you agree that the app chain thesis is finally coming to life? And what are definitive signs of this, in your opinion? Maybe we can start with Victor.
Yeah, I mean, it's hard to tell because on one side you have technology clearly getting there, right? With the entirety of the modular stack, you can now build things kind of like Kenny was saying. We have like Zom was saying, you have all these choices, right? And you can scale your apps right now somewhat indefinitely, and we see a lot of progress being made in the world of like ZK proof costs and data storage costs, right? So in a sense, yes, it's happening. Like people can build those things, can build chains per app. Now, is adoption there? Do we really have users for all these apps? Do we have issues with liquidity fragmentation? I think there are a few more questions to answer here, but I definitely think that the tech is moving in that direction. Now we just need to see whether these apps materialize in a space where there's active usage, there's practical cryptoeconomic security, and the ecosystem is still running. Like the reality is we still don't have the scale of users for these products that we'd like to have. So what happens over the next few years is going to test all these assumptions.
Well, we love upchain thesis. This is one of the biggest challenges that we personally have, and we are trying to decentralize order matching and routing and make it transparent. No one has done it before on chain, and that's why like Celestia DA is extremely important for us. Right now, market makers on Ethereum blockchain, specifically on the mainnet, have a lot of unfair advantages. Within like 12 seconds of block, the market can shift dramatically, and a lot of transactions have like SEX arbitrage. And then the exchange of data between nodes is generally like very slow. But with Celestia DA and more upchains and rollups, there must be like a way to analyze the state of different chains more. So we are trying to explore those different options, and yeah.
I could add something. I think if you can internalize a profitable sequencing model, like it's sort of naturally going to tend towards that end state for every project. The tension there is obviously with composability, and that's pretty important in DeFi because that's where a lot of the magic happens. So I think if we continue to see improvements in asynchronous composability cross network, cross L2s, and even cross L1s, I wouldn't be surprised if we don't end up seeing almost all protocols end up running their own app chains in some way, shape, or form. But that is still a significant technical challenge on the the asynchronous composability side. So yeah, it kind of remains to be seen. Obviously, with teams like Conduit and and others making it really easy to spin up an app chain or roll up, like you're literally doing it in a few clicks, kind of like you do with AWS. That's also lowering the barrier to entry, which is why we're seeing a ton more app chains than we've seen ever before.
I think there's just a natural tendency of people to want to own their own infrastructure, and this will always be the case. The app chain thesis was prevalent for the last few cycles and will continue to be so now. One of the big differences is the app chain thesis was first created by Cosmos. People would create these Cosmos chains, just for giggles, I think. You have 6 users and 150 chains, not really the best at how this infrastructure actually benefits your application. And there will be a natural transition into owning your own stack. Like once you become big enough, you don't want to leak any value. You want to build things that are unique directly for your customers and your user base, and you want to retain it all. And so I think the app chain thesis will continue to become bigger and bigger. And as we have this modular expansion that makes it easy for anyone to do so, allows people to use differently, will get better and better as more apps continue to rise. There's basically only 2 ways to scale blockchains. One is make a lightning fast, super scalable, single layer with shared state, and that's the Monad Hyper Mega ETH approach. And that would be like the dream, if that worked. I think if we want to scale to the way we all believe crypto will, we're going to need hundreds of monads.
And one that's an external factor. One in the externalities are more so currently growing. What we're looking at is essentially, as an application, there's obviously trade-offs, whether you want to do your own app chain versus deploy at first, at least, on an L2. And we've seen these types of transitions with applications where they start off a more of a general purpose L2 and eventually transition into their own L2 once they reach that max velocity. Right? Once they actually have the resource contention and they're starting to see that lag and it's impacting user experience, then you start seeing apps transition into their own app chain. But the question is, do you want to be your own app chain on day one? And I don't know, I don't think, at least not right now, the answer is yes for every single app out there, because you miss out on a lot of different advantages as part of like a broader ecosystem. One is much easier access to a user base, much easier access to liquidity, right? And so there's definitely different trade-offs strategically and in terms of go-to-market strategy when it comes to choosing an app chain versus choosing a general purpose VM and a general more broad ecosystem. But I do think that once you actually start testing out, growing, find that go-to-market, and really need to hit the ground for scalability, then eventually the app chain does come into play and would be a more favorable environment.
That makes sense. So for all of your current projects, when you were thinking about what and where to build, what were some of the other important considerations in terms of infrastructure aside from DA that you all had?
Well, I'm going to start because for us it's slightly different. So we didn't actually, when we decided to build somewhere, we really wanted to showcase the product, right? So we were the first ones that who came up with the RFQ model, right? So we wanted to showcase the RFQ model. Now, for us, it was all about liquidity. And I think similar to what Kenny's saying, like the reason you want to use an ecosystem that's already vibrant is because people are already going to be there, right? You have to think of your users. Who's your product going to cater to? And why would these people come to you, right? Typically because they're already there, want to check it out, and it's convenient for them to do so. So that's where we launched RFQ. We launched on Ethereum first. This was back in 2020, 2021. Ethereum was still where everything was happening, and people hadn't really launched these L2s yet. So there were very few chain options to choose from. But for us, building infrastructure, we're cognizant of the fact that from the user perspective, it doesn't matter. It doesn't matter what chain your app is running on. You don't even want to know. Right? Like for us to be able to transition to people who don't know, who are not software engineers, who are not technical, who just want to manage finances, we need them to not have to know. And with that philosophy, we wanted to be ubiquitous in that regard. So that's why we worked so hard on pioneering native cross-chain swaps. Then native cross-chain swaps between EVM and Solana and so forth, because to us, it's so important that all these app chains, no matter what builders do, have a shared liquidity layer, because if they don't, then that's going to make a difference for the user. And at the moment it makes a difference for the user is going to pick a solution which is more centralized, less trustless, and more likely to harm them in the long run.
I'll add to that we've been, our system is a bit now in order to connect routes and make it more efficient and utilize it to the maximum. But at the same time, it's all about community. And whenever we see a spike in user activity on any chain, like we recently expanded into Base, there is a lot of meme coin activity, and there are new unique protocols that are emerging in the ecosystem. And then we can do some of our magic in terms of optimization and connecting them and saving them some tokens. So yeah, user activity and liquidity layer, super important. And of course, we call ourselves an invisible hand of the market, and because the user shouldn't know like whether it was barter or where liquidity came from or how, we want to make this process as easy as possible in order to grow DeFi and onboard more and more users and steal them from like centralized exchanges.
Yeah, I would agree. I just think it's trying to make things as easy as possible for both developers and users. So on the developer side, EVM compatibility was a must for us. OP Stack gave us that. But then on the user side, like trying to get to an end state that does look and feel like a centralized experience. So like gas abstraction with Gelato, which we have on Lyra chain, using Coinbase Wallet as a service to give people other ways to log in a way that's still decentralized and self-custodial, and just starting to kind of knock through things like that to make the end experience for the user as smooth as possible. It's already quite difficult for people to understand DeFi, and then you get into derivatives and structured products, options, all these things. There's enough complexity there on the financial side. You don't want people to also have to jump through hoops just to actually use your product. So yeah, that's kind of how we've been thinking about it. Yeah.
So at Inisha, we had to rebuild a lot of shit. The basic goal was, rebuild all of multi-chain, which is a huge task, obviously. We had the Cosmos ecosystem to look at, but it is, just a horribly executed system of chains. It is ultimately the most flexible stack to build unique blockchains, but the way that it was just put together, came to light, the way things were orchestrated was not done effectively. And so we're, to a sense, building Cosmos Pro Max Plus, which is interesting because one of the biggest problems was you could build these unique blockchains, but you had to build a layer 1. You had to deal with the infrastructure that comes with that, the token that you have to create, the inflation that's associated with that, and then how do you connect to all these other blockchains? How do you ensure you have Oracle data? How do you get USDC and CCTP access? How do you use other VMs? What if I'm a builder of Move or a builder of Cosmosm or an EVM builder? And so essentially we rebuilt all those pieces, enshrined them into this system so that users who build blockchains on Inisha or app chains don't have to think about essentially anything but their own application, and then rebuilt the entire product stack around this. Because architecture doesn't just stop there. Your end users are not just the builders, but it's actually the users of these chains too. And that means, what does it look and feel like to actually connect to an app chain? How do you connect EVM wallets or Cosmos wallets or in-app wallets? We built a wallet ourselves that we think is best for the multi-chain world. How do you bridge around all these different blockchains? What does that experience look like? How do I get from point X to point Y, whether that be within Inisha's ecosystem or to an EVM chain or to Aptos or Solana or any of those paths? And then rebuild an entire economic framework around these things that really ties it all together. And so one of the things that we just announced yesterday that we just completed building was a Cosmos SDK module for the Layer 0 team. And what that does is it enshrines Layer 0 omni-chain messaging within a Cosmos SDK-based chain. And since all of the rollups on Inisha are Cosmos SDK-based rollups, essentially, despite launching or having EVM, Move, or WASM on top, all of those can come with Layer 0 compatibility, which means you can now onboard from literally any Cosmos chain or any Layer 0 enabled chain, which basically just is all chains. So stuff like that we're just slowly trying to work towards building a new and better multi-chain future?
We're a general purpose L2. I mean, EVM based, right? So it's kind of boring to explain to you why we deployed on Ethereum. But I think one really interesting point for you guys to think about as you figure out where to deploy your applications is, there's obviously EVM, right? Solidity, tried and true bread and butter of the Web3 space. There's alternatives that seem to be stickier, right? Like such as SVM. But apart from that, right, there's not really any other options. And I just want to point that out because there are a lot of ecosystems that you can be a big fish in a small pond, but the question is, are those trade-offs essentially worth it? And I think if you look across the timeline of ecosystem development, probably since 2016, 2017, with the explosion of forks of EVM and other Turing-complete ecosystems, what you essentially see is a lot of great experimentation that kind of has this boom and bust cycle. And ultimately, the resiliency across all those years have been on Ethereum and EVM-based chains because of the flexibility on the app side. If an L2 goes down, the apps on the L2 will, sorry, when I say L2, I mean specifically on top of Ethereum as an EVM. The apps on the L2 might not suffer as much as if Terra went down, right? I mean, I'm sure you guys are, I don't know how many of you guys don't know Terra, but for those of you that don't know Terra, it was an amazing, amazing ecosystem that had so much promise that just disappeared overnight, right? And this is the reality for any type of these fringe deployments beyond these larger ecosystems such as the Ethereum ecosystem. And so just something to think about from your perspective as well, because if you are building an application, deploying an application within an ecosystem, your application success is not just tied to your ability to drive users, go to market, et cetera, but it's also going to be tied to the success of the ecosystem itself, right? So that's something that I think teams starting off tend to underestimate. But it is an extremely important and major driving factor in your ability to fundraise, in your ability to acquire users, in your ability to keep users, drive liquidity, et cetera, yeah.
So as you were saying, they're going for just liquidity in a thriving ecosystem.
Goal, right? It shouldn't be, oh, I'm a Cardano maxi, so I'm going to build on Cardano and then expect 100 million TVL, right? Like the expectations don't really align there. So I think it's a rabbit hole that a lot of Web3 projects tend to take, but one that I would kind of stray away from and focus more on how do I acquire users to prove out that my product is actually valuable versus how do I over-engineer this and then find out later that no one wants it.
Does anyone else want to add to that?
I think there's just want to kind of reinforce the point that you're making. I think there's this thing that people tend to do to try to gain relevance, which is try to understand what is going on in the market. What are people talking about, right? Like they're talking about, okay, ZK right now. This is a bad example because ZK is objectively a great thing, but people tend to kind of stick to trends in order to try to attract TVL, try to attract users, and try to attract narratives. And the reality is that, again, if you're trying to build something that holds value long term, the current narrative should not be evaluated based on how many people are talking about it. It should be evaluated based on its soundness, right? So as a founder, as a developer, you have to trust yourself to evaluate objectively the soundness of the current narrative and to ask yourself, do you really think this is going to be a thing in 10 years? And if you think that it's not going to be a thing in 10 years, then I would just stay away and find the thing that is actually going to be there.
Okay. So Nikita, as it relates to some of the topics that were brought up about liquidity fragmentation, so in the last year, you all have been expanding outside of CowSwap and expanding to other protocols and experimenting with a few different things to solve this liquidity fragmentation problem. Could you say a little bit more about that?
Yeah, definitely. Actually, like this discussion made me thinking that you know, liquidity fragmentation can be good, and can be good in terms of that it brings more innovation, whether there is like AMMs competing with other AMMs, and or whether there are chains that are competing with each other. Moreover, when platforms like ours exist, we try to unite it, and like a very simple example would be if there is like a $10 million Uniswap pool, or there are like 10 AMMs, different AMMs, and $1 million pool in each one of them, it would be probably more efficient to split across, you know, those 10 pools, and the user would get a better rate. So like there are some pros of liquidity fragmentation. However, of course, when we talk about efficiency, you know, this liquidity has to be very competitive, and it has to be composable. So, you know, it should not be laying on some kind of L2 where no one else has access to it. And we need better infrastructure for that. We need more bridges, we need more systems that communicate with each other. In terms of us, yeah, we started on CowSwap because CowSwap is an amazing sandbox where, you know, it doesn't matter like which solver or which party gets to execute a transaction, as long as user gets the best rate. And we've been trying to achieve it, and the competition is fairly transparent. So yeah, we've started expanding, and again, as I was mentioning before in the beginning of our panel, we are always eyeing chains and ecosystems that have a vast amount of order flow, active trading, and where we can, you know, make a big improvement with our tech. Yeah, we've also had a partnership with Hashflow recently, which we are very happy because RFQ liquidity is superior liquidity on chain. You know, it's has some advantages even to centralized order books, and yeah, like we are super proud to be working with you guys. I'll stop here.
We're proud to be working with you too, by the way.
So on top of liquidity, infra builders have to fight for developer and user attention, which is hard to come by. So how are you all thinking about building a strong community that converts to a dedicated user base? And what factors do you weigh highest in building community? Do you want to start, Kenny?
Okay. It's a tough question. I think it's a very tough question because the reality is there's not too many users in the Web3 space. I was actually on a panel, I think 2 days ago. It doesn't matter. I don't know why I'm thinking so hard about the time, but there are about, I think, 4 other L2s on the panel with me, and it was a whole conversation about L2s and why there's so many and should they exist. And then I asked the audience, which was, I think there were probably like 100-something people in the audience. How many of you guys actually interacted with an L2 in the past day? And 3 people raised their hands, right? So it's like a restaurant with more waiters than customers, right? Like we had more L2s on stage than actual users of L2s in the audience. And I think that's not just an L2 problem. I think that's a general Web3 problem, right? Like the incentives are truly not aligned with the intention of the builders, right? Like I want to build an amazing game that people really enjoy, but you end up becoming the next airdrop farm, right? Like it's, you think for some reason because everyone else is doing it and it pumps their numbers and it makes their KPIs look good, and all of a sudden they have 1 million wallet addresses on their, you know, app or something, then you got to do that too, right? And it drives us in this wrong direction that incentivizes and encourages Sybil attacking, botting, and all these other things that ultimately don't drive real users. It just keeps us in this echo chamber of, you know, bots that continue to either congratulate, which, you know, kind of feeds us in the wrong direction, or shame us, right? And so I think in general the problem is there's not enough users. And so, you know, it becomes a very hard task in general to think about, like, how do you quote unquote build community? And I think the answer to that also is, unfortunately, it depends. It depends on the life cycle of your project, right? Like a pre-TGE project versus a post-TGE project has completely different strategies in terms of how to build community. This is coming from firsthand experience in being, you know, both. And so it's a very nuanced answer. I think one of the things, though, right now is the question is, when you're building community, how do you define community, right? Do you define it in sheer numbers, or do you define it in sheer users, or do you define it in sheer token holders? Because all of those have completely different strategies in how to do that. Over at Manta right now, because we are a post-TGE project and we are competing in a heavily contested space, right? Obviously, L2s are heavily contested. And we're all going up against Solana now as well, so whoop-de-doo. But one of the things here is, I think the only tried and true sort of category, other than DeFi right now, is probably memes. So we're definitely tackling that. Actually, so Bonk is moving over their community to Manta as well. We just made that announcement yesterday. And so that's one of many different actions that we're taking. But in terms of community building, right, like I just kind of wanted to leave you guys some bits to think about because, yeah.
I think it's all about opportunities for wealth creation. That's how you build long-standing communities in crypto. You read up technology. It's not a thing that you can ever promise or properly deliver. And one of your main goals should be aligning early users with high growth potential applications and ensuring you support as many projects as you can that have the potential to do so. Because that's how you actually build communities that stick around within crypto.
I want to push back slightly on that because I think opportunities for wealth creation is very relevant for, I guess, for you guys, right? Especially because we're kind of focused on the DeFi sector and decentralized finance. Finance is for the purpose of wealth creation, hopefully. But beyond that, right? Like when it comes to things like GameFi, SocialFi, right? Like ironically, the underlying value proposition currently is wealth creation, right? Like I don't think anyone uses friend tech because they love friend tech, right? Like everyone uses friend tech because they can trade keys and arbitrage and all that other stuff, right? And so I don't think that in those scenarios it does create actual community. I think it creates a little bit of temporary relevance.
Sure. I think temporary relevance is fine as long as you can have a snowball effect that's going to lead to other opportunities. Right? Like if you look at, you were talking about Terra earlier as being one of the most successful communities. The reason it did that was not only because of Luna, but all of the ecosystem projects that launched, that started low, that gained communities early, happened to gain relevance and grow over time, making these early users a little bit of cash, but also putting them into this community where they can be shared members of other communities. Like things like memes are amazing for garnering attention, but I don't think they build long-standing communities that are value additive to the products that we're trying to build long-term. Yes, they might help with the number of posts on Twitter related to, Jenny the dog, which is one of our mascots, but not necessarily the best when it comes to actual on-chain users that are contributing to what we're trying to build.
But I think when it comes to wealth creation, right, like I think that's great for marketing, right? And I think temporary relevance is an amazing step for marketing. But I think the problem, and this isn't like an issue that's specific to any of us, right? I think it's an issue that's more pervasive across the entire Web3 space, is that when we talk about community, I think we conflate that with marketing strategies and temporary relevance quite often. But the reality is that that temporary relevance does not build strong brand commitment, right? And I think we see that a lot across, even DeFi projects. And this is like, if you can offer the best momentary yield, you capture that audience. But they're not going to say, oh, I'm going to stick with, I don't know, Lido, even if Lido only gives me 1% and everything else gives me 4%, right? I think like that movement shows or indicates that, the brand loyalty, which is truly core to the community, is not mature, but rather the marketing for the temporary relevance is extremely powerful as a tool through wealth creation. Yeah.
We are actually at time, so thank you, everyone.
Thank you.
Thank you.
Okay. That was an amazing panel, as predicted. We're going straight onto the next talk, where one of my favorite founders, Bunny, is actually going to talk about the search for a unified multi-chain and a multi-VM world. And yeah, enjoy.
Hello, everybody. My name is Mauricio, also known as Bunny or Conejo Capital on Twitter. I'm the CEO of co-founder Andorra. We're actually also joined here by the two out of the four other co-founders of Andorra, Ann, Chai, and Silicon FX. So also you can go chat with them after this talk. Today we'll be talking about something that is actually it's a bit of an introduction to three really big news that we have on Andorra as a product, and also as something that might be very interesting to you if you're launching a VM, an alternative VM, a new VM, or also starting to innovate within the EVM landscape. Today we'll be talking about discovering the new infinite frontier. Search the unified multi-chain and multi-VM world. As previously mentioned, I'm Conejo Capital on Twitter. Our company's Twitter account is have a really quick recap of modular acceleration, how this is a 0 to 1 moment. We've all experienced it. That's the reason why we're all here, and that is why we're having a Modular Summit. Then we're going to dive into the Infinite Garden, just a really quick glimpse into it, but also into how this does not equal that we're going to experience a limitless EVM. We're actually starting to we're going to explore the new infinite frontiers, multi-VM worlds, how stylus, fluent, and movement are all innovating within the multi-VM landscape. And ultimately, we'll look at the Infinite Discovery Engine, which is where we'll announce three really big news from our team. So let's start. So modular acceleration, 0 to 1 moment. One of my favorite graphs that I've now used, I believe, 5 times across different conferences is the one by in which we're able to break down their different roll-up economics that we're experiencing as an entire industry. Very simple. Let's say equation, profit equals L2 transaction fees earned minus L1 call data, blobs, and verification costs. There is a little bit of nuances on, maybe they're paying a little bit more of the sequencer fees or the roll-up as a service. Maybe they're running their own sequencer. Maybe they're entering into agreements with different infrastructure providers. But regardless, this is the on-chain profit that we're able to at least guarantee that they're making. So if we're able to elaborate a little bit more on this, we look a bit more closely. We see that in total, as of last month we made, as an entire cohort, 4.1K of ETH, this being denominated into $15.32 million as of yesterday, as of the time of making this slide and updating it, which feels pretty good, honestly. As an entire subcategory, we are starting to see that actually running rollups is quite profitable. We see the teams are Arbitrum leading the charge, the teams at Base, OP, Mainnet. We are starting to see even teams starting to subsidize a little bit their own running of their chain, like let's say the Polygon CK VM, which actually is at a negative loss of ETH with minus 32 ETH as of last month. You can find more about this on Dune.com, Infinite Tables, or just search up rollup score economics. So now we have this infinite garden of the EVM. We're starting, but however, this does not equal a limitless EVM. Quick recap on the Infinite Garden, how we got here. We got here thanks to all the innovations on data availability, thanks to Celestia, EigenDA, ABSs, Ethereum blobs, EIP 4844. This made it infinitely cheaper to actually be able to start working on rollup as a service. We have shared sequencer networks start showing up. The team is Astria, Espresso. You can also chat with them. You should definitely chat with them if you're looking to launch your own rollup and actually have cross-chain interoperability. Then our sequencer interoperability. Then we have rollup as a service teams. Of course, they are honestly one of the most crucial ones within all these networks. We have the teams at Ledger, Gelato, Gateways, rollup as a service offering, Presto, Caldera, and Conduit. All of these teams have also become hyper-specialized in some of these SDKs. Some of the ones that we're seeing right now flourishing quite heavily are the Arbitrum Orbit and Nitro SDK, the Superchain Optimism OP Stack SDK, Polygon CDK, as well as the most recently announced, as of this month, CK Sync's Elastic Chain. Now, interoperability solutions related to this. Quick recap, we have a Squid router, which works closely with the Axor team, a cross protocol, which actually is one of the major providers for all of these integrations that be effectively aggregated across, such as, let's say, Socket, Decent. We also have, of course, Hyperlane, a more open source solution for being able to create interoperability from your rollup, as well as with wallet providers that are a lot more personable, a lot more easy to onboard a Web2 user by letting you create embedded wallets with, let's say, Face ID, Google accounts, and whatnot. And then we have, of course, our bread and butter for every rollup, which are index data subgraph providers, token NFT APIs, as well as multi-chain search engines, and maybe a little bit more with GoldSky, SimpleCash, and Dora. So now we are starting to hit the limits of the EVM. What are some of these bigger issues? I could dive into most of the technical discourse onto why EVMs are not necessarily the best, but just to keep it very straightforward, we're starting to see even some simple UX issues in which
for Modular Summit, or you're just trying to order coffee, it all kind of requires internet, and it all kind of works on your phone. And that enables people to change the way they interact with each other. So, what does the future hold? Before we dive into that, I want to talk about one of my favorite applications of the modern technology stack that is so ubiquitous today, which is finance. I remember how excited I was the first time I downloaded Robinhood. I was so excited I started buying stocks I should have never bought, right? And I lost a lot of money on. However, that's not the point. The point is that this created financial freedom. This ability to write software and deliver it everywhere created these markets that people never thought existed. And fast forward to today, we're able to trade cryptocurrencies. How cool is that? All these exchanges that we have today are taking assets that are literally created days before. They're putting them in circulation. They create liquidity for them within hours, and people have access to them. That's how you're trading your favorite coins. Every day, whether it's Dogecoin or it's Bitcoin or it's Shiba Inu, it doesn't matter. These guys are fast. They offer a wide variety of products. They have amazing user experiences. And most importantly, they allow you to have access to the finance that you want, right? How do they do this? How do they build such a great experience that you always have access to? Well, naturally, they use the modern stack. They deploy to the cloud. They have applications. And typically, they use a very monolithic approach that allows them to scale and optimize very, very quickly. Typically, every single performing exchange has a central limit order book, also known as a CLOB. This is the thing that you see when you go on Binance and you see red and white kind of orders matching in a V-shaped structure. That's your order book, right? They also have a matching engine. As you're placing orders, they get matched against other people's orders, and you're trading coins, right? They take custody of your assets, and they also run their own ledgers, which are settlement models. Because everything is so monolithic and centralized, they allow you to have a really, really good user experience. However, this is real money. And with real money comes real risk. There are definitely risks associated with centralized exchanges. They manage billions of dollars of capital, and we all know what happens when you have too many billions of dollars. You tend to spend them on things. They're not exactly the most wise things to spend billions of dollars on. And sometimes you lose them. So as a user, it's kind of hard to trust these entities because of the lack of transparency. You're putting your money into an exchange, you don't know what they do with it, you trust them, they have a good reputation, but maybe one day they start telling you that they lost $8 billion, you can't take your money back, right? So there must be a better way. We have to think of a better way. And I'm here to talk today about the Exchange OS, also what we're calling the provable approach to building exchanges. So the idea here is that instead of keeping them as a monolithic structure, we make them modular. And with modularity and provability comes safety and user trust. However, there's a big caveat here, which is we can't compromise on user experience. Making things harder, making things slower, making things impossible to use, requiring users to change the way they do things every day when it comes to their money is not going to attract them. So it's very, very important that we preserve the user experience. In a provable world, we think of exchanges as two components. The first one is the service layer. You can think of this as the order book and the matching engine. This has to be state-of-the-art. It has to land on your phone wherever you are, whenever you want to use it. It has to be quick. It has to have access to a lot of liquidity. It has to allow the current actors on centralized exchanges operate the same way they've been operating for many years now, so that they can offer you the same suite of products that you want. However, it has to also be safe. So we're splitting the settlement layer, which involves asset custody and the actual exchange ledger, into a modular component powered by zero-knowledge technology and a data availability layer. We call this the Exchange OS. Why do we do this? Why does modularity work? Let's think of a computer. A computer, is the simplest form, is a state machine. It has, at abstract layer, two big components: computation and data. By splitting them, we allow the very, very bright minds of our industry to work on these things in parallel. With zero-knowledge proofs, you can actually reduce verification to constant time, no matter how complex the computation behind it is. So therefore, as hardware advances, as we get faster GPUs, faster CPUs, better machines, we can make ZK-proof computation cheaper. We optimize that by itself. Separately, on the data side, we have more and more data availability solutions. We have Cosmos-based solutions like Celestia. We have eigenlayer AVS-based solutions like EigenDA. We have Avail. All these things are amazing tools that are going to be used for the years to come by different apps that are building their own experiences. We want to split them up so that these teams can research independently and benefit the exchange ecosystem as breakthroughs are made. But this is hard. And the reality is that if you look at centralized exchanges today, they have quants that are veterans in the game. They have devs that are veterans in the game. But learning an entirely new stack that they have to trust for billions of dollars is really hard. So therefore, we make it easy for them. Exchange OS is not just meant for new exchanges. We want Exchange OS to be used by new exchanges, but we also want it to be used by exchanges that want to improve the trust assumptions that users have to make. Essentially, think of Binance being able to use this to prove to their users their solvency. Think of any other exchange being able to do so while preserving the amazing experience that we've perfected over the years, right? So then, why provable? Well, again, user experience is the same. People don't have to do anything else. They don't have to learn math overnight. They don't have to learn how to code, not even JavaScript. They don't have to do anything. They use the exchange the same way they've been using it for the past few years. However, they cannot get rugged. Sounds like a win-win, right? Well, why now? It's important to mention that the past year or two have been pivotal in zero-knowledge cryptography. Things have gotten cheaper. A lot of things have launched in the past year or so, kind of battle testing a lot of these techniques that we use. And based on the research that we did, or we've been doing for the past few months, we've determined that technology today is advanced enough so that trades as low as $1 in volume can actually be profitable in a provable world. This is big. Before this year, we didn't have this. We didn't have the tooling. Everything was expensive. NVIDIA didn't have the hardware they have today. And the best news is that this is getting even better. So if $1 is profitable to 10 cents is going to be profitable within the next year or two. So this is the right time to show the world what it's like to build something that has the same user experience, allows us to onboard people that have been in a space for a while that do not know what crypto is, while maintaining costs and giving them better guarantees. So, kind of moving on. The future, the next paradigm, in our opinion, is provability. Finance is only one industry that requires people's trust. There are others, like healthcare, like politics, social media. We see all the crazy stuff that's going on in the world today, and we see how confused people are about what to use. What's preserving their privacy? What's not preserving their privacy? Who's giving them the correct information? Who can they trust? So to us, it's not just about how fancy our machine learning models are. The way we're thinking about this is the internet created communication, our ability to talk to each other. Cloud created opportunities for software creators. It made their lives better. Mobile made lives better for software consumers. And the missing component is trust. Software creators are going to use ZK, zero knowledge, improvability, to have consumers trust them and to create a system that across the board has checks and balances. And we're excited to be some of the first to build this in finance. And by we, I don't mean just Hashflow, I mean the entire community that has been building crypto for a long time. And we feel like the beginning of a more free financial world is in sight, and it's just going to be paving the way for how software is built in the future. Now, the question is, how soon? Are we talking research? Are we talking a month from now? Are we talking 2 months from now? Are we talking a year, 2 years? Is this just ideological? Well, I'm just going to end by saying this. The first provable exchange is going to be with us within the next few months. And I'm so excited that we're going to be able to show the world what can be done in a safe, profitable manner with amazing user experience for what we think is going to be the future of crypto trading. Thank you so much for having me.
Okay, thank you for that exciting presentation, for sure. Next up, we have a few talks about rollups. First one from Henry from Penumbra, talking about dark rollups. I'm wondering what that's about, so we'll see.
Alrighty. Hello? Great. My name is Henry. I'm the founder of Penumbra. I don't know when we get the, there we go. Today I'm going to be talking to you about dark rollups, and maybe we will figure out what those are together. So this is a fun word that's meant to kind of draw attention to what I think is an interesting new design space for rollups. So my talk today is actually not going to be primarily about Penumbra. If you already know about Penumbra, then I'm sure you're excited. If you don't, you should find out. But for this talk, what I want to do is try to broaden overall design horizons, right? So my thesis is that right now there's sort of two concepts that are mashed together on top of each other, just kind of by the accident of path dependence, and that we can do some interesting design thinking if we take those two concepts and we pull them apart. And the two concepts are data availability and data visibility. So data availability, by this point in the conference, is probably a term that you've heard. The idea is that you want to build a system where people can get a guarantee that some data was made available to all of the other participants of the system. Data visibility is about, okay, who actually gets to have insight into what that data means. And the reason that I want to pull these things apart is because when you build a public blockchain, these things are necessarily the same. There's no notion of control over information. But once you have a notion of control over information, you can ask, should these really be the same groups? Should you differentiate between these two sets of users? So looking at this kind of very conceptual modular picture, the basic idea that we're working towards is first we have a bunch of individual rollups, and they can post data to some common, scalable data availability layer. And that layer, here at Celestia, there could be others, is going to be optimized for just doing that one thing and scaling at it very, very well. So we want to build one system that can give these global trust guarantees and scale to massive size by having a very specialized sort of limit of functionality. Then each of those rollups gets to form their own interpretation of that data, and they don't have to worry about all of the consensus properties, because they can know that they all are operating on the same view of what information is out there. So this is a cool idea, but one thing that is actually not required is that the data that is posted to this underlying base layer should actually be visible to anyone beyond the rollup participants. And again, this is kind of this like path dependence for public blockchains, where generally it's assumed that, oh, if someone is building a rollup, that means that the set of participants should be the entire world. But this doesn't necessarily have to be the case. And if the data that is published to this underlying DA layer is encrypted, then you can have some really interesting designs where you're separating between who those participants in this specific rollup are, but still allowing them to take advantage of this global security layer, the security guarantees of this like global common data availability layer. So what I would suggest that people do is actually look to shielded chains for design examples of how to do this. And here's a little bit of a side point that I want to make is, in the blockchain industry, a lot of the time people get kind of like pigeonholed into narratives, right? People have these sort of narrative sound bites that let them structure like, oh, this thing is like this is like that. And that's kind of a convenient shortcut, but it can actually kind of give people a bit of a tunnel vision. And sometimes if you defocus your eyes just a little bit and you look out at the structure of things that appear to be very different, you might notice that there's actually a lot of commonality. And so if you look at a shielded chain like Penumbra or Zcash or Namada or Alio, these are not roll-up centric, or they're not branded as such, and they're not modular. They're usually monolithic systems because they're built to try to achieve one thing. But if you take a closer look, you can actually see a lot of interesting commonality with this sort of roll-up centric design vision. So in a shielded chain, you have some kind of private base layer, and you have shielded transactions that are posting encrypted blobs and proofs about the validity of that data. And each of these clients is going to sync its own view of the data that it is able to see. Right? So if I have my wallet, I get to view my transactions, but I don't get to view yours. And there's not going to be some server that is just going to be compiling all of my data. I have to do that on my own on my client. And in this case, not only is it not required that there's visibility between these different clients, but actually like the whole point of why you would do this is to try to not have that. But when you look at it this way, you can kind of think of each individual user as having their own little personal rollup. And that specific example is something to kind of dig through and look at in detail. So we're going to look at how shielded transactions work from this sort of roll-up centric view. The first kind of conceptual idea there is that on a shielded chain, you want to have composable state. So rather than having one big global tree of state, where each transaction can basically modify anything, you need to have a system where the state is split up into many different fragments, and each transaction declares certain input fragments that it consumes and produces some new output fragments. And again, with this sort of defocusing our eyes and looking at similarities, you can see also that there's kind of a convergence here between kind of a UTXO model, or if you have a global state model with access lists, we'll kind of end up converging to the same place. But composable state. Why do we need that for shielding? We need it because what we're going to do is make all of the state transitions private by moving all the actual data off the chain and onto an end user device. So instead of actually having this big tree on chain of all the raw state, we'll just have state commitments. And instead of each transaction having an explicit description of the state change that it makes, we're going to wrap that all up in a ZK proof that lets each participant certify to everybody else that they did their state transition correctly. And what this means is that the execution is actually moving off-chain onto the end user device, and each user has their own little personal roll-up of their own account data, their own UTXOs, their own nodes, etc. And that has, so let's look at this like slightly in more detail of like, here's a shielded transaction as its own little micro rollup. We have a ZK proof that provides trust. We have some commitments that are going to bind the output states. And we have a way to mark the input states that have been consumed as being spent and no longer being able to be used. This is done with a technique called nullifiers. And the only important thing there is that there's a way to do this so that you're not revealing precisely which state you're consuming. The interesting thing, though, is each of these shielded transactions is going to have its own encrypted payload blob to try to make the resulting state data visible only to the recipient. So this transaction that is being submitted is it's almost like a sort of monolithic bundle of a little micro rollup where it has both the updated state root and also the opening of the data that was rolled up that's encrypted so that only the recipient can see it. And you could ask, like, what is, even though this shielded transaction system is not conceptualized in this sort of roll-up language, what's the meaning and importance of data availability here? Why is it important to know that data was definitely published, even if it's just me making my own internal transaction? And the reason is that these commitments are opaque. So if I ever lose this plain text opening of like what was my state update, then I'll never be able to spend those funds ever again. And so even in this single player context where like I'm making my own transactions, it's actually quite important for me to get some kind of ironclad guarantee that the plain text data that I'm not revealing to anybody else was actually securely stored somewhere, right? Like what happens if my laptop crashes like right after I make the transaction and submit it, but before I save that locally? What happens if I need to restore on a new device? All of these problems that show up in a, this big like open world Byzantine fault way, if you can solve them there, you can actually solve them much more usefully in the single player context. So that's kind of this like classical shielded transaction picture. The connection with, okay, what does this mean for rollup design probably is still a little bit unclear. So the next example that I want to show that I think points in a more interesting direction for what are some sort of first use cases for building rollups that use global DA layers for private participation is actually the idea of trying to build shielded multisigs. So if we go back to this diagram, what happens if we want to have joint control? This is pretty common, like Gnosis Safe is probably one of the biggest products that people use. But that requires that the participants in that joint custody are all public. And when they want to sign things, they're going to do that by just posting signatures. And so you're revealing to the world a lot of information about who has custody over those funds. And that probably isn't actually wise, right? Like if you have joint custody of some kind of treasury, you probably don't want to be declaring to the world, like, here's the .eth address of like the person whose house you can show up at. But once you say, we're going to do this privately, we're going to use threshold signing, where we're going to produce a signature that's indistinguishable from any other signing method, we have this problem that all of these signers need to coordinate with each other. And for Penumbra, we actually built a threshold signing tool. It's kind of our like minimal proof of concept, but it's intentionally scoped to kind of point or punt all of the complexity of that problem out. So it just works on the command line, you copy paste messages or whatever. And we've been thinking about what does it look like to try to turn that into a coherent product that people could actually use without giving up any of the decentralization aspects or the security aspects. So our thinking here is like, okay, how can you have threshold signers who are coordinating off-chain amongst only their own little committee, but we want to have certain properties. We want to, if they were all online, then this whole problem would go away because you could just do a direct peer-to-peer messaging. But the assumption of everyone is always online all the time is just not realistic. So if you build a product like that, you're not going to have a good time. The other requirement is we want to have all of the signers having a consistent view of what messages other signers have sent. If you think about the experience of using a safe, for instance, you log into the front end and you can see here are all the new signing requests. And there's not a possibility for people who are part of that group to be confused about what the set of active proposals is. Everybody gets to see that. And if you're coordinating off-chain, now you need a way to coordinate all that. So that state that you have to synchronize between all these signers. And the last and kind of subtle thing is we want to have signers be able to recover their shares of the key from their own seed phrases. Right? If you have people have talked a lot about the UX of seed phrases or whatever, but one thing that's genuinely very good about that design is as long as you remember that one secret, you can deterministically recover all of your data. But in a threshold signing setup, the participants have control over a joint key. And so their individual shards aren't necessarily going to be derivable. So we need some way for people to basically back up a list of here are all the committees that I've ever been part of, and I'll encrypt my key for that committee to myself so I can recover it later if I lose my computer. And that way you can recover this kind of, the seed phrase is enough to get everything. You're kind of aligning this system with people's existing expectations. And part of the thinking of how do we solve all these problems is that we don't want to have any kind of central service, right? So we don't want one of these individual signers to be dependent on a specific service run by a specific company. One of the things that we've done, they're restricting the interpretation of what those messages mean to only be the members of their own little committee. So I think this is a really interesting thing to think about. Dark rollup, right? So this is kind of a fun word. We can invent our own meaning for it and design new kinds of rollups. But that's the
Okay, we will continue our talks about rollups. Now we've learned what dark rollups are. We'll learn about rollups in the wild from Andrew from Conduit. So give it up for Andrew.
Hello, folks. Today I'm going to be talking about why launching your own rollup can save your startup and might let you build into product market fit. A little bit of background on myself. I'm the founder of Conduit. We're a rollup native cloud platform. We make it really easy for anybody to spin up their own rollup. We operate it, maintain it, upgrade it, and basically give people their own block space. Today, we do over 50% of the gas a second across Ethereum. We secure over 1.2 billion in TVL, over 30 mainnets deployed, and over 20% of the transactions sequenced on Ethereum are actually going through Conduit sequencers. You can see some of the great teams that we work kind of at the bottom here. So before diving deeper, just establishing kind of the background, what is a rollup? I'm not going to get into a semantic debate today. I think rollups are really just off-chain compute that settles securely on-chain. And there's kind of a gradient of security models here, depending on the stack that you choose and what DA you might choose. But generally, what we're interested in here is the ability to verify some compute off-chain, kind of on-chain. And rollups enable you to customize this compute to your application. There are kind of various configurations and customizations you can do. You can do things like use a custom gas token. You can use modular DA for cheap variable costs. And generally, we're seeing this form factor kind of take over as, it's kind of very similar to AWS, right? You can spin up your own EC2 server. You can increase the memory. You can increase the CPUs. And we're starting to see that for rollups and crypto-based compute. So before rollups, it was pretty hard to build on-chain, right? So you had a couple of options here. You could deploy on a shared layer. So like Ethereum, kind of in the early days, CryptoKitties was kind of an application that kind of took off. But when DeFi kind of made it to Ethereum, CryptoKitties got priced out, right? So no one was going to pay a couple of dollars to play CryptoKitties game. And so they either had to migrate to a layer 2 for cheaper fees, or they may have even needed Explorer creating their own alt L1. And so that's kind of the evolutionary path that we see for applications, is they first deploy on a shared layer. If they kind of take off, they run into vertical scaling limits. So a very common one is they're limited by the amount of gas that they can do on-chain, and they're limited by kind of how expensive those fees can be. And since blockchains are so limited generally on shared layers and compute today, you kind of design your application around that, and I think that's kind of what we've seen in today's market, where many of the applications are DeFi-based, where users are willing to pay very high transaction fees. And I think if we're going to see crypto succeed, we're going to need to see an abundance of on-chain compute, where on-chain compute is very cheap, and you can start to think about building kind of more expressive and interesting applications on-chain. I think the fact, any of these options, you either kind of run into scalability limits, or you kind of, frankly, just run into, kind of upfront costs and delays in kind of getting your application to market. After rollups, I think prior to something like Conduit, even running your own rollup was difficult. It was primarily the framework teams that, for example, like an Optimism and an Arbitrum, that were kind of running these rollups, taking millions of dollars of research and investment. And we kind of helped them navigate that. They eventually ended up deciding to be in Arbitrum Orbit L3. So that's in L3 that's settling to Arbitrum 1. Couple of reasons for that. One, I think it makes settling very, very cheap. So instead of settling to Ethereum mainnet, you get to pay L2 costs for that. Two, the Arbitrum Orbit stack is really great for games. So they have very fast block times, 250 millisecond, versus say, 12 seconds on Ethereum mainnet, and that's important for things like UX, where you kind of need a fast confirmation time. And then finally, the key point here is really internalizing the fees. And the Orbit stack makes it easy to recycle that. And so Proof of Play ends up powering a lot of the in-game actions. And so when you're playing the game, and let's say you get like a loot box, all of that is on-chain, kind of powered by their relayers. And it was important for them that they're able to essentially recycle the sequencer revenue back to their game relayers in order to keep the game kind of powered. And so we built this kind of performance-based dashboard for rollups called rollup.wtf. We're big fans of like L2Beat, which kind of show the security trade-offs, but we didn't find anything that was really showing kind of real-time performance metrics. You can go to this site today, and it'll show you kind of what these chains are doing. Proof of Play is consistently at the top in terms of gas per second. And so they're hitting 40 million gas a second. That's roughly 20 times what Ethereum does, and 5 times what Base does. So it's a pretty significant kind of jump in the amount of compute that's happening, over 35 TPS. And it's really starting to push the limits of on-chain. And right now they have 5,000 concurrents. There's actually a 1 to 2 hour queue time to get into the game because pushing the gas a second higher today increases latency. And so in order to kind of push things further, they want to go multi-chain, right? And so what does it look like to have a game where you can actually shard the users across many different instances of that? And what are the problems that come up, right, around multi-chain kind of interactions? And so that's something that we're currently exploring with them, and we're kind of excited to kind of showcase down the line. But I think it's a really interesting application of rollups where, on any shared layer, this would have broken the bank. And I think on their own chain, they've kind of converted what would be very expensive on-chain costs into cloud costs on Conduit. And I think that is really like an underappreciated paradigm shift in what launching your own compute and launching your own rollup really enables you to do. And so just to quickly review and kind of recap kind of what happened, prior to launching their own rollup, there's really limited throughput and high expenses on shared layers. By launching their own chain, they were able to 100x concurrent users. And importantly, and I think this is the stat of the day, is that they're able to pay 300x less in on-chain fees. So settlement costs were 1.2 ETH versus a few ETH a day before making that transition. They have a straightforward way to scale up from here by launching more chains. And I think it's a really interesting case study of rollup as the new server or database. And I think it's almost like a metagame shift of if I have all of this gas a second, if I have this entire thing to myself, what does that enable me to build that I wouldn't have been able to on a shared layer? So I'm excited for what this technology is going to enable, and importantly, what builders are going to use it for. And I think Proof of Play is a great example, and hope to see more kind of follow that path. And that's it. So you can find us at conduit.xyz. Our socials are up there as well. We have over 30 mainnets deployed, and we're excited for kind of this this paradigm shift. Q&A or no? Any questions from the audience today? So the question was, how do you ensure uptime for rollups? So rollups today are relatively centralized, and I think that's part of the advantage, actually, is you can push the performance frontier. I think for things like uptime or like decentralization, I think they'll eventually kind of come in, and I think the question is finding the right operators. And I think frameworks are pushing on this for example, like Arbitrum Orbit has Bold coming out, which enables permissionless validation and permissionless sequencing. I think something similar is on the way for the OB stack, right? So they released their kind of fault proofs that can be permissionlessly kind of validated. And so once the frameworks actually support it, it opens the door to a more decentralized kind of operator set. And then I think the key there is just making sure you find the right infra providers for that. If I think like the case of Proof of Play, where you're pushing kind of the performance frontier, and you might have special infrastructure to enable that, it might be hard to find another infra provider who can replicate that setup. And so it's really just a trade-off around performance versus kind of decentralization. And I think you see the same thing and the same dynamics at layer 1, where they've chosen not to push the performance frontier to enable a kind of more decentralized kind of set there.
Yeah. Hi. Why are some of the ZK rollups missing in the dashboard? And is it hard to measure their performance?
Is there a particular one you're looking for?
Any ZK rollup.
So I think that one was just showing like the top half. We have like Polygon CDK up there. We have, I think we have ZK Sync up there. But I think for some of the ZK chains, it's they have a slightly different like format, so it's hard to have the metrics align in the right way. And so optimistic rollups tend to be a bit easier for that.
How are you guys thinking about based rollups?
So based rollups are interesting. I think at least what we've seen so far with, I mean, it's cool tech. I think what we've seen with like rollups like Tycho is that it's hard to get the same UX or like cost compression benefits that you would on a kind of standard rollup setup. And so I think, again, it kind of comes down to where you are on the spectrum. If you really kind of want to prioritize decentralization, you can go kind of base rollup for some of the benefits there. If you want to push the performance frontier and treat it more like a server, then that might not be something you opt into.
Yeah, that makes sense. Are you guys thinking of supporting them at all in the future, or not really?
I think it depends on the demand for something like that. I think that I think they're relatively new technology. We're excited to see kind of how they perform, and as they kind of mature and improve, they're certainly something that we could integrate into Conduit.
Cool, thanks.
Cool. Well, thanks for having me, guys.
Okay, so we talked about applications earlier today during a panel. We talked about rollups, so now it's time to bring those together in a panel again. So the panel is called From Apps to Chains, and we'll have, again, Andrew here from Conduit. We have Mike, who was earlier on the panel, from Lyra. We have Griffin from Halliday, and we have Ben from Coinbase, who will be moderating this for you all today. So give it up for our panel.
Boop.
He met some of the folks, but I met him at his like builder event. Oh, do you have any more panels today?
Running on really good time right now, so this is good. Hello, everyone. Welcome to From Apps to Chains panel. I'm Ben Rodriguez, protocol specialist at Coinbase. We are going to have a very good conversation on this kind of evolution from kind of these smart contract apps to chains in general. Like everybody's just building a chain, build anything you want, all at once, right? So we're gonna get right into that right now, okay? So would love for my panelists here to start introducing themselves, and then we'll get right into it. Griffin, let's start with you.
Yeah, pleasure to be here. I'm Griffin. My background, so I studied computer science at Stanford. I was a researcher to begin with, so did embedded operating systems, worked at the hardware-software interface before getting into cryptography. While I was a student, did zero-knowledge protocol design and somehow fell into financing NFTs, which is where the business started. And I've been in the industry, founded Halliday for over 2 years now.
Mike.
Hey everyone, Mike from Lyra here. I'm one of the founders. I guess my background in crypto is I used to work at a DeFi protocol called Synthetics, and I left to start Lyra like early 2021. We were one of the first kind of OP native apps, and have since kind of made the transition from pure protocol to app chain, so pretty relevant to what we're talking about today, and yeah, keen to get into that.
Andrew?
My name is Andrew. I'm the founder and CEO of Conduit. We're a roll-up platform. We enable anybody to quickly, securely, cheaply launch their own roll-up. We work with Mike at Lyra. Excited to be here today.
Andrew, you're just everywhere today, right? You just finished a talk and stuff, and now you're on a panel. It's great. All right, cool. Let's actually get started into what we want to talk about here. So, like, there's just kind of been a debate, and like, this is a call forward to MERT and like, the modular roast on I think day 3, right? So it's like monolithic versus modular. So first things first is like, what can be built in either case? Specifically, try to make the case to like modular is better, and like there's certain things that can be built that's not like for monolithic and stuff like that. Can we get right into that, because I do want to get into how it it seems like it gets complicated and stuff like that. But first, what is the benefits of modular? Anybody can start.
I think the benefits of modular are that it's not one size fits all. And so I think for example, you see this on Ethereum where they're prioritizing, the solo staker, quote unquote, for decentralization. And I think that makes innovating and kind of adding features slower and more difficult. I think the modular kind of blockchain enables teams like Lyra to build better applications by enabling them to customize parts of the stack. And it's not one size fits all, it's kind of application specific. And I think that's how we'll get best in class apps, and I think that's one of the reasons we're seeing Lyra have the success they've had.
Yeah.
Yeah, I think the only things you really want to build that are monolithic are like base layer primitives like monies, like Bitcoin, Ethereum as well, kind of that settlement stuff. Anyone who's trying to do high performance execution, whether that's DeFi, gaming, or fully on-chain gaming, that kind of stuff, you probably want to go for a modular approach. It's going to give you scalability you just cannot possibly get in the monolithic context. So I'd say pretty much everyone at this point would do better building modular unless you're trying to start a new money, but that's probably going to be pretty hard.
You have anything, Griffin?
Yeah, I think the reason I sort of gained such high conviction on modular blockchains when I was looking into the industry was honestly the history of computing in Web 2, where once the internet started scaling, there was this trade-off between verticalizing hardware and designing horizontally scalable databases. And if you look at any internet scale technology, I can guarantee you there is not a single vertically scaled application servicing hundreds of millions of people. And you almost get to like laws of physics reasons why this is not possible. But you cannot run the internet on a single threaded computer. And that is fundamentally what a monolithic blockchain is. If it's truly a blockchain, it's absolutely ordered. And you can't run hundreds of millions of transactions per second on a system like that. You need this sort of asset compliant, eventually consistent model. Google's running 4 billion containers concurrently to service their workload. If Google has to do it, in all honesty, we're going to have to do it as well.
Oh, that's fair. That's fair. So then, that's actually going back into the architecture part of it, right? So, what I like to describe to some of my normie friends, right, is that in Web 2 we have something called microservices, right? And the idea here, just take an example like Uber, right? Uber has Uber Taxi, Uber Eats, they have Uber Package or Delivery or whatever it is, right? And at one point they had a monolithic architecture where if you wanted to deploy a change to Taxi, right, you have to deploy change to the entire code base to everything. It would affect everything, like all the operations, right? And then, but they moved into microservice where it's like, oh, we'll split this up between business units, independently deployable, right? And then what happens is that now, okay, if I want to make changes on Uber Taxi, right? I don't have to affect the Uber Eats app or something like that, right? Would you say that we're at our kind of like a microservices part of building modular right now?
I think we're still in the early days. I think we're seeing a mix of things. Conduit, we see both ecosystem chains that are building, tracking all the integrations, making it easy to build, and pursuing that route. And then we see a lot of application-specific chains. And I think, frankly, at this point, it's more of a compute-constrained thing than anything else. And I think the more compute you have, the more interesting things you can build. And I think rollups are kind of the only way to do that today, securely. And I don't know if it's necessarily microservices versus monolithic. The analogy, I mean, there are different reasons why you might do that in a Web 2 architecture. I think of it more as sharding a database. And so I think, yeah, more compute, more data, more storage, and you get to co-locate the logic that's important to you. I think Griffin had a good point earlier around Google runs 4 billion containers. I think beyond that, it's not like Google and Facebook and all these big apps are like composing all the time, there's actually maybe not as much data flow between those things, or it's kind of isolated. And I think we'll probably see a similar model emerge amongst crypto apps, right? Where like, I don't know that Pirate Nation needs to compose with like Lyra necessarily. I mean, that might be a collab you guys do in the future, but maybe the simplest version of that is just like, you can bridge between the two chains. And I think there's good primitives for that today.
Sweet. Anybody else got anything to say about that?
Yeah, I mean, I would just say from our perspective, like, it all just comes down to being able to optimize like usability that rivals what they'd be getting on a centralized exchange, while still retaining all the decentralized foundations that we sort of come to know and love over the last few years. Yeah.
Sweet. Got anything, Grover?
Yeah, I think that the part of the analogy that I like, and that I think why microservices got adopted in industry, but there's a joke in distributed systems, which is rule 1 of distributed systems is don't distribute the system, right? Nobody actually wants to deal with the complexity of asynchronous coordination, your abstraction interfaces being a network boundary. Like, these are all bad things, right? They make things more complex. But when you're at scale, and especially when you talk about like a shared computer, like a blockchain, you don't want these sort of systemic dependency at scale where you isolate failure modes. You isolate sort of strong dependencies to talk to each other in one place. That actually dramatically simplifies the sort of macro level computing system. So I do like that idea of like push the complexity to these smaller nodes so that you don't make the entire system brittle. Is it exactly a microservice? No, but I do like that idea of segmenting the different computing environments. And that's seen everywhere in computing.
Sweet, awesome, thanks for that. Let's actually get into the building of app-specific chains and stuff like that. There's the idea, and Andrew, you're enabling this with what you're building at Conduit, right? With being able to build an L2 or an L3 in just record time, right? Which is super awesome. You also just recently closed a raise, which is congrats on that, right? That's awesome. So then my question here is, right? When would you say it would be appropriate to build like an L2 versus an L3? Like, can you talk about the differences between the two, and why would you build one over the other?
Yeah, for sure. I think that's a great question, a question we get a lot at Conduit and kind of help folks navigate. Listen, I think that launching your own L2 kind of means that you're competing with the big boys, so like a Base or like it kind of depends on what you're doing, but I think it tends to be a little more competitive and a little more expensive. I think you are a bit closer to Ethereum, and so I think that means that bridging is probably a bit easier, onboarding is probably a bit easier for folks that are already on Ethereum. I think if you want to go the L3 route, why we might see that is if you're a smaller app-specific chain that wants to use kind of an L2 settlement layer as a means of getting users, and so like Base, for example, has a bunch of infrastructure integrated. They're going to have like Coinbase onboarding. They have smart wallets. They have all this great stuff. And so you can leverage that and the users already existing, the assets, to have really great onboarding. And so really, I think it comes down to what you're trying to build. If you're really tied into the Base ecosystem, your users are there, you're going to benefit from kind of the wave of innovation and kind of activity happening there, then an L3 would make a lot of sense. I think if you want to be a bit more sovereign and kind of, Lyra's a great example of kind of paving their own path, I think an L2 makes a lot of sense and enables them to, one, start out as an app-specific chain, but in the future, they might even become their own ecosystem.
Sweet, can you get into that with Lyra actually? Like, what was the decision to make as an L2 and you go right into building that?
Yeah, for sure. So a little bit of context. Lyra is a decentralized derivatives protocols. We do options, perpetuals, structured products, and the like. We started off as a pure protocol actually on Optimism main chain back in 2021, and back then that was kind of the place for us, and we were able to grow our community pretty quickly on Optimism. But kind of over time, we ran into some sort of fundamental scaling constraints of being a pure protocol. And when we came back to design our V2, this was 2022, 2023, we kind of went back to the drawing board and realized, look, we need to do things like portfolio margin on chain, which is for people that aren't derivatives, experts, kind of 50, 100 positions in one account, all sort of getting margined against each other, which is what market makers need, stuff like that, to provide institutional grade liquidity. And very quickly you start to kind of run into gas constraints and like how much gas can actually fit into a block and settle on OP mainnet. And that's when we started to think, maybe we want to take control of the actual underlying infrastructure stack and launch our own chain, which is where we met Andrew and the Conduit team. The other part of that as well, though, which I think is important, is there is a economic model to running your own chain which can be profitable if done correctly. It can also be wildly unprofitable, as we found out at the very start, because we were actually settling to Ethereum L1 DA like late last year when gas was spiking, and this was like pre-4844 and pre-span batches, is it? And so we ended up losing like 37, 38 ETH in the first month, but there was actually a solution for this, which was we were able to migrate to Celestia and get our DA sort of ported from ETH to the Celestia DA solution. So now running a much more economically viable chain. And I think like for any app that is running on, say, an OP mainnet or an Arbitrum mainnet, like at some level of scale, you're going to start to probably think about like, should we be internalizing this gas market that we're sort of just renting at the moment? The trade-off, of course, is you're leaving a more established ecosystem like, an Arbitrum or a Base and going out on your own. But I think there is a point there where it does become sensible for applications to go and build their own chains. And so that's kind of what we decided to do. So just to recap, it was sort of like, on the one side, like fundamental technical constraints that we want to be able to push the boundaries of and like, change the gas limit, potentially make some modifications to the actual OP stack code that we're running, but secondarily also bring a new economic model into the Lyra ecosystem as well.
Sweet, awesome. So now I have another question here. Do you think there will be other layers, like an L4, for example? I know it's been a little bit memed on stuff like that, but I can think of potentially like use cases for an L4, maybe like an isolated environment for like private transactions, for example, that you don't want to mix up with like public transactions or something like that. That's what I think, at least. But would there be situations where we might need L4s? Anyway.
I mean, I think there will be L5s.
Okay.
No, I think realistically, I think the end game is that it kind of doesn't matter what layer you're on. This is just like crypto compute, and as long as it's easy to use, it kind of doesn't matter where it's anchored. And so I think we might see like L10s one day. And I think if you go, I think traditionally we've looked at crypto as so kind of supply constrained that there just hasn't been that much built. We've just seen fees go up. But I think if we have all of this compute that can actually fulfill that demand, it's going to be like this huge tree kind of coming out of Ethereum, right? And so I think it'll keep going up. The layers will kind of keep going up. And we just need to make it easy to transact across these chains.
You mentioned something before, Andrew, about like sovereignty. Obviously, like as you go further and further up the stack, what do you think the real trade-off is as you get up to like L3, L4, L5? Like, what are you trading off? You're obviously gaining a ton of scalability, cost reductions, and everything like that. But do you think at some point it starts to undermine some of the fundamental sort of decentralization? Like, how do you think about it?
Yeah, there are certainly like trade-offs there. Like I think stacking an L3 on top of a layer 2 probably makes it a little bit less secure, at least in terms of some of the like fault-proof kind of delay game theory logic. I think ultimately a lot of these L3s are already making some trade-offs. For example, like in Orbit AnyTrust chain, right? With a 1 out of 1 like DAC, which is like a lot of them, is really just treating the rollup as a server. And if you're running a game, like maybe it doesn't kind of matter that much. I think frankly what kind of stacking layers, one does it does cost compression, and the compression is like quite good. But then two, it's like how close are you to a specific layer? And so it is easier to use or like kind of bridge from a layer that you're settling to. And so I think as these layers expand and like as they fill kind of the supply.
It was a great question. Thank you for asking that, Mike. And also, like, you hinted at decentralization as well, right? Like, there's criticisms, from, different parts of the community, outside communities and stuff like that, about like, L2s being quite centralized, as well as like, an L3 settling to an L2 would be kind of centralized, right? So can you address kind of like the decentralization aspect? What does it look like for the different parts of the stack? We can start with L2s, L3s, and stuff like that. And then just kind of like addressing that potential concern. What does decentralization look like in a modular world? Anybody? Griffin, you want to
Yeah,
go?
I'm happy to speak on this one. I think the primary trade-off is not necessarily, like I think decentralization, there's many axes to what that actually means, right? There's censorship resistance, there's like execution correctness, there's liveness, right? The thing that changes with these sort of off-chain execution environments that commit to a sort of like a state transition, they're like computationally they have to be correct, right? Because of fault proofs, and the industry is moving towards zero knowledge proofs. And that's the design of these. Like you can't get all three because the consensus is network bound at the end of the day. So if you want to scale, you do need to sort of sacrifice on one part, and that's liveness at the end of the day, right? Because if you're running your own shard and your server goes down, transactions might not be accepted, but you can always sort of go back to the L1 and sort of abort the transaction and get your money out. So it is trustless, actually. So I don't think it is as decentralized as you can get, except there's a slight liveness issue where if anything goes wrong, you need to resort to something that's higher latency. But it is really the best of both worlds. Because without that, what we're saying is, oh, we're going to scale on a monolithic architecture, which is just, like, from an engineering perspective, is not possible.
I think that was a great overview of kind of the core characteristics of a rollup. I think like maybe there's characterization of rollups today as like they're multi-sigs. But I think there's been a lot of progress on at least the frameworks that we work with at Conduit on permissionless validation and moving towards stage 2 rollups where multi-sigs have a time delay and they can only do actions when multiple fraud proofs actually disagree on the outcome. And so I think we're making really great strides towards scaling Ethereum. And I think as with any new technology, you want training wheels. And I think that's why the multi-sigs exist today. And I think we've clearly hit some trade-offs on the L1 that run amok of performance. And I think that's what rollups are here to solve.
Sweet. Awesome. I mean, obviously, we get all criticisms aside, there's progress that needs to be made because then we talking about onboarding 1 billion people, and my take is that we're not ready for that, right? We need more of this infrastructure to be built out and all that fun stuff, right? And that is going into different layers and all that fun stuff. But this also brings up to the point about fragmentation, right? Many different chains, right? Many different things, and it's very confusing to any kind of user. I mean, I tell this to my mom all the time, and she's like, I just don't know what to do, whatever it is, right? So I think one thing I want to ask is that with all of these chains that are coming out and we expect to happen in this modular expanded future, right? Where does the user onboard?
I mean, I think if we look at Web 2 is pretty fragmented, right?
Sure.
And so I think application, I think there's a little bit, and I maybe touched on this earlier, is that we kind of assume that the 1 billion users we're going to onboard are going to be exactly like the users that we have today, and I almost think that maybe that's not quite right. And as we onboard the masses, I think it'll probably be more about applications, and I almost think that the fragmentation is going to be abstracted away, and whether that's third-party bridges, there's a bunch of, I'm sure, intense stuff that, intense protocol people that would love to kind of jam on that, but I generally think that this will be abstracted away, and people will just be using apps.
Okay, cool. Griffin, I think maybe you want to talk a little bit about what you just released.
Absolutely, yes. I think this problem we're very, very familiar with at Halliday. And the way I like to describe it from a Web 2 analogy is imagine you logged into Netflix, you choose a piece of content, and before you can actually watch the content, the application says, hey, please tell us sort of which backbone network you want to use. Or is it a tier 1, tier 2 ISP? Are you on Cloudflare, on Akamai? Do you want us to use a Cisco router? That's the level of abstraction that we're giving to our users. And where we sit in the stack is we're a payments business. And we say, okay, a user wants to spend $1 on a modular chain. They don't care how it gets there. They don't care where their funds are sourced. They have an outcome that they want, which is I want to spend $1 of my balances that exists on my fiat bank account in a centralized exchange or on one of a plethora of chains. And so what we released, and we call this commerce automation at the company, which is providing a uniform interface on top of automating where the flow of funds go. It is an intent-based architecture. You sign a declarative outcome, and then it just works. And that is the level of abstraction that people want. That's the level of abstraction that developers expect, too. Like, you have these amazing businesses in the prior version of the internet, like Visa, that make it easy to talk to hundreds, if not thousands, of banks. Same with Stripe, right? We're trying to do the exact same thing, but for paying into a blockchain, and the whole pitch is, look, grow your volume, grow your TVL, by making it easy for people to bring in their cash and bring in their tokens. You shouldn't be telling them how to route networks and do all that stuff.
So then if like we have native asset issuance, like for example on some type of L3 or whatever it is, you know, putting that, like using Holiday, that doesn't really matter in terms of like trying to do something else on like maybe put that asset on like another L2 or an L3?
Exactly. They want to buy that asset because it's a new application, it's a new app. With our technology, you click once, those get pulled, they get routed, they get eventually settled, and you just buy the thing you want. You don't need to worry about ideally, you don't even think about this execution threading. I think there are going to be single video games that get launched that are popular that will have hundreds of chains. Maybe even hundreds of thousands of chains if they're big enough, right? Think about World of Warcraft that's running a server per zone, or maybe many servers per zone. We're going to that world. I don't think we should expose that to people.
Yeah.
I was just going to add, I think if you go all the way back, the first step usually for people onboarding into crypto is to buy some crypto from Coinbase or Binance or one of these centralized exchanges, which frankly do an amazing job of onboarding everyone. So I think like from a decentralized application perspective, like starting to see these like, you know, Binance Web3 wallets, OKX wallets, even the like the self-custodial versions like Coinbase's wallet as a service that we've integrated, like for me it's still like that's where you see like the next 10, maybe 100 million users coming into DeFi, because they do still have to come through that funnel at some point. So that's kind of where I'd be looking in terms of the onboarding problem.
So you think that people will be mostly onboarding through sexes and stuff like that, or you don't think people are going to be potentially like onboarding directly onto, let's say, you know, just, I'm not trying to shill, but Base, for example, right?
Well, I mean, where are Base's users coming from at the moment? Are they coming from Coinbase, or are they coming somewhere else?
I mean, definitely from a lot from Coinbase.
I would assume, I actually don't know the numbers, but I would assume that's kind of still where most people get their start. And I think that's a great like point of call for centralized exchanges, and maybe long term, that's kind of what they end up becoming, is more just the sort of entry point into the DeFi ecosystem. Certainly, they're much better at customer acquisition than anyone in DeFi is. They've been doing it for over 10 years. We're trying to get better, but it's an education process, and you know, you've got to get the user used to what crypto is, fiat, you know, all that stuff, changing that into crypto, and they do that much better than anyone in DeFi.
You know, one really interesting thing we're seeing at Conduit is, you know, I was maybe a little bit bearish initially on custom gas tokens if you're a chain, but I think one of the things it enables you to do, especially if you control the token, is to easily onboard your users. So I think what a lot of applications will do is they'll launch their token, make it a custom gas token, and then just airdrop balances to their users. And it's really cheap. It's, you know, their own chain, and that kind of circuits around all of this onboarding problem. And so they can have WETH on chain, they can have USDC, and they can, you know, swap into it from that custom one. But I think that's a super interesting application of the custom gas token that I hadn't previously appreciated.
Yeah, one thing that I think is exciting as well is there's a whole sort of group of big payment institutions and financial institutions who are now aware of blockchain. And I think that for people who are onboarding through apps, and what we've seen this in Web 2 as well, is that I think embedded finance and these embedded checkout solutions will be the dominant form of transacting in the future. And the reason it's hard right now is there's a KYC burden at the sort of, because tokens are convertible virtual currencies. But what we forget is that there are all these businesses, the credit card businesses, the telephone networks, the traditional financial institutions that already have all of this data for everybody. And once they sort of hop in and connect to the crypto rails, that is going to unlock a whole slew of, because you don't need to go through a 4-day, 5-day onboarding process with those guys, because they already have it.
Oh, no, makes sense, makes sense. So let's get into some maybe more fun things if you wanna consider it that. you know, what do you want to, you know, with this modular expansion, right? What do you want to see built, right? Andrew, I know you enable like all of that stuff through Conduit also, but like, you know, what are you thinking right now where it's like, you know what, this is something that needs to be built right now?
As an infra provider, you know, it's typically not my domain. I think what I do want to see is I want to see builders utilize kind of the you know, blockchain more as a server. And I think like you know, right before this, I gave a talk on proof of play, which is a game that is currently running at 40 million gas a second consistently. That's 20x Ethereum. That's 5 times base. And I think once you start thinking in terms of I have this entire thing to myself, how do I max it out? And you know, even down the line, how do I shard this, right? How do I run multiple chains? And then what is the interop story there? I think you start getting into the more traditional like Web 2 lens of thinking where I can build something great and kind of the scale. I'm not kind of inhibited or kind of held back by some of the fundamental limits that people have today.
Sweet, yeah. I know you're building Lyra, man, but do you have anything that you think would be like, yeah, this needs to be built or something like that?
I think the main thing for us and anyone in DeFi who's pursuing their own app chain is like you do give up composability when you go to your app chain, and like that is kind of where most of the magic happens. Like, you know, if you look at what's going on in Ethereum, it's like, you know, restaking into Pendle, into something else, back into Pendle, and when you kind of go off on your own, you give up some of that. So I think for app chains like ours to truly thrive, and like one of the great things about options and structured products, they are composable instruments, but if we don't sort of enable some good level of asynchronous composability, like we obviously can't get synchronous between different networks, we do kind of undermine our own sort of efforts. And so I just want to see the interop and asynchronous composability space continue to be developed. You know, teams like Socket, Layer Zero are obviously pushing that really far, and as they continue to do that, we can make an application which gets the best of both worlds, like high performance execution environment on RL2, where we can do all the portfolio margin and, you know, derivatives logic and all that, but still be able to have those tokens and vaults kind of like proliferate out into the broader DeFi ecosystem, whether that's on Ethereum, Arbitrum, or any of these other like app chains and L2s that are coming up.
Got something, Griffin?
Yeah, one thing I would love to see be made possible is just asynchronous computing in a way that's not just for fungible tokens. And the reason I say that is it's pretty simple to get this sort of asynchronous model with, you know, cross-chain atomic swaps, right? You have this sort of escrow lock. A lot of the intent protocols, right? They lock money, front the capital, and then you release it on the other chain after the fact. That's great for moving tokens around, but that doesn't work for arbitrary state management. And if we want the blockchain to be a computer and a server, you need a way of moving the bytes around that are not fungible from one place to another. And that's sort of in the way that you expect with like Node.js, when I call a server, right, there's a nice wrapper around the fact that it's asynchronous. I think we should bring back the Yank opcode. There's an old ETH research paper on this, and it was basically saying you should be able to take part of contract state, freeze it on one chain, and then move it over just in time. And what that lets you do is you can start sharding truly and having access to memory. And like the OG analogy would be like pipes in an operating system, where you can actually move data. Not just, a lot of interop today is not really interop. It's just fungibility reduces the problem. Data interop is almost impossible right now, unless you use these wrapper constructs. You're not actually moving state between the chains.
Oh, that's pretty cool. So more infra?
More infrastructure.
All right. So we have actually a little bit of time, and I don't mind to just, we got a couple minutes. If anybody has any questions, I'll run to you if you have any questions for anybody on the panel or me. If not, then we can end, and this has been really great. But first, let's get some questions. I also can't see, so you might have to call out. These lights are like killing me right now. All right, great, perfect. All right, so I've been Ben Rodriguez, a protocol specialist at Coinbase.
Griffin, founder and CEO of Holiday.
Mike from Lyra.
Andrew from Conduit.
And thanks for joining us on this panel. Thank you, appreciate it.
Okay, yeah, thank you everyone. So, as said, we're ending a little bit earlier than expected, but we have lunch break now. Come back after lunch, stacked agenda full of very interesting talks, so hope to see you then. Okay. Welcome back. Already a lot of people here. That's good. I hope you had a wonderful lunch. So we're going to continue on the same track that we went off just before lunch, and now it's time for Jacob from Celestia to talk about the sprawl. So I'm very interested to hear what that's all about. So give an applause and good luck.
So actually not the sprawl, it's actually about the lazy application thesis, which I'll explain the context for. But basically, back in 2016, there was this really popular sort of like debate about basically where in the what in the stack it actually captures value, what is the most important part of the stack, etc. And there was this whole thing called the fat protocol thesis, and people conjectured or believed that basically most of the value would be accrued by protocols. So basically, whereas in Web 2, basically the idea is, you have basically like, applications like Facebook or Google are capturing most of the value. In Web 3, of course, because basically, we can look at Bitcoin, we can look at Ethereum and see that, their market caps and their tokens are so much more successful than any application or thing built on top, that therefore there's this fat protocol, sort of structure that exists. And so basically he's like, well, why is that happening? He's like, well, there's the shared data layer, which it's like Celestia. He means like data, like user data is there. And so therefore people just build on top. They basically, it brings the barrier to entry to building an application all the way down. And basically anyone can just come on and tap into the same users, the same state on the chain, and basically build for those people over and over. And it's free, it's a utility, it's really cheap, allegedly, all these things. And then where he goes next in this piece is that basically, the other reason is, by the way, there's tokens. And tokens mean that you're going to, you can basically build this network effect using a lever that you did not have in Web 2. So you can, and he, basically, as I said, he's like sort of pointing to Bitcoin and Ethereum as these canonical examples of basically why this is the case, why this must be true. And then basically in 2022, after there'd been all these alt L1, Ethereum struggled to scale in the last cycle, and so a lot of L1s come out and they launch after raising a huge amount of money. So we have Avalanche, Solana, etc. And basically after that whole sort of thing comes apart, people this is actually right after Terra, like maybe a few weeks after Terra. He basically Hasu, who Flashbots and Lido and whatnot, he basically makes this tweet that became a reinvigorated this debate, basically like what captures value in crypto in Web3, and basically what he said, what a lot of people started talking about was like basically that applications' interests and chains' interests are basically not, they're fundamentally in tension. And the second that something becomes successul, it has the upper hand because like the users have a deeper relationship with the application theoretically than they do with the underlying chain that they're on. And so basically, this became a really popular trend for a little while in 2022. Basically people were talking about it, for a bit, and then basically the industry proceeded to, instead of doing that, that sort of playing out, instead sort of went down this path of deploying 80 Ethereum L2s and L3s, and they're mostly just general purpose chains. Like basically, there's no fat application sort of thesis playing out to date. But basically, and then there's also the modular movement. Why we're here. There's this huge explosion in people building infrastructure for a world of many chains or for a modular architecture, etc. But what's like the truth? Like we basically see this we haven't really, this hasn't really fully played out. We don't really actually have a grasp of like of reality on this item. And basically, what we have seen, where we're at, this was as of yesterday, is that basically actually there is some kind of like fat application dynamic going on. A lot of these are on Ethereum, right, or across a bunch of chains. They're omni-chain or something, and they're basically, if you look at, I think it's like 6 of the top 10 fee earners or fee earning things in like around Ethereum or EVM ecosystem, this excludes Solana, basically are applications. And basically, then there's a case of Friendtech, right, where Friendtech on Base, because the fees came down, basically, in the beginning, even before 444, was making, massive amounts of money. They made a total of, like, I think almost $60-something million in fees as an application cumulatively. And then basically what happens is 444 comes out, has come out, right? And basically what happened is that you can see where a lot of the revenue, actually the item I didn't cover was that the other point I meant to make is that Ethereum still is the biggest, even as of yesterday, as a fee earning thing in the whole, as a single fee earning thing, it is the biggest fee earning part of the stack. And then after 444, there has been this change in like what the Scrotopi folks have been measuring as rent paid to L1. It's actually crashed. Like you can see, it's very stark. Like after 444, basically all the fees from L2s, where a lot of applications now live, have basically collapsed and basically gone to zero. And that also includes things like Celestia, Anytrust, et cetera, in the market, right? But alongside that, you have this increase in, for a while, there was this explosion in profit that these L2s are making. They're basically doing the same thing that Ethereum has been doing for, the same fees that were going to Ethereum. As I said, almost all the chains that have deployed in this so-called modular era have been general purpose, Ethereum L2s. They look very similar to like what Ethereum, Ethereum itself, right? They're running Geth, they're running, something that's just, they're basically all the same apps are deploying there, et cetera. And as a result, a lot of the same, especially in the recent cycle we saw, that just triggered a huge amount of profit to these L2s before people before things cooled down and like basically, or they started moving to other places, right? And so basically the question is like, well, have we made it? Like, is it now the case that basically, we're in this era where applications are starting to capture more value, or where the fees are coming down from like multiple parts of the stack, et cetera. And the truth is, of course, that most people, and especially if you ask a lot of people in the Ethereum or modular community, is like that basically, no, not even close. In fact, it feels as if Solana has basically sort of taken center stage, or the underlying thesis of Solana has taken a very interesting center stage amidst basically a lot of the UX struggles of the stack and just the early there's just a sort of this modular and L2 disillusionment that sort of started as a result of basically this sort of having played out as basically the same thing as basically Ethereum L1 with worse UX. And so basically on Solana, actually, there's some interesting, which is that actually they're because they have so much throughput and because there's so much activity there now, there are applications that often that can have more fees in a single day and even a single week in this case than Solana itself. Whereas in Ethereum, Ethereum is still king. It's still earning more fees than any single application on Ethereum or on EL2. Basically on Solana, this isn't the case. Actually, in fact, Radium is actually basically earning, even in the past 30 days, it's almost matched Solana, which is really, really shocking. Given like this is basically unprecedented for this part of the stack. Basically, and then the Solana folks actually they explicitly are like, actually we like this. We actually unlike say Ethereum, the folks around Ethereum, like we think that like we're really successful when there's actually and Austin says like there's 10 plus applications making more fees than the L1. And basically, which I think probably would be isn't possible on Ethereum L1, but obviously certainly could become possible on Ethereum L2. But the point I was going to make is here is that does that mean that okay, well now given that we now have a substrate or a platform or protocol where basically everyone you can deploy an application and you basically can start earning you're basically being extracted from so minimally that you actually can earn all the fees that otherwise would be create the friction or the limit limit the ability to grow your application to mass adoption scale because Solana handles that for you. And does that mean that everyone should be onboarding to Anchor Framework? And a lot of people are like, well, what even is Anchor Framework? It's how most people build stuff in Solana. It's still pretty low level. It's pretty specialized, et cetera. And so it doesn't really scale to the distribution of like developer, the total developer population of the rest of the world that would basically want to build these applications. And the other thing is that, going back to what I said before about this fat protocol thesis that people had, like, say, a while back, basically there was this, basically what it actually looks like is, the guy's idea around basically this idea of like a shared data layer, user data being on one chain, and then everyone just coming in and building new stuff, new applications for the same people, the same users. And in fact, if you actually, sort of strip it away, what he's really saying, or what you really take away from the success of Solana is that, well, that's what it looks like when you have really high throughput and distribution without bridges, basically, without any of the L2 constraints, any of the frictions that have been basically holding back a lot of the sort of the type of UX that a lot of people would like to see from Ethereum L2s or just the modular stack generally. And it's actually what I think the real takeaway, the interesting thing, is that when you really step back, you're like, well, what are people even doing in those Solana applications? What even is going on over there? It actually just, you realize it's the same exact thing in a weird way as what was happening in the fat protocol world. It's just that instead we're doing, with L2s and with, now that we're scaling L2s and we have Solana, taking off and everything, it's like basically the same exact thing. It's just instead of it being, what we've really done is we haven't scaled the ability to allow anyone to build an application with all the freedom and flexibility and instant distribution that they expect in Web 2. What we've actually just done is make it so that everyone can take Bitcoin Ethereum and any individual community or whatever is just launching a token. Like, Iggy Azalea is launching Mother, there's Pump.Fun, there's like, if you go on there, you'll have a seizure probably looking at all the new token creation. And basically, and then you have Blast, of course, which is a whole other, can of worms. But the point there is like, that obviously like, was, could not have existed without, the scaling to L2, right? And so, but there are like really nice signs of hope, right? One of them, I think, is basically that if you're coming from scratch, if you're going to build an application from scratch, one of the challenges right now, or historically, has always been where do you get these users from? And so it just kind of warps the basically the incentives and the possibilities are severely constrained by the fact that you can really only tap into the users on these really historically relatively unscalable general purpose chains. So the difference, like where we're going, is like in Friendtech's case, right? Privy, obviously like sort of set the stage for this because you could just bootstrap, Friendtech was just literally built on the top of this Twitter social graph. Right, and then in the case of Polymarket, you have basically all this off-chain data. You have things like the election, where, for example, in the U.S., where basically there's all this. It's very topical, and then you just onboard, and it has a very Web 2-like experience to coming on. But it does something that really is uniquely better, with crypto than not. And so basically, my point is like historically, if you go back to this era, it's like really about getting the same users, the same people, same liquidity. Just maybe like a little bit bigger each time around, and basically just like sending it through the same, like basically like a Rube Goldberg machine of like incentives and whatever to basically kind of just recreate the same thing over and over. And what I want to leave everyone here with is that a lot of what we're doing at Celestia, is basically uniquely suited, kind of to like a hard right from, or like a swerve from that past reality. And I think it's gonna take quite a while to bootstrap off of reality, off of not just these same existing users and whatnot, but basically Celestia, by offering, I think these four things basically get you to a point where what I was showing there with Solana can actually look much more like traditional Web 2, basically architectures where actually the underlying infrastructure does not, basically is not bigger than anyone thinks. Like AWS is not, you don't necessarily assume that it's definitely taking way less fees from Uber than Uber is earning, right? Like, so it's like there's just no, it looks a lot more like the Solana case, but with an absolute like extreme diversity and heterogeneity of different types that are built on top. And so what are the things that enable that in the roadmap that Ismail presented, right? Is basically like abundant DA, of course. And so that, and I'll get to that after this, but abundant DA, the fact there's no execution, so MEV and the skimming fees off of execution are handled at higher layers. There's no validators needed, right? Like you don't have to, if to launch something even more scalable than Solana, you don't even have to stand up a validator site. You can just go do it with an L2 and Celestia. And then the last one is that we can bootstrap off reality, similar to we have with like things like Friendtech and Polymarket. We can bootstrap off reality to onboard any developer with many VMs, et cetera. And so this is actually playing out. So since, especially in recent months, like, let's look at the 444 data. Celestia is there on the bottom, Celestia underneath, I guess. And basically, it's basically, you have where we were with like call data, and we've come down like about 90%. Then Celestia is another 90%. Most of that actually like the gas overhead, I think, of posting blobs or something. But basically, it's just dramatically cheaper. And in fact, like we're seeing it in practice. Like this is a little misleading because I'm like cutting off the rest. But the point is like the top 5 chains, like what are they, right? The 3 of them are things using AltA, and 2 of them are based in Arbitrum 1, right? So it's like where there's like a huge economic incentive to post a lot of data. And so basically we're seeing this start to play out, and basically like, I think where we sort of come in is like we have this opportunity to like basically, instead of it being constrained to, basically the same, basically like basically just redeploying the EVM over and over and over ad nauseum, we actually have this opportunity to like kind of like basically bootstrap off reality with an EVM. And even more, like this is kind of like the core embedded mission that will just keep improving and improving as like Celestia's roadmap sort of plays out. And so basically, and as I was saying, it's like this is kind of really embedded in the mission, and it's going to continue to play out. Basically, it's like basically the core idea is basically that like a customizable blockchain, like any of those VMs, right? As it can bootstrap off reality and just be as easy to deploy as any of those apps on those L2s. Sorry, I'm just trying to. And basically, okay, here's what I was trying to get to. Basically, where it goes is like instead of sort of there being this fat application thesis, fat protocol thesis, whatever, the core idea is that actually it's not even about where value accrues anymore. It's actually about how easy is it, how trivial is it to basically build your thing, get users, and get distribution. And so I think what I wanted to present kind of as the core idea that's what's enabled by both the Celestia, like existing Celestia, we're seeing a lot of signs of this, but what's especially going to be possible as the roadmap develops is basically like these 3 things, which is basically that instead of it, people caring about where does value accrue, these sorts of questions, instead what we care about is basically like providing people with just these things that they cannot bootstrap for themselves. And so what you cannot as a developer or a user, et cetera, or someone who wants to deploy a chain or an application get for yourself is basically these 3 things. And I think it's basically, you don't want, how, bootstrapping security, you don't want to have to recruit validators, et cetera. Maybe you don't even want to, have to, be told where you should be getting your distribution from. So that's the second one. Is basically, you should be able to just launch an application or launch a chain and you just get distribution from everywhere else. You don't have to worry. And not just that, you get distribution from reality through all the things that are being built, things like TLS, TEs, et cetera, to start connecting blockchains to the real world in a much deeper way. As well as the last one, which is, as I was saying before, bootstrapping off of existing developer communities, which basically means that you don't have to just go through existing EVM, go back to the same 5 Solidity devs that people feel safe working with. And the last one is just like as part of the roadmap that Ismail presented, it's like basically the block size is just going to keep getting bigger. So if from the lazy perspective is that basically you don't have to, you basically ideally won't have to worry about whether the underlying scale that you're tapping into is enough long term. And so basically that, and then the second one is that, and this is like, again, part of that presentation, you can check out Lumina, which we've kind of been soft launching here at Modular Summit, which is that the light node, the Celestia light node is getting really small, is getting smaller and smaller, and it's usable even in the browser now. And so we actually have the ability to embed it everywhere. Where basically just like, these things, like if you think of it almost like how Solana talks about, yeah, we're just going to get faster every year. Like we just have to get bigger every year. Like we just have to get, more distribution of the light node to do that safely. And then lastly, this distribution from everywhere. So that to sort of summarize is like this point I think is something that people have, there's people who sort of talk about, there's like Sandeep's presenting the ag layer, there's people presenting all sorts of visions of interop. This is like going to be a very like long process. But basically this is from Ismail's slides. But basically I thought this was like an interesting point is like basically you think of it as like it should really be that simple. Like it should really be that you have like any asset or whatever, or someone wants to do something here, and execution can just happen somewhere else. And as someone basically building an application, you basically just have to basically start posting data to this chain and start posting proofs to this, basically verifying proofs on this chain, et cetera, with whatever, or to some proof aggregation layer, whatever that sits in the middle, whatever, and then basically, hopefully, basically someone, basically your users, all they have to do is basically sign a message and underneath, and basically they're just getting it somewhere else, doing something else, whatever, and like that to me is like basically the sort of the last step, or like in terms of like what's needed for the on-chain piece. I don't have time to really go into like sort of like this bootstrapping of how else we can bootstrap off the rest of the world, but in terms of the user data. But the point is like all of this stuff together is actually presenting something that gets us out of this and we basically enter the era of like actually being in like the real world, where it's like actually you actually have applications that can bootstrap the existing value, but you can also basically just tap into any existing distribution, whether from a developer perspective, from a user perspective, with your own data, etc. Thanks.
Okay, that was quite a turnout for this talk. So, good sign, and we'll follow up with another banger, I hope, which is about solving native asset issuance in a modular ecosystem by none other than Jelena from Noble. So, give it up.
Thank you.
Good luck.
Awesome. Thank you so much for having me. I was just saying behind the stage, it's a really beautiful venue, and we're super excited to be here. So I'm going to talk about Noble today and what we're doing in this modular ecosystem that we all exist in to solve for a very specific pain point, which is native asset issuance. So I'll go through a little bit of the Noble origin story. We'll talk about how we're actually solving for these pain points, what those pain points are, and actually even share some exciting news on the next asset that we're launching on Noble for the modular ecosystem. So first, hello. Very exciting to be here in the heart of the European Union, and let's get to it. So what is Noble? Noble is purpose-built. We like to think of ourselves as doing one thing very, very well, which is native asset issuance. We are very much leveraged and exposed to the growth of the modular ecosystem, some of which Jacob just here described. And in the past months, we've gone to over $500 million of transaction volume on a monthly basis and even exceeded $1 billion. So this is our success so far. We first started off with a simple mission, which is how do we bring native USDC in the Cosmos ecosystem. We launched in September of 2023, and we've actually grown to 240 million of TVL, so this is a little bit outdated. We have 20 times more penetration than the nearest native stablecoin that exists in the Cosmos ecosystem, being Tether. And the reason why that is because we really try to proliferate and make it very, very easy to go between various chains, various execution environments in one click with stablecoins such as USDC. So whereas many projects right now are very interested and incentivized to create these, walled gardens and to retain incentives and liquidity and activity on their various chains, we really, really look to see ourselves as more of a router of liquidity, a chain that exists in between, in this case, Circle, and destinations like DYDX, the Celestia ecosystem, and so on. So while we started with native USDC, this was really just the beginning to experiment and to kind of see what does this model look like. Sometimes I like to say that being a native asset issuance chain when you're building a blockchain almost sounds redundant, like isn't any chain with settlement and native tokens an asset issuance chain? For Noble, we really specifically focus on stablecoins. We really see this as the next unlock of onboarding many developers and users into these various crypto applications. And so these are the other stablecoins that we're bringing on board. We actually launched Ondo's USDY officially on Noble's mainnet yesterday. So this is the first time that various Cosmos users and application developers and builders will actually have access to this USDY, which is a tokenized treasury bill that is always hooked into the perfect redemption price that's being fed through the Ondo organization. And so this is something that we're really, really excited. So while, again, we are live with this one stablecoin that is still a very, very important pillar of our growing modular ecosystem, the others that we're really excited about are also other fiat stablecoins. So really excited to share that tomorrow we'll be announcing we're bringing a Euro stablecoin, which is very timely considering we're here in the heart of the European Union. And this Euro stablecoin is actually issued by a company called Monerium. And again, you can imagine where in a world where you have native integrations of USDC, treasury bills, the Japanese yen, and the Euro stablecoin, you kind of see this early machinations of Forex markets actually being able to come into play on-chain in a real way. So by leveraging these very, very native properties on the Noble chain, so a perfect redemption price for something like a tokenized treasury bill, the perfect kind of current euro exchange rate, for example, and many other yield-bearing stablecoins, you can actually start to build out applications that are very, very suited for things like lending, things like swapping, things like Forex, and so on and so forth. So we're really excited because we've seen these applications take off in the Ethereum space, applications like Curve and others. But in the modular ecosystem, it's still very, very hard to be able to solve for the liquidity fragmentation, solve for this kind of perfect price problem where there is discrepancies across various execution environments. And for Noble, this is what we're super excited to solve for. Okay, so I talked a little bit about what we've done so far, but how are we different than any other blockchain? This will actually feel very, very familiar to the people in this room. This is typically something that I like to share with folks that are not as familiar with modular systems or app chains. But really, we're looking to prove that this idea of an app chain, which obviously the Cosmos white paper initially envisioned, is really being realized. Things like L2s, things like L3s, you can even think of rollups as their own sorts of app chains. So really being leveraged, this vision is something we're very excited about. This is probably another image that resonates with folks. Again, as you have distinct execution environments, as you have different interoperability solutions, how does something like a stable coin fit into that? How does an application developer that maybe wants to launch a Minutia actually plug into native USDC and have reliable native USDC liquidity from the Noble chain? So looking at this ecosystem map, it's very clear that there's many kind of folks doing many different things, and really for Noble, it's about issuance and settlement at the end of the day. Yeah, I mean, this is something that we all like to talk about. Really, it's the next evolutionary step, growing this interchain economy, having kind of leverage to all of the transaction volume that takes place between various app chains, and making sure that this continues to grow is part of our mission. This will also look familiar to many of you, so I'll continue to go to the next slide. But really, at the end of the day, one thing that we really like to emphasize is that Noble is UX. So things like fast finality, so being able to have, in Noble's case, one second block times, things like actually using USDC as a gas token on both the Noble chain and on various other rollups and app chains, and this idea of this one-click transaction. So we really emphasize that to onboard the next millions of users and developers, you'll have to have a UX environment that feels seamless, that feels easy, And that is really something that we prioritize when it comes to the stablecoin issuance piece, both for the end users, the end app chain developers, but also all the asset issuers that we help to onboard into the modular ecosystem, issuers like Circle, Monerium, Ondo, Hashnote, and many more. So I'll give one specific example of how Noble is UX. I think sometimes these terms might seem very broad and even fluid and a little bit abstract, but for Noble, it's actually something that's very core to the way that we operate and is a core principle, this idea of UX. And so this specific example of automated interchain accounts, now actually called a forwarding module, actually came to us from a team that had a very, very specific need. So this team is a team that spun out of Krafton. Krafton is a South Korean gaming development company. They're very well known for having built PUBG, and they're actually launching a Cosmos chain. And they wanted to have this chain perform a specific function, which is doing creator payouts for their various gaming developers in stablecoins, specifically in USDC. So we had various stakeholders that we had to solve needs for. You had Krafton, the gaming development company. You had Circle, of course, wanting their USDC to proliferate in that environment, and you had Noble being the on-chain issuance chain for USDC, and you actually have Stripe that at the end of the workflow would actually be able to withdraw these creator payouts to bank accounts. So you can think of these workflows as very complicated systems, because at the end of the day, you have to satisfy very specific requirements across all of these stakeholders. And so our objective became, how do you automatically forward an asset, in this case USDC, to a destination chain, in this case Krafton, in one click? And so what we did is we actually leveraged these core primitives that already exist in Cosmos, specifically, being interchain accounts, which is an IBC standard. And so for us, it was pretty straightforward solution to be able to actually come up with a system where you could actually register a packet, in this case, a USDC transfer, onto a account, which would then be automatically forwarded to a destination in one click. So this is a really seamless sort of solution that you can actually think probably would not have been as easy in other ecosystems, and definitely perhaps not in monolithic environments where you don't have fast finality, you don't have these custom workflows sort of established, and you definitely don't have things like IBC. This is another example. Today, I mean, we all talk about how easy or how hard it is to interact with these systems. Again, going back to this idea of a one-click user-driven experience, here you can actually go natively between Ethereum mainnet, and Osmosis in one click. It does still take time because you're waiting for Ethereum finality, but at the end of the day, you have a very huge unlock where there's no slippage, having to route through various pools to go from Ethereum to the Cosmos ecosystem. It's one-to-one, and really at the end of the day, really what you're trusting is that in this case, Noble's implementation of the cross-chain transfer protocol. So this is a native bridge for USDC. So we see these intense-driven experiences with one click as something that is very, very, very core to our philosophy, and just continuing, again, to make it extremely straightforward for both users and developers to interact with these systems when it comes to stablecoin issuance. So really, we're excited about bringing more liquidity to the Cosmos ecosystem, to the Celestia ecosystem, and really beyond. And at the end of the day, having these super, super unified experiences that we can solve for both, in the Cosmos side, which we already have, for other ecosystems in this kind of modular environment is really important to us. I will end with happy paths. I think this is something we need to think a lot more about. I think we get very caught up with meme coin mania and speculation. But at the end of the day, people just want nice experiences that don't give them anxiety or want them to rip their hair out. And when it comes to things like using stable coins and going between various ecosystems, that's something that we're super excited about. So happy paths are something we always talk about, and here there's some really nice examples where you don't have to think about fees, you don't have to think about slippage, you don't have to think about, gas fees and filling up your wallet with, tokens to pay for gas in a separate token. Really, what we're interested in these is in these happy paths for all users. So that's that. Thank you so much for having me, and hopefully you learned a little bit about Noble's mission. Thanks.
Okay, thank you so much for that. We are running a bit ahead of schedule, but that's totally fine. So that we'll have more time for questions maybe whenever anyone has a question. Next talk is about WorldCoin. We'll have Philip, who's going to talk about the user activity and the journey to World Chain. So give an applause for Philip.
Hello, everyone. Okay, so today I'm going to talk about a bit more about, actually more in detail, what WorldCoin does. I think probably most people heard about WorldCoin as the project's name about it, but we'll dive way deeper now into the user activities or what users actually do on-chain. And maybe many of you also have seen the announcement. Like 2 days ago, we've launched the developer preview of WorldChain. And yeah, we're going to talk more about it today, like what does it actually mean to launch WorldChain. Yeah, so first of all, the goal of WorldCoin is to launch the largest identity and financial network. And more than that, not only launching it, but also giving the ownership to the network itself, so everybody in the network. And like this is very abstract, but kind of what does it mean now in more detail, and actually why do we do this, right? So on the identity piece, maybe first of all, I think in general this proof of personhood and proof of unique humanness has become way more popular than it was like 5 years ago nearly when we started. And I think by now probably way more people at least will agree that humanness is an important concept as a whole, and you actually need a proof of personhood to solve problems in governance, and especially like the long-term problem of HEI, I think, and redistribution of resources and wealth created through HEI will require some sort of notion of humanness. And on the financial part, nevertheless, I think we really want to deliver on this OG premise of crypto, of building this large financial system that actually anybody can be part of and is built on blockchains and is this permissionless thing that just anybody in the world can participate and really have the same opportunities. So 2 major pieces of the system that I will talk through is one World App, which is right now the major wallet in the ecosystem, originally developed by Tools Humanity, one of the core contributors. But it actually does more than just the WLD token, right? It allows people to hold crypto as a whole, interact with other crypto tokens, and also exposes this notion of digital cash, which is really USDC, and a bunch of primitives around USDC and other tokens to end users. And this is really like easy to use, beginner-friendly wallet in a sense. And on the protocol side, there's WorldID. So this is mainly the piece of the whole system that allows you to prove that you're a unique person, and then also use it in other applications. And it's totally privacy preserving, or like we go to a large extent to include various technologies that improve on privacy, and I will talk in more detail, but that's the other core primitive that we built. So now to numbers. In total, there's around 12 million World App users. These are not all verified with an orb, so I'll dive deep into those numbers later, but this just shows like there's a large influx of new users that go on-chain and do certain actions on blockchain. And around 5.4 of them are monthly active, and the largest number of orb verifications that we've seen in a week was around 400,000 users, so they really went to an orb and then were proving that they are human through this biometric means. And yeah, nevertheless, a big part of why users sign up and what they can do right now is they work on airdrop, right? And I think this is also one of the largest, or probably the largest airdrop already now with around 200 million WLD claimed by users. And yeah, we're not going to stop. Every user is eligible for that. This is, I think, an interesting graph because it shows kind of those two lines starting to diverge and like this orange line becoming huger. So the blue one shows the orb verifications, and the orange one just in general, all users downloading the app, right, and really becoming like a wallet user. So you see that it's not only for users that, I don't know, learn about WorldCoin the first time they see this shiny sphere that we've built, right, the orb, but they also just download the app and World App or like any wallet that, because they're interested in the project and actually want to become on-chain users, right? And that's the orange part, really, users that just have World App as a wallet. And yeah, what does this now mean in terms of on-chain activity, right? Peak new users, around 800 or 900,000 new users kind of that we brought on-chain that have some certain interaction with the blockchain. Average of transactions per day is around 600,000. It's not quite Visa style or Visa level, right? But it already shows like there's a huge already kind of infrastructure needed to handle this. I think it goes very high in the overall usage of crypto. And the most transactions in a single day were around like 1 million or above 1 million. So I think another impressive number is total transaction, 120 million. So that's so far what all users interacted with a blockchain, and they're mostly new users, right? So we're really growing the overall pie here. So now what this means in terms of on-chain activity, right? In terms of, here in our example, optimism, because that's really where the users are right now. And it pretty much results in, I think recently we, or World App users or WorldCoin users took over the majority of the network, at least by definition. So around 51% of all the gas consumed on OP Mainnet is driven by WorldCoin users. And all of those users interact through the chain through pretty much already account abstraction, right? So all of those users have a safe deployed. They have a way to pretty much also, like it's a way for them to get an on-chain account, right? It could be something that's not bound to World App in the future, but they just take this account and use it in any other wallet in the future. And I think that's generally the direction that the whole space is also heading at, or should be maybe heading, to have this reusable on-chain account notion versus the wallet being the account and very hard to migrate from. And also here to point out, $0 were paid by users in terms of fees. These were all sponsored transactions, actually, and this is really just possible, A, through account abstraction, and B, through Sybil resistance. So you could really not do this if you, or if we hadn't like a strong way to prevent Sybils through a WorldID. And really what got us there, kind of from originally like, I don't know, 4 years, 5 years when we got started to OP Mainnet. So 2021, this was actually, I think the last time I was at FCC. We were still creating this optimistic rollup. I think back then there was really nothing that was kind of production ready. And based on first principles, we thought, well, it will be, or like WorldCoin will be really useful in peer-to-peer payments. So we built this custom optimized and highly gas optimized version of an optimistic and slightly CK rollup, which was called Hubble. Yeah, we found out people want to do more than payments. Actually not a big surprise, I think, in retrospect. And also the scale really did not matter so much yet to go highly optimized. Actually, a lot of the improvements we did back then came back later in some sort of other improvements we've done. So it was definitely at least a very good learning. But we also found out then when migrating to Polygon that it's actually not enough to just give everybody an EOA, right? And so we shortly after migrated to Safe pretty much for all Whirlab users, and every user got upgraded or was able to upgrade and got a Safe deployed. And since then are using Safe. And this was really, I think, the beauty of decentralized protocols. We just started deploying those Safes. Safe didn't know kind of what is happening. There's just this huge influx of new Safe users, and I think a really good example of like permissionless infrastructure they were just able to use. And yeah, this led them pretty much to launch on OP mainnet last year, pretty much exactly 1 year ago, when L2s finally became like production ready. And now we kind of also outgrew this and migrate to WorldChain. And yeah, we announced a preview 2 days ago, as I mentioned. Now, what do those people actually do with all of those transactions, right? I think not surprisingly, a large chunk of transactions is actually claiming the airdrop. And this is not an off-chain interaction, but this is really an interaction or like a transaction created by the user consisting of a zero knowledge proof, in detail CROT16 pairing-based proof. So this actually is very expensive to verify on-chain in terms of compute gas. And I have here on the right side a little graph from a Dune dashboard from Nibra, a team that's working on proof aggregation of all of the amount of gas that is consumed in terms of verifying zero knowledge proofs on chain, actually on any chain. And the orange part is WorldCoin. So the majority, or like more than 75% of all gas related to verifying zero knowledge proofs is spent by pretty much, or like is consumed by WorldCoin users. And this just shows also the scale and like the importance of the large scale applications of zero knowledge proofs here. This is kind of not maintainable, right? You cannot just have a zero knowledge proof for every person that claims the airdrop. So we work on proof aggregation actually with a lot of outside teams through the grants project. And yeah, want to ship this proof aggregation, which would then be a huge improvement and hopefully also opens up new use cases like permissionless gas sponsorship through 437. And it's kind of a call out for developers. By the way, all of those blue ones are like, we're very interested in those topics, also through the grants program, which I later will mention. But it's also all based on a larger piece of infrastructure, which is the WorldID as a whole, right? And to briefly guide through this, so a user's journey kind of starts here. The user creates this WorldID key pair, fully self-custodial, in the app, and then gets this verified at an orb. The orb does the humanness check locally, so make sure that you're not just wearing a mask or, I don't know, bringing your dog to sign up. But what it can do locally is the uniqueness check, which happens in a more central way, but we also managed to make it a bit more decentralized by running it in a multi-party system, but most importantly, make it fully private, that the biometrics, like the only person that sees your biometrics kind of is you, right? And the orb would only like also see it and compute something locally, but it's never retained. And this MPC system is actually one of the recent additions that also Remco talked today earlier in another talk. And we also released a blog post. Definitely worth checking this out. It's like a huge piece of engineering that went into this to make it possible on its scale. Then it lands in a, like the verified WorldID public key lands in a off-chain sequencer, which again is pretty much like a mini CK rollup that batches a bunch of those and brings them on-chain, and then proves that those state transitions were correct and makes kind of a commitment to all of those available on various other chains like OP mainnet, because the whole thing runs on Ethereum actually. And yeah, just as a brief call out here, I think we use pretty much like most of the buzzwords here in privacy enhancing technologies of CK, MPC, CKML, TEs, soon even PIR. And yeah, we're happy to slam more privacy enhancing technology in there if you're interested in improving the system. And the other part besides WLD and claiming the airdrop is really people already do now on-chain transactions with USDC and stablecoins. So they can, of course, hold it. And it sounds like not a big thing for many of us here, but it is actually a big thing to just get access to dollars in many countries in the world that have like high inflation. And as a bonus, you can even earn yield on this, right, in a permissionless way on chain. So this is like already a big thing for many World App users. And then, of course, people can send this USDC around. I think there's really no technical hurdle now anymore to adoption. The fees are so low. They're anyway sponsored, but they can also continue to be sponsored because they're so low and Sybil resistant. Users can also swap tokens, and I think what we actually want to also see more of in general in the WorldCoin ecosystem is like actually day-to-day transactions, right? People should not just hold USDC, but actually maybe also use it, pay for goods, and generally something we're very interested to drive real-world use cases and not just Web3 degen demos. Right? I think that we got plenty of in crypto. This is all again based on the larger wallet infrastructure that is behind a lot of parts in WorldCoin. World App as a self-custodial wallet, but then also, as I mentioned, smart accounts, which is built on Safe. Each user has their own Safe and actually can manage the Safe, for example, adds passkeys, which make it very hard to lose the access to the Safe. And soon they will also all be migrated to 437, so works way more permissionless and kind of independently of World App backend or Safe backend to propose and send those transactions. And yeah, ultimately this allows for more wallets, and yeah, we're interested also to fund these. What we've learned, I think in general, as like getting to that scale is L2 ecosystem definitely was early and is still early. I think we had to build a lot of things ourselves, had to make a lot of improvements. For example, like the fees were definitely not that low in the beginning, so we had to do custom compression on those transactions, and L2s were not really that kind of big game changer in the beginning. Now with 4844, which also took a lot longer than we thought, and which we also helped contribute to, which is kind of here, if you remember the KCG ceremony on the right side for Ethereum, where we also contributed on like the infrastructure. And I think now it can be summarized as like the new bottleneck is L2 execution gas, and that's also the new focus where we want to contribute as a project and want to also fund other developers, give grants to people that want to help improving that. So WorldChain is now live actually, developer preview, so you can apply and get a private RPC URL. Later in summer it will be fully public. It's more like a time period where developers can deploy the contracts without, I don't know, having to be bothered by a lot of World App traffic and like high transaction fees or something. So it's more like a launch window for other developers. But what's next is actually public launch, as I mentioned, migration of all World App users, and we want to really contribute on scaling ref and joining this whole GigaGas roadmap. And yeah, this seems to be like the new bottleneck for now, as long as we don't run into, again, some data availability constraints on L1. But that's like the primary objective on our side for now. And I think this is very well aligned with the overall ecosystem of OP, Coinbase, and anybody else in the superchain. And yeah, we obviously also want to push account abstraction very far on the WorldChain and make this a kind of first-class citizen. As I mentioned, yeah, every user has to Safe, and this should also be the primary way to interact for users. I had a bunch of callouts. All of these blue bubbles were like little callouts for things that we're interested in or like generally interested in. There's more than that, but I think not surprisingly, CK identity is very big topic for a WorldCoin project, and also anything around the infrastructure, working on actually scaling RAF. And yeah, we have the Human Collective Grants program for that. We'll be very happy if we see applicants on any of those topics. And I think that's it. No, we're also here somewhere around EFCC. I think there's at least one of the cafes is still ongoing, and there's ETH Global on the weekend. So yeah, it would be great to see people hacking on things. And that's it. Thank you very much. Any questions, or should we? Are there any questions? No. Okay.
Okay, thank you very much, Philip. That was very insightful. I think this data is not out there all the time, so it's good to see. And then we have, of course, Hilmar from Gelato. We have the nice Gelato stand to thank him for out there, so I hope you already have enjoyed a little bit of ice cream, but he will talk about the learnings on layer 2s, so looking forward to that.
Test.
Yeah. Works.
Hello, hello, hello. Exciting crowd here today. How are you guys doing? All good? Nice, nice. So, today's topic is learnings on layer 2s. I'm Hilmar. I'm one of the founders of Gelato. And yeah, quick agenda. I will introduce the presentation with a bit of context about Gelato and why I talk about learnings about layer 2s. I will talk a bit about data points that we are collecting and sort of trends that we are seeing. And also sort of asking a question here is, should rollups actually sort of settle to Ethereum, and should they actually pay Ethereum, or are there maybe other architectures that we could be exploring as an ecosystem? Yeah, let's maybe jump in right away. So what is Gelato? We call Gelato the verifiable cloud. And what it consists of is kind of like 3 layers. At the top, we have a rollups as a service platform where we work together with projects in the space to help them deploy and launch their rollups, OP stack, Arbitrum Orbit, Polygon CDK, potentially more stacks in the future. And you can really come to a platform one click, and the thing sort of runs and it scales to how much usage you really can sort of gather. And the exciting part about Gelato, compared to maybe other service providers out there, is that we have developed a really strong middleware services layer that we combine with our rollup as a service platform, where we offer users to, for example, create push-based oracles for low latency DeFi applications such as perp dexes, abstract away gas on their rollups completely, supply verifiable randomness, all these kind of things that games, DeFi applications, and so on require. We can offer them out of the box on a single platform with a single click. And this is really where we want to go to. We want to minimize and lower the cost to deploy a fully functional rollup, not just a vanilla blockchain with nothing on there that you can't really use for anything, but really imagine the same environment you have on Ethereum today with all the infra on your rollup with a click, and as sort of cost effective as possible, right? And then it kind of scales with your needs. And this also includes a bunch of third-party services that we tightly integrate, from indexing to multi-sig, wallet as a service, and so on. So really like an end-to-end platform for your development needs. As an example here, one of our customers is Raya. They are a super exciting project building next generation perp DEX as an L2 on the Arbitrum Orbit stack. Their DEX that they are building is fully gasless, so users are not paying a single cent to use it. It's really like a Web 2 user experience. We are driving the cost per transaction down to the minimum. Data is not being posted to Ethereum. It's posted on a data availability committee. The chain itself still settles to Ethereum. There are up-to-date prices every 4 seconds. They have actually 100 millisecond block time, so like toxic order flow and stuff like this, arbitrage is minimized through that. And the cool thing is they have a fully functional interoperable bridge set up, so you can bridge in assets from any chain you want, Arbitrum, Base, whatever, not only Ethereum. And this is, I think, a great example of a project using our services quite heavily for all the features that they want to offer. We have over 38 chains in production today. An example of some cool ones are, for example, Fox News. They recently deployed their rollup on Gelato to combat fake news and AI-generated content by onboarding like New York Times, for example, to push verifiable hashes of their content they're posting so users can actually validate it. And then there's some general purpose chains like Lisk, Asta, and then also a lot of gaming related chains. So we see really a wide array of cool use cases. And we are really seeing an uptick of layer 2s and layer 3s deploying this year. I think there are over 120 rollups that are already confirmed to already have launched or will or are about to launch in our ecosystem. And an interesting trend that we are seeing is that until like last year, most of them were really like traditional layer 2s that also settled on Ethereum, posted data to Ethereum. But today, more and more L3s are actually launching. And I will go in a bit into why we think that is. And not only are projects launching more chains and more layer 3s, but also they are exploring different data availability solutions, right? Data availability is basically where do you post the data as a rollup, and it used to be just Ethereum, as you can see in the chart. But this year compared to last year, we already have a 450% increase in chains that do not post on Ethereum. They post on data availability committees, they post on Celestia, they post potentially in the future on like EigenDA or other DA solutions. And 60% of all the chains actually do not post to Ethereum that launched today, which is this year, which is basically the larger part, right? And most of these are optimistic rollups. So Validiums or ZK rollups are still sort of lacking behind the trend quite a bit. And indeed, most of our customers, they are launching optimistic rollups. Regarding the TVL that you see, we're actually about to flip Ethereum in terms of the TVL that is available. Obviously, there's some caveats here, right? Like if you have TVL on rollups, then it kind of like also lives on Ethereum if you use the canonical bridge, right? But what we expect to see until the end of the year is actually the TVL that comes from Ethereum and also comes from two other sources, which are like other chains that are not Ethereum, and assets that are issued natively on layer 2s to slowly exceed Ethereum, right? And this will be an interesting point in time because, yeah, what happens to Ethereum when actually like other chains will have more native asset issued than Ethereum? Like, do we still want to sell to Ethereum? It's a question that we will be going into a bit deeper in a moment. And still though, Ethereum for the layer 2s out there is still the largest source of liquidity today. And how you can look at a rollup, of course, is a rollup is a chain and a bridge, right? And especially if you build an L2 on Ethereum, what you really get out of the box is a secure, trust minimized bridge to Ethereum where people can bridge assets in and can bridge assets out again, either very fast via ZK proofs, but expensive, or very slow via validity proofs, and it takes like 7 days today, right? Well, what is interesting to see is that more and more assets are actually natively minted on layer 2s, and USDC is contributing a big chunk to that. Over $4.3 billion worth of USDC is actually natively issued on layer 2s, such as Arbitrum and Base and so on. And you don't really need an Ethereum layer 2 bridge in order to secure that because USDC and Circle and Coinbase are really the security mechanism that secures these assets. And then also external bridges are slowly growing. So chains used to only bridge in via the canonical bridges, but if you talk to the developers building rollups, the canonical bridges suck. Or they don't suck, but they are slow and no one really uses them. Or no one really wants to use them. They all want to use fast bridges and want to bridge in via Base or Arbitrum. And so yeah, this is a clear trend we are seeing. And this is an interesting one. I think the first pie chart is a bit wrong. It should be like 99% versus 1%. But these are basically these are 3 different layer 2s. Rhea, which is like the perpdex L2, which is the second largest Arbitrum orbit chain that is deployed on Gelato. Then we have Base in the middle and Arbitrum on the right. And what is interesting to see is like Arbitrum is the oldest, right? And if you look over 66% of all the assets that are issued on Arbitrum actually originate from Ethereum. So they're bridged in via the canonical bridge. That is kind of like the sort of native bridge of the layer 2, right? And then you have over 28% actually being natively issued. These are probably some meme coins and stuff, right? And USDC. And then only 5% come from other layer 2s. This is probably because Arbitrum is the biggest layer 2. And so you don't really need to bridge assets in from other layer 2s. But if you look at a slightly younger layer 2, such as Base, for example, there we see an interestingly different trend. And this is that the assets, which is mostly ETH, bridged in via the canonical bridge, the layer 2 bridge, only constitutes to roughly a quarter of all the assets that Base has. Actually, 70% of all the assets on Base are natively issued to the chain. This is mostly USDC that can be natively issued on Base without actually having to go through the canonical bridge. But this is interesting because Base is settling to Ethereum, right? And they're paying Ethereum a lot of fees in order to secure the assets that are being bridged to Ethereum, but actually only 25% of all the assets are secured by this bridge. And they don't get any security for the rest, right? And then the extreme case, and the chart is unfortunately wrong, it should be 99%, is Raya. And actually 99% of all the assets are coming from different L2s, from Base, from Arbitrum. So Raya's paying Ethereum for settlement, but they don't get anything out of it, really. They don't have any security when it comes to the funds that are being bridged in or not. So should they be a layer 2, really, or should they maybe be something different, or should applications that are similar be something different? This is a question that we are asking ourselves. And so what if you, as a chain, you do not source liquidity via the canonical bridge? Question, should you settle to Ethereum like normal L2s do? Or should you maybe not settle to Ethereum, right? Should you pay Ethereum as a settlement layer, even if you don't get that much benefits from it in practice? And I think this is what, especially the Celestia community is sort of thinking about as well. And there is this concept which is called a sovereign rollup, which stands in stark contrast to being an enshrined rollup, which is what an Ethereum layer 2 is, for example. Ethereum layer 2, you get a canonical bridge that is enshrined to Ethereum. Sovereign rollup doesn't have this. Sovereign rollups are much more like a layer 1. They just outsource data availability and consensus to a data availability network like Celestia, and then they sort of settle within the network itself. Of course, you still need bridges, right? You might still want to get assets in from other chains. But in order to do that, you then can build custom bridges like what Raya did that use, validity proofs, ZK proofs to prove only certain events that have been emitted on each chain, and then you can move assets between. And you don't need to constantly just settle to Ethereum like the layer 2s do today. I'm not saying that sovereign rollups are the way the industry is heading, right? We just realized that this is an interesting trend that we are observing, and there are a lot of chains that are just paying Ethereum for nothing. And if you step out of the Ethereum maxi bubble and you think of Ethereum as a service provider for data availability and being a reliable asset issuer that you trust, but you don't get any security from Ethereum for your assets on an L2, then why is the L2 paying Ethereum in the first place for its security? It's just it's just nonsense, really. So yeah, this is just something that we're observing that I think is quite interesting to see. And yeah, maybe to round things up, there are several trends that we are observing as Gelato when it comes to rollups launching, and in general how people are using layer 2s. First of all, I think we are past the point where many rollups are sort of just building the next general purpose chain without much differentiation. I think there's a consensus in the industry that we are going more to purpose-specific rollups. These can be application-specific, this can be community or sort of country-specific rollups. And how we see this really is we see rollups as verifiable servers at Gelato. And if you are building an application that you can run on a centralized server, but it just means people have to trust you, and this creates costs around auditing and monitoring, you should just put this on a verifiable server. Fox, for example, is an interesting example of this, as I described. Like the New York Times doesn't have to trust that Fox doesn't tamper with the attestations that they are collecting from other publishers that are stored on their layer 2. They can just run a node and verify it themselves, that everything has been sort of handled correctly. And I think this is a big reason why the New York Times or Times has actually sort of agreed to participate in their program, right? And I think we will see more and more real-world use cases coming up that are similar to that. Additionally, I think chain abstraction, everyone heard about it. For me, this means that users don't really know on which chains they are on. It doesn't mean the chains don't exist anymore. It's just they don't even know which chain they are. And what do you need for that? You need full gas abstraction. You need to have scalability that can be horizontally. So you can have applications that might live on 3 different chains and shard their state between them, and they might elastically scale up and down, but the user doesn't even realize this, right? Like if you are using Amazon, you don't know which server you just interact with to view and buy this asset. And so I think this is a big trend that we are seeing, and 90% of all the chains that are deployed on Gelato actually use our services to abstract gas away from their users. And I think in a couple of years, no one will pay gas anymore. It's just what it is, especially with 7702 and other EIPs coming around. And then there's the emergence of roll-up clusters that we are observing. So we've seen Arbitrum kind of like spearhead this at the beginning with like L3s being built on top of Arbitrum. We have like Optimism with the superchain. And we believe that we are entering now a space where we see different clusters of applications that are kind of like close, they want to be close to each other emerge, that build and interconnect horizontally and also vertically. And we believe that like in a year from now, you have not only Optimism and Arbitrum, but a bunch of them that somehow sort of interconnect asynchronously, but between each other go very close to synchronous composability. And they have curated communities, curated infrastructure, and are specialized for low latency DeFi, high frequency gaming, and so on. And then the last point that I mentioned earlier is non-enshrined rollups. As I said, when you're not using the bridge from Ethereum, why are you paying Ethereum for settlement? And if you're not even using it for DA, why are you paying Ethereum for anything, right? You maybe want to still be aligned with Ethereum, but for me, alignment is not a long-term sustainable business model. You need to provide value. And Ethereum does have value, a lot of value, because it has assets issued on its chain that it can make available trustlessly via its bridge. But the more assets are bridged to like Arbitrum and other chains, the more other layer 2s can also tap into those and don't actually need to settle on Ethereum anymore. And so maybe should they settle on Arbitrum or Optimism instead, or Base, right? That's an open question that I cannot answer today, but I think this is just a trend that we are seeing again from all these chains that we are launching. Cool, that's already it. Thanks a lot for listening. I hope you learned a thing or two today. I'm around still for an hour, so if you have questions, just let me know. Thanks. No questions in the audience, right? I think they come to me afterwards.
Okay, we just saw the blue pill, the red pill being the sovereign rollup, so let's have a panel on that. For this, we have Sam from Sovereign Labs, one of the proud Maven 11 portfolio companies. We have Felipe from Cartesi, and we have David from Anagram as a moderator. And they will be joined later by Connor still, but he will join in a couple of minutes.
Thank you.
Good afternoon.
Hello.
How are you doing, guys?
Doing good.
Doing well. How are you?
How's your ECC?
ETC been nice.
Yeah.
Yeah,
Modular Summit a little bit better?
Hopefully.
Definitely bigger.
Yeah, that's right. Cool. We are here to talk about sovereign rollups. So maybe we'll just start with like a lightning round of introductions and what you do, what your projects do. We'll let the conversation evolve from there. I am David. I'm an investor at Anagram.
Sure, I'm Felipe. I'm a co-founder of Cartesi. Our idea is to let builders build more complex and intricate dApps. So to do that, we built a RISC-V execution environment, which allows you like to bridge Web2 tooling. And the idea is to work and let the builders build more complex dApps than the ones we currently see on normal blockchain applications.
That's awesome. Hey everyone, my name is Jim. I'm one of the co-founders of Sovereign Labs, and what we build at Sovereign is we try to build the most flexible and performant rollup framework. So users just bring, similar to Cosmos SDK or Substrate, bring their business logic. This time it's written in Rust, and we take that and we enable it to be deployed as a rollup on any base blockchain. It could be Bitcoin, it could be Celestia, it could be Solana, and yeah.
Cool, awesome. Okay, so I don't want to start a semantics war. However, I think it's really helpful to start with just shared definition of what is a sovereign rollup. Jim, do you want to lead us off?
Sovereign rollup, from our perspective, is just a rollup that doesn't have a validating bridge to the smart contract or like execution layer of the L1, of the blockchain that the rollup inherits its security from.
Yeah, so actually, I'm definitely not a specialist in sovereign rollups, so I'm here to learn from him a lot. But I see sovereign rollups as a pure function over data availability layer. So it's so like you choose the data availability, and then everything else is governed by social consensus, and you don't have an official way, official place that you settle to.
So our view of it is a bit different. So like the social consensus has been talked a lot about, but from our perspective, at the end of the day, when you're like bridging to any other like rollup, or if in your case your sovereign rollup does have a validating bridge, your rollup does have a validating bridge, there still needs to be the canonical like state transition function that like these bridges will respect. And in that sense, like you can't just use social consensus to update all these other bridges. So there is a defining the bridges basically in this case. In Ethereum-based smart contract rollups, there's a single bridge that defines the rollup. In sovereign rollups case, it's more like Cosmos. All the the rollup can be connected to many different rollups, and like the L1 and the state transition function that those bridges accept is the right version of the rollup.
So just asking a question. So you don't fork by social consensus. You actually have to have you cannot just hard fork your sovereign rollup because the bridge is connected to a bunch of other rollups, right?
Yeah.
Interesting. Okay, so we are at a point in crypto, I think, where we've separated out a lot of the primitives for building your own sovereign blockchains or rollups, right? And we've made those tools much easier for application developers, to where we've kind of like compressed the time to build your own sovereign rollup or blockchain from months or years to really weeks at this point. Why do application developers want to choose a sovereign rollup?
Yeah, so at Cartesi, like as I said, we're a modular execution layer.
Mm-hmm.
So our execution environment can be used for, it can be an L2 and L3, you can run as a sovereign rollup. I think sovereign rollups are good use cases for applications that are quite big and independent, and they don't need to interrupt that often, so that's my current view on it. And I believe that's like, say, if you are running World of Warcraft on chain, then a World of Warcraft can be a sovereign rollup because it doesn't have like shared assets between many different layers. You can fork more easily because the assets are all basically defined in the rollup itself. So that's how I think about sovereign rollups.
Yeah. Again, our thinking is a little bit different here. By the way, like at Sovereign, we don't necessarily see ourselves as purely like sovereign rollup toolkit. You build a rollup, and like this sovereign like rollup versus not like regular rollup is a bit of a semantic and not existing the definition. So as long as you generate a secure rollup, you can run it as a sovereign rollup, or you can have a validating bridge if you're deployed on Ethereum or if you're deployed on Solana. And at that point, it's not a sovereign rollup. It's like a regular, like smart contract rollup. And from our perspective, there's not that big of a difference between the two. So it's hard to say that one is like in which instances is a sovereign rollup more useful or like not, because like. Do you need a bridge to the L1? If you need does your L1 support execution environment enough to be able to build a bridge? Sure, build that bridge, and in that, if you do that, then your rollup is not going to be considered a sovereign rollup. In Celestia and Bitcoin, you can't currently build that bridge anyway, so you have to build a sovereign rollup. But it's hard to say when it's much preferable to be a sovereign rollup versus a rollup deployed on Celestia. If we dig a little bit deeper, it could be liquidity, because if you're really dependent on being tied to the Ethereum ecosystem or the Solana ecosystem, and you want to have a trustless bridge to these L1s, then you likely don't want to have you likely don't want to be the sovereign rollup. You just want to have that bridge to Ethereum or Solana.
So just to align a little bit, so if you believe, if there's a rollup that has 3 canonical bridges, meaning that it has assets on Ethereum, maybe has assets on Solana, and has assets on, I don't know, Base, is that a sovereign rollup to you because it doesn't have a single canonical bridge but has many canonical bridges?
No, from our perspective, a rollup can be a rollup on only a single blockchain. There has to be only a single blockchain that you inherit your security from. I mean, there are very complex ways to have two rollup, have inherit data from multiple blockchains, and then you get the security of worst of both blockchains. But normally, in the simple sense, a rollup can be a rollup of a single base blockchain, and then it can have regular IBC type bridges to other blockchains. It can have Solana is through Picasso connected to IBC. Hey, Connor. It's connected to Ethereum through Axelar. And so as long as it's deployed in one DA layer, then it can connect to others through trust minimized bridges, but it can't have this validated bridge.
Hey, Connor. Hey. Okay, cool. So, when we're thinking about sovereign rollups, and you touched on it a little bit, we talked about bridging. Interoperability surely is an important thing for sovereign rollups, whether that's synchronous or asynchronous, and we can get into that. But how are you thinking about and pitching to the application developers this interoperability?
How are we thinking about interoperability? Yeah, so at Sovereign Labs, as we were building Sovereign SDK, initial liquidity was a major problem for a lot of our users. So we, for our Celestia deployments, we started work on an IBC integration, similar to the regular IBC bridges. Sovereign SDK rollups that are deployed on Celestia will have IBC connections. Hopefully, in time, we think we can have IBC connections to Sovereign SDK rollups on Bitcoin. And the way it works is that in a regular IBC bridge, you validate the signatures of the base blockchain, base blockchain validators. And in a Sovereign SDK rollup, if you're running on Celestia, you run that same verification, which I think Connor has worked a little bit on to do it in ZK. And on top of that, you run a snark verifier that enables you, or like the optimistic light client, to make sure you can get to the state root of the rollup. And once you get to the state root of the rollup, afterwards it's like a kind of like a DevX issue. You can like integrate any type of bridge. You can integrate IBC, you can integrate Hyperlane, any sort of those like higher level like bridging tools.
IBC is a spec. It doesn't force you to trust the validator set. What's nice about it is there's part of the spec is the definition of a light client, and there's 2 implementations that currently exist to implement the IBC light client interface. One is the Tendermint consensus verifier, and the other is called the solo machine. And theoretically, you can develop as many more of them as you want. You said you want to connect Bitcoin rollups with IBC. You could do that. Yep. You can create some sort of Bitcoin verifying thing that conforms to that software specification, and then you can do it. Same with Ethereum or any other chain. You can also upgrade it to somehow verify the state transition function. You could somehow upgrade that to verify ZK proofs of correct execution, or you could even add a delay and do fraud-proof style.
So that's exactly what we're doing. We're using the light client, like the Cosmos light client that like Celestia already has, and on top of that, we're asking for like destination chains that are trying to bridge from a sovereignistic rollup to verify the snark verifier on top of like the Cosmos light client. But I'm very excited about someone building a Bitcoin SPV light client as a Cosmos that adheres to the IBC spec, and in that way we can also bridge from Bitcoin sovereign rollups. That would be very cool.
In your view, a rollup that wants to interoperate with the other sovereign rollups, it has to run the light clients of each of the rollups that it's running in a sense, right? Whether that's like verifying a validity proof or knowing how to play a fraud-proof game of that other rollup. Is that it?
So yes, if you're deployed on the same base blockchain, then you have to run, if you're trying to bridge from a ZK rollup, then you just have to run a single snark verifier, and we have our whole blockchain succinct, like Mina, so there is no much like machinery outside of like the snark verification, and then we can aggregate the proofs of all rollups that live on the same DA layer, all the ZK rollups that live on the same DA layer. So with a single proof, you can get basically a state root view into infinite number of rollups that live on the same DA layer. If you are trying to bridge from like a fraud-proof based, like optimistic rollup on the same DA layer, you have to run their light client. But that's why we kind of expect the hub-and-spoke model to work for optimistic rollups, and for ZK rollups, they'll just be connected as in a mesh connection to all the other rollups.
Awesome. Connor, thanks for joining us. I'm wondering if you can give us a little bit more about like what you do at Celestia Labs and what you're working on, because I think there's actually been a few breakthroughs just as of late that have taken place that might be interesting to talk about.
Sure. I am substituting for Manav, who couldn't make it today, and he's a better fit for this panel if this is a panel about sovereign rollups. But I used to work on Rollkit. I spent a year working on Rollkit, which is a sovereign rollup framework. And I don't know, Rollkit is a sovereign rollup framework which is compatible with the Cosmos stack. So you can use Cosmos SDK or other kinds of ABCI state machines to create sovereign rollups on arbitrary DA layers easily. Were you asking about new breakthroughs on that side or on the Celestia side?
On the Celestia side, that might kind of like bolster what we're talking about here with sovereign rollups. Yeah.
Yeah. Let's see. So Celestia.
Pretty open-handed question.
Yeah. I'm just thinking if there's anything that has been done on the Celestia side to improve sovereign rollups recently. There's been some stuff to improve non-sovereign rollups recently. The snark account stuff there might be some utility for the SRUs from snark accounts, but I think people are mainly excited about snark accounts for like settled rollups, the non-sovereign kind of rollup.
Yeah, like since we don't like really look into the distinction of sovereign or not sovereign and like sovereign labs, which is funny, but like snark accounts once implemented will enable a lot of like all the TIA to be trustlessly transferred to the rollups where like they can be used for any purpose because these rollups are Turing complete. So I think that's the one like very exciting development. On the other hand, there's lots of like engineering improvements that happen, like that like obviously don't get talked about because these are implementation details. But we've been working with Celestia Labs, and for example, we need to verify like Celestia's data structures inside our ZK proofs to be able to build these succinct rollups. And there has been like a couple of engineering improvements that like make our like life way easier. So we're very happy about that. I'm talking about the authored signer for the blobs.
The which?
Authored signer, like address of like the pay for blob, like the blob's sender address gets included in the blob as like the first part. Small implementation detail, but on the engineering side, like small implementation details help us a lot to move fast.
Right. Oh, also, this may be something that we should talk about, not on a panel, but I think I spoke with Preston, and I asked him, how do you, because you guys have to go through every blob, and you have to, for the blobs that are not relevant to the SRU that are in the namespace, you have to prove that they're not relevant to the namespace. And I think Preston told me that that was easier to do on Bitcoin than on Celestia, which is a huge problem because we're trying to be the best chain to do exactly that. So we need to talk about whatever makes it easier on Bitcoin, we need to bring to Celestia.
Yeah, definitely.
Yeah, I'm very excited about Celestia personally because at Cartesian we have this concept that we try to put forth called the cone of innovation. So since we are focused on an execution environment and computational scalability, like computational scalability makes less sense if you don't have a very good data layer to support like real data, right? Because it doesn't matter if you have like a very good computer if you can only use very little amount of data. So we see the design space of applications opening up a lot when you start to work with app chains and good execution environments, and you see like a data layer that can actually support like real amount of data, as in you have on Web 2.
Cool. How do you guys thinking about like governance for sovereign rollups in terms of upgradability? How do users reason about that?
I think there are two models. One of them is if you want to if you want to upgrade your application, you deploy a new version of your application, and slowly your users that like want to get onto the new version move their assets out of the previous version and like move on to the new version. Another path is to encode an automatic like a voting-based like upgrade process into the main like state transition function of the rollup, so that all of the bridges can update their view of the rollup binary basically. We've seen like demand from users for both, and I think as people like deploy these rollups more and more in production, people will come with more interesting, more complex, likely like ways to do these upgrades that like fit their business model. But those are like the main two things that I'm seeing for now. And one like cool idea that we had, and like we will only implement if there's like actual feature request for it. But you can imagine a scenario where if there's an issue with like some of like the business logic of the application, a security council could revert the rollup to being only of like transferring assets rather than like all the business logic functionality that's inherent to the rollup. And so at that point, people can only use the rollup to exit. So that that's one like crazy idea that we had that we have to analyze more. But those are some ideas.
Yeah, my understanding before coming to this panel was that sovereign rollups would fork through social consensus. So like they would upgrade through hard forks. But if that's not the case, then I think like I agree with you on the options. You can either launch a new version, and that's in a sense an opt-in upgrade because users have to move their assets, or you can have the upgrade baked into the state function, the state transition function, either through a governance model or say a security council or anything else, and then that's in a sense an opt-out method, right? Because you leave the application if you don't want to get upgraded with it. I think that's much better than forking through social consensus, because I think social consensus is actually much more expensive than it looks.
Oh yeah, I think there's a gigantic difference between the rollups that can be easily upgraded with social consensus and the ones that need some sort of vote because you have a trust minimized bridge to the base layer that's immutable or something. Gigantic, stark difference between those two things, which is why I still like to use the distinction between sovereign and settled rollups.
Yeah, in any rollup, anytime that you start having bridges to the base blockchain or to another rollup, the moment you add like validating bridges, you have to have a model of like you can't use social consensus unless all the bridges somehow accept upgrading through like social consensus, which is hard to reason about because presumably the other rollups are also going to be like the other rollups are also going to have some sort of bridges, and they're also going to have to upgrade, and so you like there has to be some like social consensus doesn't go too much with rollups, unfortunately.
The reason everyone says rollups aren't real now is because it's like theoretically possible for a L2 with an immutable validating bridge to the L1 to fork away from that bridge and break it. So, for example, Arbitrum, hard forking in such a way that all the ARB tokens and all the other tokens that were minted on there go to the hard fork, but then the ETH is broken, and so the ETH that was bridged up through the original bridge goes to 0 on the L2. Technically that's possible. No one's ever going to do that. So, like, rollups aren't real in theory. In practice, they're very real.
Interesting. Okay. So, you know, we're all building for a future where we actually have applications on sovereign rollups. I'm curious what you're seeing in terms of adoption of these frameworks and what types of applications are actually being built.
So we have a few users in the we have a few like derivatives exchanges being built on Sovereign SDK because Sovereign SDK can provide very, very low latency soft confirmations, which in the case of derivatives exchanges becomes extremely useful. Thanks to like the fact that we can also build rollups on Bitcoin, we have a category, we have a bunch of users, Strea, Alpen Labs, Bison, building on Sovereign SDK forks on Bitcoin, and yeah, derivatives exchanges, Bitcoin rollups, Solana rollups. One of the derivatives exchanges I mentioned about is building on Solana, and a few gaming and other like applications are looking into Solana rollups. Just as an ecosystem-wise, they want to be connected to Solana. And lastly, we're seeing people building SVM rollups using Sovereign SDK and MoveVM rollups. So we're all over the place, to be quite honest, in terms of, because the SDK's main goal is to be one of the most flexible frameworks, and so that leads to like users from a lot of different ecosystems and use cases. But it's nice to see the momentum.
One rollkit user that I can shill is Astra, the new Stargaze rollup.
So thinking about the difference between sovereign rollups and settled rollups that I know you don't agree with too much, but I think good use cases for sovereign rollups are those that are very big applications that a lot of people use, but they don't have to interop a lot, especially exchange assets with other rollups. So say big games in which, like, if you have some financial interoperability that can be done by liquidity providers who live in that chain, but also live in like whatever other chain you want to exchange your money to. So I do like sovereign rollups for those kinds of applications, because as I said before, say a World of Warcraft on a sovereign rollup doesn't have to pay the price to settle on another chain or to settle on a bunch of different bridges, right? So I like those types of applications for sovereign rollups. For other applications that have more need of interoperability and so on, I think settled rollups are very good. So for instance, we have at Cartesi, there's a very cool application that's being built called Rives, which is an arcade game, a world arcade decentralized. And you not only can play the games, but can also sell and buy cartridges. So you can program your own game. You can sell that to the protocol, and then that would be available for players to play. I think it would be a good use case for sovereign rollups if all the games were there from the beginning, but this cartridge market makes it a better fit for settled rollups, in which you can actually have a market that interacts with a shared liquidity of wherever your canonical bridge is.
Another open-ended question, but in a world where we have hundreds, thousands, tens of thousands of sovereign rollups, how are you guys thinking about UX and UIs for these different things?
So there are two limiting things in the current state of blockchain technology that's limiting UX across rollups. One of them is that the consensus, like the time it takes these base blockchains to come to consensus, because that's always going to be a limiting factor of how fast these rollups can communicate. And the actually bigger bottleneck at the moment is ZK proving latency. ZK proving, for a rollup to communicate with another rollup completely trustlessly, you have to first publish your data on the base blockchain. The base blockchain block needs to be produced, and then over that produced block needs to be finalized, and someone needs to come in and prove that block. So until we see these latencies come down a lot, sending messages trustlessly between these rollups will take quite a bit of time and will lead to inefficiencies. But at the same time, we see that with for a lot of users, for users that are not moving tens of millions or billions, we do see that for the everyday user, the relayer systems or low security systems do help a lot, and they do relayers provide fast messaging, and so users opt into that quite often. So as long as we have the rollups actually running in production and their throughput way higher than where they are now, I think the bridging issue, which is the main UX issue right now, will be alleviated quite soon.
If you give everyone a standard to follow, like IBC, which is a really complicated spec that has for the first few years of its life, had very messy UX and difficult to read code, it's worth it. It pays for itself over time, because once there's a standard, even if the UX around the standard isn't great at first, it allows someone to come in later with a little bit of software engineering elbow grease and build something that will knock everything into place. You can see this now with the skip API. IBC is not bad anymore. Now you can go to ibc.fun and seamlessly jump around Cosmos chains, and it actually feels very good. It reassures me that creating the IBC standard was worth it, and it will pay off, and UX is just a matter of time and a little bit of elbow grease.
Yeah, I definitely agree that UX is a matter of time. I think about UX in two main verticals. One is dev UX, so the UX of those building the applications that the end users are going to interact with. And I think for those UX, for the devs, there are a few things that help them a lot in their journey to build application. One is predictability of the so standards, good written standards, very well established APIs, also Web 2 tooling in a sense. So making their environments, the environments that they interact with, as close to the ones they're used to as possible, allowing them to have many layers of abstraction and convenience, so they don't have to rebuild the wheel every time. They can import and reuse code that was built by other people. So I think there's a lot of work to be done there in the developer UX. I think for the end user UX, it's often a trade-off between centralization and UX. So for the paranoid user, I don't think we have to give them that much UX. I think for the say naive user, then I think we have things like chain abstractions. You have things like Infura and so on for Ethereum. And I think what we have to work on is to make sure that those centralized actors who are providing you with UX are as in a sense, punishable as possible. So as transparent as possible, as slashable as possible. But I do think it's very hard to provide the UX that you're used to in a, like, say, normal world without making some trade-offs in the centralization spectrum.
Yeah, definitely. Okay, so Connor mentioned like maybe rollups are not real. Jim, like, what is the most common misconception that you would like to clear up about sovereign rollups?
What's the most general misconception? Before I answer that question, I do want to come back, like, to the previous question of like user experience, because I think it's super important. I do think, like, I would just wanted to share one excitement from my perspective. I think wallets were like a huge distraction and point of like pain for lots of users. But thanks to like a lot of blockchains adopting, I'm forgetting the team's name, like the social login type systems where like you're able to generate a private key on the browser for the application that you come in. Later, if you want to bridge to another application, you can export your keys and like put them into another app. Preview, for example, like preview-like solutions are really making the blockchain application UX not that much different from a regular Web 2 UX, and I think that's what we should be striving. On top of that, like we've seen that with like rollups, people are very okay with trusting centralized sequencers because in the worst case, if the centralized sequencer is acting bad, you can exit. So now we can give soft confirmations at the levels of Web 2 applications, which is another incredible like user experience improvement, which I don't think we've like seen like the whole implications of. I think lots of Web 2 like developers will come to see this and build applications on blockchain technologies thanks to these improvements. The last thing is just like sending messages. Async calls on internet takes about 300 milliseconds or so. Right now on blockchains, like on like Cosmos, it takes about 5 seconds. On like rollups, it takes anywhere from 15 minutes for ZK rollups to a day or so for optimistic rollups. And that will come down as ZK gets cheaper and ZK proven latency comes down and block times for base blockchains comes down. But bridging aside, like we're doing really well on like user experience front on all sides almost. And the ZK technology speed is improving so fast that in a few years, I think that UX problem will also be solved. Okay, so about like the what people like what was the question again? Sorry.
What's the misconception about like what sovereign rollups are, or the trade-offs that application developers are making by choosing to do this?
Yeah, the biggest misconception from our perspective is that we don't see much of a difference between sovereign rollup and like smart contract rollup. Do you have a bridge to the L1 or not? That's the main thing. And what we build in Sovereign Labs, Sovereign SDK enables like rollups of both type. It's just that like we don't need the smart contracted function. We out of the box like rollup work as like sovereign rollup, and then if you deploy the bridge, it becomes a smart contract rollup. So for us, like there doesn't need to be as much as focus on a rollup being sovereign or not. It's a rollup at the end of the day, and that's the biggest misconception that we're dealing with.
I think the biggest misconception that I see is that sovereign rollups cannot interoperate with anything else, and that's not true. But yeah, I think that's a very common one.
Yeah, for sure.
Biggest misconception about rollups? I think that that they don't have a good definition. I think that it's like an ambiguous hand-wavy thing is a misconception. I think whether or not something is a roll-up is a very clear yes or no.
Would you not say that a rollup that posts data to another blockchain to inherit its security, both safety and liveness, is considered just like by definition a rollup?
Any chain that posts data to another chain?
Not state, data to another chain so that it can inherit the full safety and liveness of another chain.
Yeah, that's a rollup.
Yeah, so I think we have a definition now.
Yeah.
Cool. Okay, Jim, if you had a magic wand and you could wave it and fix one thing that would increase the adoption of sovereign rollups or the performance of sovereign rollups, what would that be?
Just ship faster. Ship at insane speeds.
More engineers.
More cracked engineers.
I think I'd reduce the censorship possibilities. I think a lot of the challenges that we have technically come from this idea that like we have to reduce the amount of actors that can censor you and for how long they can censor you. I think if you start to reduce that, then you can improve a lot of the UX and a lot of the performance around blockchains.
The one thing that would do the most to accelerate sovereign rollup adoption is just for one really, really cool one to ship. And then once people see how cool they can be, a lot more people will be attracted to use this kind of architecture.
Absolutely.
Yeah, so breakout applications. We need more engineers, more developers working on applications for sovereign rollup. Cool. Okay, we're kind of bumping up on time. Do you guys have any closing remarks? No?
Thank you for having us, and see you around. If you have any questions about Cartesi and so on, just meet me. I'll be around.
Yep, thank you. Thank you for coming.
And thank you for the thoughtful questions.
Yep. Thank you, guys.
Okay, we have now 10 minutes, like a little bit, not on a break, so don't go away, but just get something to drink, come back, and then we have Matthew Wang at the hour at 4. So see you all back. Okay, welcome back, everyone. We are starting again. So now we have none other than Matthew Wang here, who's going to talk about native intelligence through compute-specific networks. I can't wait to learn more about that. So give it up for Matthew.
Hold on. Okay, microphone's on. Great. So, yeah, firstly, great to be at Modular Summit here. Today I'll be talking about native intelligence through compute-specific networks. Before I get started, a bit about my personal background. I'm the founder and CEO of Valence. Previously, before founding Valence, I was a research engineer in quantum finance. I was at a fund called 2 Sigma, where I worked on research and engineering for specifically US equity options. My personal background before that, when I was in school, is in computer engineering, and I'd also spent some time doing ML research as well as HCI research. But before I dive into why we're bringing compute on-chain and why that matters, the fact that compute happens on-chain as opposed to off-chain, I think it's important to go back to the root of the problem, which is why do blockchains exist and what problems do blockchains actually solve? So blockchains exist today, and they're often touted as the technology that essentially allows for people to send money across the globe without any kind of friction that banks introduce. It's often seen as the world computer, the global settlement layer. It's a technology that is globally accessible and is also censorship resistant. And that's what gives it a lot of value, right? Because I can send money to any random address. Nobody can stop me from sending money. And it's valuable because of that. And today, with the advent of blockchains such as Ethereum as well as rollups, people are putting more and more compute on chain, right? Instead of simply sending money to other addresses, people build things such as banks, lending protocols, automated market makers, and all of these protocols live on chain, and they have all of their compute verified by all the nodes on the network. While that sounds really cool, that is actually not the case if you look at a lot of the more popular protocols that exist. You have these protocols existing on-chain with smart contracts, but you have all of the complex logic that actually power and optimize the protocol being done off-chain. And the reason for this is because blockchains are replicated state machines. And what that actually means is that every single full node on the network has to replicate all the computation, all the transactions done on the network. And this makes it extremely inefficient for things such as routing orders where you might need convex optimization, right? Doing things such as auctions where you have to embed a lot of off-chain logic that allows people to submit orders and for you to settle orders at a specific price that is optimized. And today, with Uniswap X and a lot of other protocols, all this complex logic is, it happens off-chain, on some AWS server. And this is a problem because you now essentially are forced into this trade-off, right? Where if you want to do compute on-chain, going back to the problem that blockchains are solving, you are not able to do it efficiently due to the fact that the VMs may be primitive. If you introduce a ton of compute onto the blockchain, it may be expensive, both from a computational gas perspective, also on an efficiency perspective, right? It's almost like choosing between two, I guess, not great presidential candidates. And on the other side of the other side of the coin, you have offloading all this compute off-chain, which is currently how a lot of protocols approach the problem. And you have two, again, ways to do this. Either you just say, hey, I'm just going to put some code on some AWS EC2 node, and you're just going to have to trust the compute that we're doing. Or you can, work with a ZK coprocessor, which is a technology that allows you to, write these smart contracts and, compile them into circuits. And then you can use these circuits to generate zero-knowledge proofs that can then be verified by the blockchain. If you go the former route, you now have this critical dependency for the protocol on some unverified code, which could be dangerous. But if you go the latter route, it then becomes very, very expensive for you to run this compute simply because generating ZK proofs is expensive. So this kind of is a a tricky catch-22 situation where you have to choose, your trade-offs, right? Depending on whether you want to make that trade-off in terms of trust and do off-chain compute, or do you want to, put that on-chain and make it, an extremely primitive application, or whether you want to use something like a ZK coprocessor and have again a computationally expensive process that's done externally and brought on chain for verification. So what is the solution, right? How can we find a sweet spot that attempts to reconcile all of these different trade-offs into one solution that could be a potentially a one-size-fits-all? So compute-specific networks is something we're currently exploring along with some other teams, where we are able to take the advantages that off-chain compute brings, that is efficiency, scalability, and how cheap it is, with the fact that we want to have on-chain verifiability and flexible ways of securing that compute, and have also, importantly, a very integrated developer experience where they don't have to work with ZK coprocessors, write smart contracts, or write different pieces of code that might live on many different execution environments or many different nodes. So a bit more about compute-specific networks is they will allow you to be able to build all these applications on-chain that are able to do much more sophisticated things, right? Instead of offloading this compute off-chain, you could do dynamic fee calculation on-chain for AMMs. You could have risk models that are able to adjust LTV ratios and lending protocols for risk management. You can do portfolio management and optimization directly on-chain, and have much more complex logic embedded into your smart contract. And this would allow for, obviously, much more complex use cases if you're able to do on-chain compute. From the user experience, which is intent-driven execution of transactions or programs, to optimize applications using machine learning, all the way down to optimizations you can make on the infrastructure layer. There are many different ways we can use more sophisticated and powerful compute on-chain to build kind of the next generation of Web3 applications. But now begs the question, how? Sure, you can have a network that is able to do more sophisticated compute in a way that is trustless, in a way that where security is flexible, but how do you actually build this network and make it happen? Introducing compute-specific networks. So we kind of invented this novel architecture that has to do with node specialization, where we essentially silo validation as well as computation into two different types of nodes. So you have the regular full nodes that are stateful, that are in charge of validation, and you have these specialized, beefy nodes that are stateless and in charge of computation. So a regular blockchain does not have any of these nodes. It just simply has a sequencer and regular full nodes. But with these stateless nodes that we introduced to the network, we are able to essentially offload the expensive compute that the blockchain network normally has to do to these beefy nodes in the name of specialization. And these nodes are in charge of doing the heavy compute, and in addition to that, generating any specific proofs, whether they are TEE remote attestations or whether they are ZKML proofs, and essentially propagating it back to the sequencer and the rest of the network where we have validation being done. So a high-level explanation for the kind of logic we've embedded into the architecture is that we have more centralized computation, but extremely decentralized validation of the proofs. And this also allows us to take advantage of heterogeneous compute architecture. We can have many different types of stateless nodes. We can have GPUs designed to do inference. We can have trusted execution environments designed to execute a certain piece of code with a model cached locally. It allows us to take advantage of the different benefits that different hardware architectures can bring. And this is nice because we can embed now a load balancer into the sequencer that allows us to intelligently route these compute workloads and these transactions to whatever hardware or whatever node is most suitable for it. In addition, because we have heterogeneous compute, we can also have what we call heterogeneous security as well. In addition to just being siloed to using ZK-ML, which is what a lot of ZK coprocessors would be, or that's the only choice they have when it comes to true verifiability. Because we have different types of nodes, we can also use TEEs and using remote attestations to verify the compute. We can also do what we call optimistic ZK as well, which is because these are all nodes on the network, a stateless node can make a commitment and say, this is the results I got from running some compute job. And essentially, since they are on the network, they participate in staking for the AVS that we are running. And we can, optimistically generate a ZK proof if someone submits a challenge, right? If someone says, hey, I think the compute you did might be incorrect. Now we prompt the inference nodes to actually, generate a proof, and depending on the challenge frequency, this could reduce the compute overhead by potentially 80–90% or even higher. So this essentially allows us, the TLDR would be, to not just use cryptographic security, but also use cheaper cryptoeconomic security that might make more sense in many more use cases. So a brief comparison between, bringing compute on-chain with compute-specific networks, that is a blockchain designed to do a certain type of compute, compared to off-chain. So if you have a compute chain, you essentially are able to choose very flexibly from different types of security modes, and that's nice because depending on the compute load, depending on the job, depending on whatever you're trying to run, this could make sense. Secondly, it allows you to not have to configure your own architecture. You don't need to run your own node at home to be able to run some compute job. All you need to do is submit some job onto the network, and some node on the network will take care of it for you. Thirdly, all the transactions and proofs on the compute chain are stored and recorded to a data availability layer, which allows for provenance of the verifiability and the proof. Anyone can query the DA layer and actually verify that some compute was done. And lastly, being a chain, we are able to have some notion of state, take advantage of view functions that might expose on-chain data, use oracles and all the existing tools that are nice to have today. But the more pertinent question here really is, what is the difference between a compute chain and a coprocessor? When it comes to a ZK coprocessing, they really, what they essentially do is they take some compute job, they compute it, generate a proof that you can then export to some blockchain where all the nodes verify, because proof generation is expensive and proof validation is cheap. But then you create this bottleneck where if your job is extremely computationally expensive, it might cost you a ton to run this job. In addition, it might also take a reasonable amount of time. Compute chains with our existing architecture that I'd walk through allows us to switch between cryptographic and cryptoeconomic security, allows us to choose your own adventure, choose your own security depending on your job. And also allows us to run this in a permissionless, decentralized fashion. Thirdly, like I mentioned in the architecture slide, allows us to take advantage of different types of security modes as well, that ultimately, is a flexible solution that might be a one-size-fits-all, right? And lastly, again, we also have composability between smart contracts. I can build a smart contract that interops with some other contract that exists on the chain and composably build more powerful use cases off of what other people have already built. So our first kind of product that we're unveiling is a network designed for inference compute. Without diving into the architecture, this is kind of like a slightly more detailed version of the dumbed down architecture diagram I showed earlier, where we have these stateless nodes here that do the heavy inference compute, the stateful nodes here, the core blockchain network, where we have a load balancer embedded into the sequencer that's able to offload these jobs to these nodes here, that then do the compute, generate any proofs and attestations, and then send them back to the sequencer where the batch poster posts this to DA. So in this case, we have beefy nodes doing all the work, cheap nodes doing all the validation and all the verification, ensuring that the beefy nodes are doing their jobs correctly, and a DA layer like Celestia that could potentially help ensure that we are doing everything correctly, right? Anyone could query the DA and verify that we're doing the compute, honestly. And in addition to simply just inference, we're embedding a lot of stateful precompiles that can help make these model-driven workloads even more powerful, right? Ranging from data preprocessing, like standardizing data, feature encoding, all the way to running simple regressions or running simple correlation tests and mutual information tests between different features, to statistical tools that could be helpful, like z-scoring or calculating variance of some price series, all the way to, of course, inference, right? These are all precompiles we offer on our network that help make, anyone who wants to build something more sophisticated, like a model-driven workload, more powerful. And this kind of embodies the general thesis that we have for compute chains, which is the fact that, while the network is decentralized, the developer experience is extremely integrated. You don't need to worry about your own GPU compute, your own hardware. You don't need to worry about, hosting your own model somewhere and running your own server. You don't even need to worry about proof generation, and also validation of those proofs and deploying contracts to validate it. All of that is done and completely abstracted away by our architecture, right? You don't even need to know what ZKML is to be able to upload a model and run ZKML secured inference. And that's how easy it needs to be for us to be able to kind of adopt these newer technologies and this more powerful compute to empower applications, right? We want to minimize the development complexity when it comes to something like bringing ML models on chain. And something we've recognized is that, while this infrastructure is still nascent and we're building it, there are a lot of research opportunities for us to actually just dive deeper into what exactly, makes sense for Web3, right? How can we use ML and, more powerful compute to actually empower applications so they can actually benefit users? So we've worked on many different types of initiatives internally, including a dynamic fee model that does fee calculation for AMM swaps, and we're currently working on that research with Uniswap. And we also have many other initiatives internally that we're working on, and we are also collaborating with a series of other decentralized AI projects to build what we see as kind of the next generation of Web3 AI primitives. As an example, risk models that can help manage risk for CDP or lending protocols, right? Or models that can help optimize vaults, so when volatility reaches a certain level, they can pull liquidity from AMM pools to de-risk. So if you're interested, please do reach out. We are working on a lot of cool, interesting research problems, and we'd love to talk to more people. And kind of with compute-specific networks becoming a thing, with flexible security that is made super accessible to any developer who wants to develop anything on our platform, this allows us to enable what we call native intelligence, right? Instead of having to plug in an off-chain code processor or have to build some off-chain program that does routing for your transactions, we're able to embed this all directly on-chain in a smart contract. And it allows us to do things like optimize DeFi, introduce risk management, all the way to building on-chain AI agents, to potentially making infrastructure today smarter by building, reputation models for DPINs, as an example. And yeah, we're very excited to be continuing down this route of not just building infrastructure for compute-specific networks, but also kind of getting into the research ourselves, right? And building these models and doing, the digging, the difficult stuff that is allowing us to build, more powerful Web3 applications that will define the future of Web3. So yeah, thank you so much.
Great, thank you, and right on time. Perfect. So next up, we have Shane from Stargaze, who's going to talk about real-time rollups and Bitcoin security, if we can have both or not. So let's find out.
All right, how's it going? All right, let me get started over here. We're going to talk about real-time rollups and Bitcoin security. Can we have both? All right, I'm the founder of Stargaze. Stargaze is an app chain for NFTs and more. It's the home of bad kids and Celestine sloths. Anyone here have a bad kid or a sloth? All right, now lick your elbow. No one's licking their elbow. What? Okay, anyway. in a previous life, I worked on low latency audio engines for iPhone apps, and before that, I worked on scaling Web 2 apps at Groupon. And there's a bit more, but I'm going to continue with my talk. So we're going to talk about building real-time rollups without sacrificing the values of crypto. And I'm going to define real-time here as a Web3 query or a Web3 transaction being as fast as a Web2 API call. Just a little bit of context. The thesis for Stargaze has been that NFTs are a stepping stone to bring in more users into crypto, and we want to build the best possible UX because right now we're a product for kind of crypto natives, but also at some point we want to bring in more mainstream users. We've always kind of operated as a kind of more of like a bottom-up way as opposed to like a top-down fashion. We kind of start out building the apps, and then we scale infra as needed. This way, this is kind of more how it works in traditional startups in Web 2. You can achieve product market fit. You can iterate quickly. You can get feedback from the users. I'm not saying there's one right way to do things, but the downside of this approach is we can't start with the end game first. We have to re-engineer and modify things. It's like updating a plane while it's in the middle of flight. Of course, I won't be here if I didn't believe in scaling the modular way. Instead of just scaling a single CPU or like, I mean, if you think of if you think of a blockchain as like a computer, right? You can think of RAM as like data availability. You can think of GPU as like execution, CPU as consensus, right? You just don't scale one of them. You break them out into components and you scale each one. So why focus on performance and speed and UX, right? If you look at history, speed was really important in terms of certain products like winning in their class, right? I remember when the search engine wars happened in like Web 1, Google won partly because it was just really fast. It was able to produce the results in like half a second. AltaVista and Yahoo and others, took 2 to 10 seconds or so. If you think about Uber internally, they're obsessed with the time to find a car, and they like trained this transformer model called DPTA with like graph theory to be able to like optimize the process of finding a car. There's so many other examples of this, like Amazon with their like one-day shipping and so forth, right? And if you kind of apply this to blockchains, if you have a blockchain that has really good UX and is super fast, it attracts all these users, and then that will attract more TVL, that'll attract more volume, and then that brings in more users, right? And then you can learn from them, and you can further optimize the speed and performance, and that brings in more TVL and volume. So it has this like positive feedback loop. So where do users spend most of their time? They actually spend most of their time querying data on the blockchain. They're not spending most of their time submitting transactions to the blockchain, right? They are finding yield opportunities. They are browsing around for NFTs, trying to find a slot that looks like them or whatever, right? So we spend a lot of time optimizing reads. So we built this indexer called Constellations, which is built in Rust, is super fast, is async and multi-threaded. It can index a Cosmos chain like Osmosis or something in like under 5 hours from Genesis. And this is kind of like the secret sauce that makes the website really fast. We also have a geo-distributed RPC cluster, and we have read-optimized RPCs. So like most of the Merkle trees cached in RAM, it makes reads super fast. And we're working on like a new version of this that puts the entire Merkle tree in RAM. So after you've optimized reads, you want to focus on optimizing writes. So there's two ways to do this. You can scale the L1, which is kind of like the Solana approach, right? Or you can build rollups and layer 2s. So in terms of scaling the layer 1, there's also some like lots of good research in this area in scaling Tendermint, Comet BFT. Dev from Osmosis gave a talk a few weeks ago at DevMos about how he thinks we can bring Tendermint down to like a second or two, which is going to be awesome. And then obviously the other approach is rollups, where you decouple consensus and execution. I really like this approach because you have a separation of concerns, right? You do one thing and do that one thing really well, and then you reduce the latency down to the speed of execution. And the other thing is it opens the door to fractal scaling, right? So you can have L3s and so forth, blockchains on top of blockchains. Another thing that I really like about it is that as an app developer, you don't have to leak MEV to the base layer, right? On Ethereum right now, there's a lot of talk on base rollups because people don't want to leak MEV or keep MEV at the L2 layer. But I would argue as an app developer, if MEV is the largest source of revenue in crypto, then you should kind of own that, right? So Rollkit and Celestia are great technologies to build rollups with. I like Rollkit a lot because for execution, it's just Cosmos SDK. So you can have CosmWasm, you can have EVM, you can have custom modules. Instead of Tendermint, it doesn't have Tendermint, right? So it's super fast. There's no rounds of BFT. And also, you use libp2p, which is this modular networking stack built by Protocol Labs, and it's less buggy and faster than Tendermint's custom P2P. And of course, Celestia, data availability sampling, kind of best in class. You can have this super light nodes, and the more light nodes that are running, the bigger kind of block sizes that you have, and that's all great. The other thing you get with rollups is fast preconfs, right? So because if you're running something like CosmWasm, the native execution speed is super fast, like in the order of like a few milliseconds, maybe like 1 through 5 or something, right? So your preconf speed is like pretty much just the latency of one global ping. So so now the user can like click on a transaction and do something in like 100 milliseconds, which is incredibly fast, right? Okay, so I know what you guys are thinking. This is a centralized sequencer. Like, how can we make it like not centralized and stuff like that? Well, one thing I like is Babylon Bitcoin staking. So this is not live yet, but this is still in development. But the way this works is that the sequencer signs a transaction and stakes some Bitcoin on the Bitcoin side, on the layer 1 of Bitcoin. And then it signs this extra transaction on the when it signs sequencer transactions. And then when if it double spends, it leaks that private key. And then when it leaks that private key, anyone can kind of take it and then slash the sequencer on the Bitcoin side. So this is really good. It prevents forking attacks on the sequencer side. And then another reason why I like it is that this is staking. This is not restaking, right? So it doesn't have like additional level of hypothecation. And then, of course, Bitcoin is the most credibly neutral network, most dominant currency, just lots of capital sitting around and people wanting to earn yield on it. All right, going to go into chill mode a little bit now. So going to use all this and build. We're working on Stargaze L2 called Astra. And Astra is going to be a CosmWasm layer 2. Is going to run at near native speeds. Is also going to have native yield. So we're working with Stride, Noble, and some others on native yield on it. And it's going to be running Skip's block SDK, which will enable developers to share MEV with Stargaze L1 as well. Why are we doing this? So Stargaze is kind of at a point where like Amazon was when it was only selling books. We have users that are asking for a bunch of other things. There's already something like 40 some apps on Stargaze, but we want to kind of open it up, make a permissionless environment for people to come and build new apps. And what I'm most excited about, though, is this kind of real-time rollups enable like a new class of apps, right? When everything's as fast as a normal web app, I'm really looking forward to like new kind of 0 to 1 apps, like maybe games and social media and stuff like that. So we're going to have native yield with Stride assets. Also for stables, we're working with Noble on that. And also there's a new class of like Bitcoin restaking kind of protocols that are out there that we're going to use for Bitcoin yield. So I'm going to talk about how the native yield works with Stride, and thanks for the Stride guys for this awesome diagram here. The way it works is that, let's say you're on Stargaze L1 and you want to send some stars to Astra. When you do the transaction, what actually happens behind the scenes is that those stars get liquid staked on the Stride side. Then it goes through a hyperlane yield route, and then it gets locked into a vault. So the staked version of the asset is in this vault. And then it talks to a rebasing contract that every epoch will mint more of the asset, more of like stars, for example. And now these tokens can flow into user accounts, and they can also flow into contracts, right? So this kind of opens the door to building like new different DeFi apps, because you're having yield flow into your contracts, right? So some of that yield could maybe go as like, it could be protocol revenue, it could be some kind of reward to the user. There's like all kinds of things you can do with this. Another thing that Astra is going to have is not going to have a dispute period. If you use Base or Optimism and so forth, there's like, I think like a 2-week window if you want to withdraw funds. You can go through like some other bridge, but you have to pay a fee for that. But there's this technique called pessimistic validation, and this is by Yermoon. He actually gave a talk on this, so if you want to learn more about this, go and watch that talk. But at a high level, the way this works is that the validators for Stargaze L1 will run full nodes of Astra, and then they're able to get the current state of the rollup, and they can update the IBC Lite client that's running on Stargaze L1. So they're kind of like validating the IBC connection between the rollup. So now you can just do regular IBC between the rollup and Stargaze L1. And you don't have a dispute period, right? So this is super nice. But this also opens the door to do IBC routing. So let's say there's another L2 on Stargaze, right? Now you can have like atomic cross-chain composability, because you can send IBC messages across the rollups, and without having any kind of delay or dispute period. All you had to deal with is the 3 blocks or so for the IBC transaction to happen. And of course, the end game is ZK, right? The end game is to ZK prove execution and consensus. But it's not at the level. It's not fast enough for what we need yet. But that's going to be the end game of this stuff. All right, show mode off. All right, so just to recap here, real-time rollups can give you awesome UX, opens the door to new 0 to 1 apps. It creates this user adoption feedback loop. And then native yield will give more optionality to devs. You have yield flowing into your contracts. And then finally, you can secure the rollup with Bitcoin staking. So I think this solves a lot of problems and kind of creates something new, a new opportunity for devs to build on. All right, well, that's it, folks. You can follow me or Astar Stargaze on Twitter. And that's it.
Okay, thank you very much. I'll put immediately the show mode back on for the next panel. I think it's a highly anticipated panel anyway. It's about slots, of course, and the lazy chain. And I don't think this crowd needs any introduction, so I'll let them do it themselves. So welcome, and a grand applause for this group.
Yeah. Oh wait. No, I'm here. Oh, I'm there. Yeah. We need to share for a duo as well. Oh, got it. I think. Well, come scoot down one. What do I need to do? Guys, scoot down a chair. Who needs a? Yeah. Needs a seat. Of course. Here and a mic. No, there you go. Yeah. Do it. All right. Do we have any other sloths in the house? Woo! There we go. All right. Let's start things off with everyone. I just want everyone to close their eyes for a second, lean back, and just have a short little nap. Feels good to relax and be lazy for a second. It's really great to get all the sloths on stage and all the sloths gathered here in the audience. There's a lot to unpack and explore in the sloth habitat. And I first want to start out with going into what are the sloths and where do they come from? What's the origin story of the sloths as a project? And then also, what's the origin story for each one of the panelists for how they discovered sloths and what sloths mean to them and what they think sloths mean to the broader modular ecosystem. But the origin really begins with Zaki, so why don't we start with you?
All right, I'm Zaki, the sloth father. The sloths were my idea, and worked on them for about 4 months before the mint. I'll just do a quick, for people who are not familiar with the lore, the early how the sloths were launched. So there was 2,500 PFPs. I have so much more appreciation for NFT creators. Like 2,500 PFPs were so much work. Started the idea in December. Started working with Sad Stories, Steve, SK. Steve is the artist behind the sloths and some of the other collections sort of in the family. So we started working with Steve in December. Created this concept. Created all the art. Then I think it was like April 6th or something like that. April 6th or April 7th, something like that. We had so the concept was very much a fair launch. So we did the first sort of giant 400,000 address whitelist that was on Stargaze. Shout out to the Stargaze team for making that possible. So we did this giant whitelist, and it was 1 TIA to mint, and they minted in about 4 hours. I'd been up literally the entire night getting this ready, so I slept through most of the mint, and started the trend towards laziness. And then the next day, Stefan from Noble came up with the lazy morning concept. We fired up a Discord. Everyone was a lot of people before launch were like, hey, how is this thing going to even work without any like marketing or hype ahead of time. It was like sort of a stealth launch. And if you just had to like follow me on Twitter, and then Nick tweeted about it, and it kind of blew up to find out about it. But like, yeah, and now I mean the community has been going strong for since then, and lots of new people, like these fine people, have joined, and they all have their own origin stories about how they got involved in the community. And I think we really like my motivation for creating it was, you know, I've been involved in the Celestia project in one way, shape, or form since 2019. And I really wanted to create sort of a cultural institution, and it's going pretty well, which is definitely a new hat for me to wear, but it's been fun.
Awesome. Yeah, I guess Saki, you have like a weird path. I think we were talking about it just before. He went from like founder to like NFT influencer, and it's usually like the opposite, right? So yeah, no, for me, like I think I found the slots because I saw that Nick made them his PFP. So congrats, Nick. He's definitely very lazy. And then I also saw that Andy from the Rollup, I think he also did it, and I was like, okay, these guys are up to something. Like, let's. I didn't actually get to mint, but I bought some like pretty early, like right after they minted. So also got pretty lucky, I guess too. It was super late for me. I think I also had to go to sleep. So yeah, definitely like it's nice to see that like everyone's story is sort of like somewhat related to sleep. And then I also started managing the like Twitter account. I just randomly, like as an anonymous guy, like DM'd Saki, and I was like, hey, you seem like you need help. So yeah, and it's been like community run like ever since. And I'll pass on the word to Jermund because I'm sure he has a cool story too.
Thank you. Yeah, I also did not join the mint because I was asleep. But yeah, I just saw all the buzz on Twitter. Is it closer? Okay. Yeah, I just saw all the buzz on Twitter and immediately felt the FOMO. But what kind of got me really into this was more like the whole modular thesis has sort of resonates a lot with me. I think it's sort of the way to do like the whole app chain thesis. The modular thesis is sort of how you do that in practice and at scale. And yeah, I'm a developer, so, and as everyone knows, developers are super lazy. So it's just, yeah, it resonates on every level for me, essentially. And yeah, during the Celestia hackathon, that was quite recently, I started building like a lazy chain for fun as a secondary project that I did. And yeah, just been somehow involved in all of this after that. It's been a fun, not so lazy journey, actually, but yeah.
Did you fall asleep after you minted, or no?
Oh yeah, sorry, yeah. So I just, immediately when I woke up and casually scrolled Twitter and got the FOMO, I just had to buy a couple.
Okay. So I'm coming from cryptography and encryption background, which is pretty weird. So I'm founder of Fairblock, and one of our challenges is that when we talk about encryption in the space, people think about like Tornado Cache or things that are not really making sense for like real users. But in the real world, we have encryption in all of the institutions for all of the applications, and I'm a really big believer of like on-chain encryption. And I was always impressed by how Crypto Zombies educated a lot of developers in a very fun way and an interactive way. So I was like really working on gamification of our encryption modules and how we can have that. And so, I don't know, I was sleeping and I saw Zach in my dream, and he told me that we can use this kind of modular talent opportunity that we have here to build games using encryption and using the community to show a very different aspect of encryption. So with encryption, you can have like on-chain games, multiplayer games, which is like a very different kind of story that people can have like a very tangible experience of what you can actually do with encryption.
I love it. That's a great background. My own origin story about sloths is I happened to be online and I saw someone tweet about the mint. I think it was some Stargaze employee, or maybe it was a Stargaze account. And I was like, I had heard rumors about it. Zaki was actually very good at keeping it a secret, believe it or not. A lot of people are like, oh, well, you had insight or something. That's how you got the mint. I did not. I just was lucky.
No one thought it would succeed. That was like the biggest. That was the biggest thing. Like all of the people who knew about it, most of them didn't even bother to mint.
Yeah, and luckily I also live in Hawaii, and so it wasn't that late for me. It was probably like 2 p.m. or I don't know, 3 p.m. So I minted, and I was like, this is sick. I immediately made it my profile picture, and then I just kind of signed off and went to sleep. And then I remember I woke up in the morning, and like the floor price had gone up like crazy, and everyone had minted, and it was really cool and astonishing kind of to see how quickly it took off. So I want to talk. I do eventually want to transition into talking about the lazy chain, but before we do that, I think I want to dive a little bit deeper into like this kind of connection between technology and community and culture, because I think this is really what sloths, like the value they've brought to the modular community, is that modularity so far has just been about like a technical narrative, right? It's been about something that it's harder for people to relate to. And I think what sloths have done is created this sort of like Schelling point for this mostly sort of technical narrative and community to gather around and create culture and have fun and to identify with, right? Like when you rock a sloth PFP, it kind of is a flag that you stand for modularity and you're part of this broader community. And so I guess I want to just hear your guys' thoughts on that connection and what you think the sloths mean and what value they bring to the modular community generally.
I wouldn't say that I've like fully understood what sloths could be when I like came up with the idea, right? I thought that yes, that there would be like there was a need for a little bit of a cultural like oasis, like rallying point, Schelling point, watering hole, etc. for the Celestia community. That like, but so like why sloths is probably so like. When I started contributing to the Celestia project, it was called Lazy Ledger. Mustafa's original paper about the idea of the sort of modular blockchain was a paper called Lazy Ledger. The project was originally called Laser Ledger. Laser Ledger was a far harder project to raise money for than Celestia, but I always kind of had a lot of affection for and felt like a connection to that old Lazy Ledger name. And was sad that it was gone. And then like sloths are cute, adorable animals. I've always liked them. I felt like they were. But I think like one of the things that is sort of key to the success of a blockchain is a community tells a story together. About why like a technical platform, why a technical architecture, why something is possible. And in the early days of cryptocurrency, when I got into cryptocurrency in 2013, it was very like that was a very common thing like around Bitcoin, Ethereum, different altcoins had their eras, and there was a lot of shared storytelling. And I think as we've gotten into the world of hundreds, thousands, tens of thousands of coins, it's become a lot harder. Also, it's a lot harder when your coin just becomes useful for things. Like it's harder to tell stories and feel an emotional connection when something is just a useful financial object. And I think these PFPs can be a mechanism for us to all tell a story collectively about this modular vision, about verifiable computation, in a way that's like very accessible to people, because a bunch of stuff that like PhDs, computer science PhDs understand is not super accessible. But like we can all enjoy an adorable sloth picture.
Yeah, awesome. I think that hits it like pretty well. Like I think actually like sloths have like slowly like became like advocates for projects in the like modular ecosystem, and I think it's something that it has been like great to see, because it's something that projects like I feel like they really need this, because it's like the modular ecosystem is amazing, like the tech is amazing, but it's very technical and very academic, and it's like. For me, it's a way to like onboard more people who are not necessarily on the modular ecosystem but are interested in crypto, or like are doing like, I don't know, like gambling on meme coins on Solana. and things like that. I feel like sloth are like a much easier touch point to like onboard these people, and also for, again, like as Taki said, for projects to like tell their story and sort of like be more relatable within their communities. And I think projects like they also like really recognize that, and like they started like engaging with us like way more. And it's been like truly amazing to see how like that vision like comes to fruition. And actually like also like I feel like one of the things that makes this like really good is also like the community. They're just so active because they really got like all these people like rallying behind the like slots idea. And like now like I see many people from here from many projects, like the guys from Stride, Achilles from Forma, and like you can ask them like every time they post something, there's slots are gonna be there, and like they're gonna support them, and it's really something that is super nice to see, and that I think also projects like to have an engaged community.
Yeah, I definitely agree with all of that. I think for me, what makes this community, like the Slav community, so unique is the like this merging of like technical people and just anyone who sort of believe in this thesis and this ecosystem. So it's I feel like there is a very special potential for that to do more than just be PFPs as well, which is I guess what we're gonna get into later. But yeah, I don't know. It feels like there's something unique there that's just hard to replicate without it coming organically like it has. So yeah.
Yeah, for me it's like in Civilization 1.0, in like Roman Empire, we have like pools, and in Civilization 2.0, we have like golf clubs. And right now we have this kind of on-chain golf clubs that a lot of important creative or like really technical people join together for some reason. And it accelerates some kind of really interesting ideas. And this was my personal experience. Like we had a lot of interesting ideas surrounding steel deductions or other stuff. And it's really hard to execute some kind of your ideas with other businesses, at least in this industry. But when there is like some kind of community and some kind of motivation and passion, even if it's just a joke, you actually get to integrate with like for very serious projects much faster. And that's really interesting for me. It's like a very interesting phenomenon that is happening.
Yeah, I think that's a really good point. It's like a good way for projects to also like bootstrap like their GTM like a little bit more, and also like to like if you want people in like your space, like yeah, slots can actually like I feel like that's also like a really good point.
Yeah, my perspective on this is that I think Zaki tweeted out something along the lines of, each major community kind of has its sort of main NFT collection for whatever reason. And I think, for Solana, Mad Lads, for Cosmos, Bad Kids, for Ethereum, I don't know whether it's Penguins or it's CryptoPunks or whatever. Right? Yeah. And then I think for Modular, so far that's very much sloths. And it's kind of just an interesting pattern across these ecosystems that the community does tend to rally around one central collection. And it really does provide a new avenue to engage people and attract them. Like, I mean, we have the evidence here on stage, like, Paco and Germund wouldn't be here, I don't think, without like the sloths. Like it's brought in all these smart, talented people that were there, but they didn't really have an avenue necessarily to engage, I guess, with Celestia, the modular community, and sloths like have been that conduit. So anyway, I want to shift gears a little bit now to the theme of this conference is modular expansion. So I want to talk about lazy expansion and sloth expansion, right? What's been so cool is that the sloths, I feel like a lot of NFT projects fail because, they make their collection, they mint them, but they don't continue to grow and expand the functionality or grow like the cultural relevance and things like that. And what's been so cool is that in such a short amount of time, the sloths community has sort of already started like taking this project. There's, I think ongoing right now, a mint now on Forma for habitats, which is like a new collection associated with the sloths. But more, and we can talk about that, I'm happy to go into that, but what's the most exciting thing to me is this new project called Lazy Chain that's emerged out of this. It's funny because I also remember tweeting after the sloth mint like a joke, which was like, oh, funny idea would be sloth chain, where it like makes one block every hour or one block every day or something, right? And I never thought that someone would actually build like a sloth-themed chain, but then here we are, and we actually have Lazy Chain. I don't know if the block times are going to be slow or not. You guys can tell me, but let's talk about Lazy Chain and what it means. I mean, Zucky's also one of the first people I've heard who talked about this idea of meme chains, like expanding beyond just meme coins and NFT collections into chains that are sort of meme focused. And it sounds like a joke, but actually, I think it becomes a way of again, like adding more culture and making the meme even deeper. It's not just like a coin, it's something that's like a whole ecosystem around it. So let's talk about like Lazy Chain, like what's the inspiration, what is it, what can people expect? Will the sloth NFTs migrate there to have a new home? I don't know, like free for all, whoever wants to take this.
Yeah, I don't know. I feel like Zaki should lead on this, but yeah, I think the main idea is to have a modular home for the sloths, a place where experimentation and like you said, where the meme can deepen. I think it will definitely have a way for at least the sloths to travel there, as in a bridge there using ICS 721.
It should be really slow, by the way. It should take them a long time.
It really should.
To get there.
Yeah, I think you guys should like think slower. I think we could like, of course, like this is just a joke, but it's like it would be fun to see like a chain with like 100-year blocks, and you can burn your NFTs or like whatever that way. But anyway, no, I think so. The way I see like Lazy Chain is, I think with a collection of like 2,500 like NFTs, you can only reach so many people, right? There are only like, their collection can only be so big. And like with a meme coin, like it's also the same. You can only, there's so much you can do with the meme coin, and there's just not that much to do. And like this is like a natural cultural extension for like the sloth collection. And also like, I feel like it's a really good avenue for like modularity to onboard like users that have been like hard to onboard for like this ecosystem as well, which are like more like crypto, like people like maybe like more like crypto native people that like, you know, like they like to like do stuff with meme coins. They like to like speculate on things. Like they like to gamble. I'm also like that, so definitely not judging anyone. But it's like, I feel like that this is the avenue to like onboard a lot of people into the ecosystem, and it can be sort of like that really like that first touch point and expand the collection without necessarily like diluting it and actively like accruing value to like those like 2,500 slots. And I'm definitely like very excited to see like this vision like come into fruition. And as Jermon said, it's all like a really big experiment. And I think if we also like manage to like build like a really strong community like we already have and like expand this, I think it could also be like a really good way to like support projects building modular with our community and send them to like, you know, like help them with GTM and sort of like make it like way easier for them to like build whatever, pretty much.
So I guess the way I think about Lazy Chain, and in general, integrations between slots and the modular ecosystem, is imagine if the only way you could engage with slots is kind of like what people have done in the past. Oh, you can like have a Discord role, you can like prove membership of slots, like we can engage with them on social media. Okay, like this is gonna run out of steam. Like there's only so much that you can do there. But what if, you know, you can launch an app and like onboard a community of people who are, so you know, Fairblock is trying to bring apps to market that show the power of their encryption technology, and do it in a way that is like direct to users rather than sort of like B2DAO or B2C or B2B sales, the way, you know, sort of infrastructure technologies. Like what if you can create like fun, engaging experiences? And I think a lot of founders who are building in the modular ecosystem are looking for these opportunities to engage with end users. Like infrastructure technology and crypto in general has this problem of it being like many layers buried below users, and like the only way in which people really experience it is like, you know, talks at conferences, and they go to a party sponsored by the infrastructure company, but like nothing that they can really use. So I think the reason why so there's like been a couple of guiding principles for me. One is we are very long way from having the sloth chain, because I think there are going to be many chains. But lazy chain is a great starting point. And there's like a ecosystem of projects that are like ripe for it. But it's not like we're going to like migrate to one chain and this is going to be like the only chain and everything has to like be there. That's like not in the spirit of modular expansion. The spirit of modularity is the spirit of abundance. That like an endless number of chains, an endless number of apps, and an endless number of experiences. And sloths need to embrace as a concept this idea. So we do things on Forma. We're gonna build, you know, seed and build out lazy chain. You know, I'd like to do something on Initia. I would like to see integration after integration after integration. And what's the point? The point is to continue to give people an accessible place to access this information, like infrastructure technology, to engage with it, to be excited about it, without just sort of treating it as like, you know, a bunch of like sort of passionless like computer interfaces.
Think slower.
Yeah, for me, like, I think for having a long-standing, healthy community, like a soccer club, you can have the fans, but you still need the game. You need some fuel to talk about and some jokes. And when you launch an NFT, it's already done. Like, you should like make it alive, like keep it alive. And the other thing that I found it really interesting was like CryptoKitties, because it was the first time that it highlighted the problems, like deep problems that we had in the infrastructure level in Ethereum. It highlighted the MEV problem, and like it even changed the whole roadmap in Ethereum. So there is two sides of the things. When you have this kind of games, you can make a lot of experimentations, keep the community engaged, make a lot of like encryption-enabled games. Even with CryptoKitties, it failed because like the breeding algorithm can be reverse engineered, so you can encrypt it and keep doing that. But there's the other side of the thing, which is when there's a lot of people engaging with that, it's like inside of your mind, you're thinking about that, you're interacting with that, you're testing that, you actually find out about very deep problems, very technical problems.
Yeah, I feel like the ability to do these things is to me feels like the core of like the modular thesis. No, it's like to be able to make these experiments to like implement, you know, fair block on with this, and to add all these experiments and games and whatever. Like if we were to do like the old route with like spinning up a chain with all with a full validator set and having to do all that stuff, it just wouldn't work out. It would probably end up with some sort of coin going to zero. And yeah, I feel like this sort of showcases also like just the ability for like an NFT collection to spin up the chain, do whatever they want to do with the requirements that they have, be that slow blocks, be that some special integrations, you know, build new stuff that you just can't do anywhere else. Yeah, I feel like it's just perfect for brings the whole modular thesis into reality.
And it's really beautiful to see, because I feel like it's something that would not have happened if like it was not so easy to like spin up a chain. Like as you're saying, like getting all your validators, not too lazy. So that's something that it's that like a big catalyst is also like the modular vision, because I feel like otherwise it would be impossible.
Too lazy to launch an L1.
Yeah. Like I've made a lot of blockchains at this point, and
this is true.
They usually are been like multi-year journeys to like even get, you know. I think like probably the fastest I've launched a blockchain is like probably under a year from like conception to launch. And I think if we can do lazy chain in like a month, that will be a great demonstration of what is possible. But I think it's just about, it's also about by like reducing all of this stuff, we can build blockchains in a much more community-oriented way. Like you don't need a VC round to build a blockchain if you can build it quickly with like minimal resources. And I think this like gets us closer to that community computer vision, like sort of community computer vision. And like why I think actually meme chains actually have a really important role to play, because they are a way of bootstrapping a community-owned platform without like a lot of sort of capitalist, fundraising and capital and like interacting with capital markets pre-launch.
I forgot who mentioned that, but like I also found like in one of our Twitter spaces, someone mentioned that like we can have the ephemeral kind of chains. And it made a lot of sense to me because like in all of the actual games, like, I don't know, Call of Duty, when you're playing, there's a lobby, there's a like temporary server that everyone joins that. So if you want to play a game for a week and it's not like interesting anymore like after that, or if you want to have like one voting for the whole community, you don't need to pay for all of the infra costs for like 3 years for like a couple of applications. So that was really interesting point of view that we have never seen in crypto.
Yeah, I think ephemeral chains is a very cool concept. Like if you have some sort of big mint, NFT mint, for instance, you could just spin up a chain for that. If you have some sort of event where you need something like this, you could just spin it up and then shut it down when you're done. It's yeah, and I've seen some cool examples of what could be done with that, and yeah, the modular thesis sort of enables new use cases like that, which just would not be feasible otherwise.
Yeah, I think like the use cases are like endless. Honestly, like what we could do in like Lazy Chain, honestly, it's I feel like the full spectrum is like really broad, but I feel like it's just about like like trying new things, like seeing what works and also like what doesn't. Like as Sagi was saying too, like maybe like doing like a fair launch and like trying to see like what's the best way to like actually like launch a token nowadays, because like there's like a lot of like debate around that topic, and I feel like it's not like a recipe. It's not like, oh, you do this and it's gonna be successful, but it's like how can we actually like try new stuff that might work. So and yeah, like maybe like break things in the process, but definitely learn a lot, no?
Yeah, I think Lazy Chain to me, kind of as what you guys have just said, is the sloth community and like the modular community putting their money where their mouth is, in a sense of like, okay, yeah, part of the modular thesis is that it's really easy for anyone to spin up their own chain. It can be a place for community computing, things like that, and like we're actually demonstrating that in reality, like putting our money where our mouth is by launching a chain in a matter of a few months. And so it's really exciting. And it's also really cool because Fairblock is also demonstrating not just that it's easy to launch your own chain now on the modular stack, but also that you can customize it and add new capabilities that aren't possible, if you're building an app on a standard monolithic chain. And like the sort of like randomness and encryption and the things afforded by Fairblock are quite unique in that sense. Specifically, there's a game, right, that you guys are building as one of the applications on Lazy Chain. Do you guys want to talk about that?
Yeah, we've made a murder mystery game named Lazy Killer, which is like you can sign in with your sloth, and then there's a story, you can read the story, and in like normal blockchains, when you, like the whole game is on-chain, but if you want to implement that in like Ethereum, the problem is that everyone can see your hand, right? So in real world, when we are playing games, you don't show your hands, right? There is like some kind of confidentiality. So when we build this game, we are actually encrypting your suspicion of the murderer, and once the round is over, we will decrypt it on-chain, and the whole execution is happening on-chain. So it's just like one kind of example, and we are thinking about like other kind of games that we can enable with this kind of logic of like surprises or like encrypting and unlocking something, and even with our randomness relation.
Paco, do you have anything in terms of other fun applications that you can see in the near future? Or also actually tell us a bit about like habitats and sort of the plan there. Is there going to be an interaction between habitats and sloths? Are we sponsoring an actual real physical habitat somewhere?
Yeah, so I feel like there are a lot of things like coming on that front, and also like shout out to like all the teams that are helping us on like Lazy Chain. It's definitely been like really, really amazing to see like that vision like come into fruition. I think habitats that are just like, well, I feel like we made like really, really like top-notch art with Steve. Big shout out to him because he really like the art is like really, really amazing. And I feel like the idea is always to like, like use also like formats like capabilities, like as Saki said, like to sort of like make it fun and also like maybe like experiment with like metadata a little bit. But of course, like habitats, they're gonna play like also a big part on like Lazy Chain, and potentially we could do like a habitat too. Lazy Summit, like who knows? And yeah, and I feel like the applications that like can be built like on top of Lazy Chain, I feel like they're right now like they're endless. I would say like we're talking to like also like many teams, and like they're also like excited to like try new things. Like for example, I was talking with the guys from Stride yesterday about like maybe like doing like LSTs for like creators. We can also like do like many like gamified things like the guys from Fairblock are doing, also like powered by encryption, because I feel like that's something like really powerful. You really can't play many games on chain now because of encryption. And like think about it, like if you're playing something like RuneScape and you're like you have a lot of like gold or whatever, like you don't want everyone to see like, oh, this guy has a lot of gold, because it makes you a target. And I think that's really powerful. So kudos to you guys on that. And yeah, I feel like the things that we're gonna build on Lazy Chain are gonna be very fun and also like awesome.
All right, guys. Well, we're coming up on the end of the panel. So, do you guys have any last thoughts or messages for the sloth community, the modular community at large?
So I think the biggest thing that people should take away from this is sloths are not just about airdrops. That there's a larger experiment that is, I think, somewhat unique in terms of like where sloths appeared in the life cycle of the project, how sloths are like being integrated into the general culture of modularity and Celestia. And this is a really fun and exciting community to be part of. There will be ups and downs and dramas and all kinds of stuff, but the sloth journey is just beginning.
Yeah, I mean, I'll tell honestly, like everyone to like, I feel like the community has really like been amazing, and it's what makes this. So I'm very happy for that, and I feel like yeah, we got a long road to like go through. Maybe not to launch the chain, but to make it like something like really godly that unites people and also like helps people building in the modular ecosystem. And I think last words, just like well, stay lazy and think slower.
Yeah, I would encourage builders who are keen on joining up with a bunch of other really great builders. I think there's a lot to learn and a lot of fun to be had. Yeah, I think it would be great to reach out and chat about if you have ideas, or if not, we have a lot of ideas. So yeah, stay lazy.
Yeah, for me it's like an endless area of creativity. We are like chatting for weeks, and every day we are coming up with a new idea. So I'm pretty excited to execute the new ideas that you'll hear soon.
Awesome. Well, thank you guys so much for coming to listen. We are going to be, I guess, ending the panel now. I think it'd be great to show off your guys' sloth jerseys and see like the actual PFPs on the back, which is pretty sick. So shout out to, I think it's Viet and I guess Paco. You guys spearheaded this.
No, Viet did almost all of the work, yeah. So
yeah.
I just handed them out basically. But Viet, big shout out, man.
Yeah, Viet is the one who dreamed up the jerseys and executed them and found the vendor and was super nervous about how they would turn out, and they are beautiful.
Yeah, and you ended up bringing Dua Lipa after all, Paco, right?
Dua Lipa, but with 2 L's. Ooh. Oops.
Anyway, all right, thank you guys very much. Thanks for coming.
Test. Okay. We'll do a small break of 5 minutes before we continue with the talk about Milky Way, the Modular Staking Hub. And yeah, please come back in 5 minutes. Thank you. Good.
Hello. Yeah, mic test.
tell me? Okay, perfect. Okay, welcome back. So as said before, now you have here JB from Milky Way, indeed, who is going to talk about the modular staking hub. Give an applause.
Mic test. I love you too, John. Hi, everyone. It's great to be here at Modular Summit. The venue is amazing, and I hope you guys are all enjoying every moment of your time. One of the best things for attending an event like this is to meet great-minded people and highly intelligent people. Yeah, so my name is JB. I'm one of the co-founders of Milky Way Protocol, and we are the first and largest liquid staking provider for Celestia that launched last December. And today, my talk is about something that we've been envisioning and building towards the modular staking portal that serves both liquid staking and restaking protocols. So I found a liquid staking opportunity sometime last September. Our team is assembled around October, in the beginning of October. And with colleagues from Tendermint, the founding company behind Cosmos, Josie and June, they're co-founders. And we're on this journey together. Our objective was clear. So build the first and the best liquid staking solution for Celestia. And we put our heads down together for 2 months, and we successfully managed to launch our fully audited product on December. For some context, existing liquid staking providers could not support Celestia base layer because it simply isn't compatible. I'm sure some of you from the audience already know about this. Celestia's blockchain, their core value is minimalism, and they don't support execution environment, meaning they don't have smart contract environment, nor what's called the interchain account that Cosmos existing liquid staking providers use at their core. So you might wonder, how do we work around this then? So we came up with our own design called the Auth-Z delegated multi-sig design. So it's the design that bypassed the technical constraints of no smart contracts or no interchain account. So if you take a look at the diagram here in the slide, this is basically the demonstrates liquid staking process. So I'm going to give you a brief explanation about how it works from a user's data flow. So there's a staking contract on Osmosis Layer 1 blockchain, and users liquid stake their TIA into the staking contract, and the contract transfers the deposited TIA back to its base layer, which is Celestia chain, specifically to the multi-sig account that's managed by 7 trusted and reputable operators. And at this point, you might think that multi-sig, it's at the end of the day, it's multi-sig, so it's very risky because there has been many multiple hacks involved with multi-sig based protocol in the past, right? But our design is significantly reduced the risk of getting hacked because we leverage the native Cosmos SDK module called Auth-Z module. So basically what this module does is to allow granting a set of permissions from one account to the other. So multi-sig key holders don't really need to sign transactions on a day-to-day basis. I'm not going to go explain the details of how it works at a technical level. There's a documentation in our website that has the in-depth technical specifications. So if you feel interested in getting to know more about it, feel free to check it out. Or you can ask me, after the talk. So the beauty of this design is, like I said, private, operators, 7 operators, they don't need to expose their private keys to the internet because, we use the Auth-Z module to grant a set of permissions to this grantee account, and this grantee account executes transactions on behalf of the multi-sig account. There are more details into the design, um, but since there's a documentation that has in-depth technical specification, you can read about it if you're interested. So we took the first mover advantage as a liquid staking provider for Celestia. And thankfully, we received tremendous support from the community. And the TVL grew to over $50 million in the first month. And a number of users continue to grow over time. And we were actually the first Cosmos liquid staking token listed in Ethereum World as well. And our LST is usable across 15 plus dApps and DeFi protocols. And it can be usable as a sequencer fee as well. And we have a great partnerships established with Manisha, Barachain, and Movement, and all these like promising L1s that are going to launch mainnet soon. And there are more promising projects that we're in discussions. They're in the pipeline. So modular staking portal. This is the restaking part. So restaking is something that we've always had interest ever since it was getting so much adoption with EigenLayer in Ethereum, and we decided to take some time researching and conduct some due diligence on whether restaking is needed in the modular space. So we have spoken to various different parties, whether they're AVSs on EigenLayer, operators on EigenLayer, or upcoming projects in the modular space to see whether restaking is really needed in the modular space. And we came to conclude that there's a clear demand in the modular space for restaking because they have a pain point of bootstrapping their security in the beginning. I'm going to go explain this a little more detail in the next slides. But as you can see in the slide, there are 6 AVSs that we have lined up already. They're Blackwing and Margin, working on the margin trading platform, and Oho Network, their Oracle provider, and DMAX and Tucana, they're the multi-chain DEX protocols, and there's Initia Bridge, which is essentially IBC Bridge that we have solution to allow them to become an AVS on restaking. And also the Milky Way rollup as well, as we are transitioning to become L2, which is called the Initia in Initia ecosystem. So operator-centric model is restrictive. I should have titled this as it is not actually the restaking problem. These are the pain points and areas of improvements that I see in the major restaking protocol. So the first point is a one asset dependency. A lot of the projects that we have spoken to in the modular ecosystem, they have a desire to be secured by multiple assets rather than a single asset because they don't want to expose themselves to a single asset. And they also mentioned that they want to include their own asset in the future when their market cap rises high enough. So that's why our design goes for a multi-asset design. We want to allow we want to become the permissionless and the practical staking as possible. And the second point is restakers have no control over their capital. So what does that mean? So if you look at the major restaking protocol, they're all operator-centric model. So restakers restake their assets, and they delegate their restaked asset to a single operator, and the operators choose which AVSs they want to opt in. So if you want to opt out a certain AVS, like the bridging protocol, because they have a bad reputation from previous hacks, or you just don't like it, or for some reason you want to opt out, but you don't have any control over your capital because operator has control over, chooses which AVSs they want to opt in. So, and the third point that we observe is there's no slashing options. So we think that there should be multiple ways to, slash a misbehaved operator, rather than just burning their asset. You can also give, you can also not give them any rewards for a certain period, or you can just jail them for a certain period as well. And the last point is a time and efficiency for operators. So in the operator-centric model, operators have a lot of responsibilities. They have to conduct due diligence on which AVSs they want to opt in. And they also have to do some marketing and sales for getting as much delegations as possible from investors and restakers. And they also have to read the guideline of AVS, how to run, how to set up, how to build a robust infrastructure. So this is, this gives operator a lot of responsibilities in the model. So we want to change that. So here's our design. We spoke to a lot of the AVSs, operators, and on EigenLayer, and we researched how a restaking, like the modular restaking layer, should evolve in the grand scheme of like the modular vision unfolding. And this is how we came to conclude that the design must be, maximally flexible, versatile, and it should be extensible. So we are using the Cosmos SDK framework, which is very customizable, flexible, and it can support multiple virtual machines as well, and it's also battle tested. So the essence of this all boils down into a single concept called programmable roles, which you can see in the slide that the diagram literally shows. So we have a lot of programmable roles. There's an asset allocation role, which is inside the delegation roles. There are multiple slashing roles as burn, jail, stake as well. So I'm not gonna go explain into like every roles here. You feel free to read it through in our documentation. But it's just want to point out that it's very extensible, and the whole philosophy behind our restaking design is to solve the pain points, the actual pain points of AVSs and operators. So the key to we think that the key to success to build the restaking protocol is that AVS, must be, to solve the AVS's actual pain points, and if they win, then our restaking protocol wins. And there are multiple, AVS use cases that we're exploring, and we can have basically anything that requires its own validation services. And Oracle is, one use case that we are having. So the key benefits for Oracle AVSs, they can bootstrap their security from, various different restaked assets. And they can also decentralize their price feeders with operators. So the diagram here in the slide is, as you may know, there can be multiple types of Oracle designs, whether it's push-based or pull-based. But this diagram literally shows the push-based Oracle design, where price feeders proactively post their, data to the network or a smart contract. So we can, our restaking design can decentralize their price feeders with operators. And they can also discover potential clients in other AVSs as well. And this is another use case, roll-ups, but I'm specifically referring to L2s in Initia ecosystem. They're called Initia. So for those who are not really familiar with Initia, but I'm sure a lot of you here are already familiar with it because Initia had a big event recently, Inter-Uven Day. So Initia is a network of inter-Uven rollups. They're on a mission to redefine the multi-chain network. So their L2 is called Initia, and we have multiple AVSs lined up already for our restaking protocol. So the key benefits are literally the same, but we can increase redundancy and we can decentralize batch submission process for Minitias. There can be other use cases like bridges, DA providers, virtual machines, cryptographic schemes, and yeah, you name it. Anything that requires its own validation services, they can be, our AVSs. Yeah, thank you very much for listening today. Yeah, and we look forward to building and continue to building and evolve our liquid staking and restaking, and bring use cases for the modular ecosystem. Thank you, and let's get in touch.
Okay, thank you very much for that and for the enthusiasm on the first row. It was appreciated. Our last talk of today is from Ritual, where Sanil will go into the overlap between AI and crypto. So give an applause and yeah, welcome to the stage.
Hi guys. Oh, that's a terrible fucking picture of me. All right, I will get started. Ah, there we go. Fuck. Okay. All right. Hi, guys. I'm Sunil. I'm a founding member over at Ritual. And today I am here to, give free-form thoughts, explain what Ritual is, and give free-form thoughts on AI and crypto, because potentially one of the most grifty spaces right now, and I'm here to help you guys distill what's actually real. So I'm not going to go spend too much time on this. I don't think I need to explain that AI is probably the fastest growing technology of all time. AI is eating the world, blah, blah, blah. All of us here know that. But I do want to talk about the structural challenges of AI. I think there's been a lot of development in AI and crypto that's revolved around like, okay, we can make this part better. In theory, some part of this is like centralized, but like what actually matters, right? And why does this actually matter to users, not from like an ideological perspective? Obviously, decentralization and censorship resistance are important, but unless people actually care about it because it affects the quality of life or the products they can build, they don't really care. And the reality is that currently the state of AI is really highly centralized, right? The best models are owned by a few select companies, and that has real actual implications. First and foremost are, one is censorship resistant. A lot of these models that come out of OpenAI and Microsoft or Google or whatnot, Claude, will never be able to encapsulate an entire value set or do certain things because they, it's in their interest to curtail behavior of the model that does not fit within the current regime, right? So if you go to OpenAI, that model is extremely like Western biased, right? It will not tell you how to do certain tasks, right? Sometimes for the better, but sometimes it's like very, very heavily curtailed. And this is really because a lot of the alignment and a lot of the red teaming that goes into this model is a bunch of Silicon Valley engineers that are sitting in a room and saying like, okay, this is what the model should be. The reality is it doesn't express the value set of most of the world or even touch on a lot of the utility that the model could do, largely because it exists within the US regime, right? So that's one thing. And then two is like structurally accessing these things is like actually hard, right? If you want to go and use OpenAI or Claude, you need to be able to pay in US dollars. And if you can't, then you're kind of screwed because that's the only thing their API takes it in. Now, on the other end of that, there's like plenty of open source models that you could probably go and use that equally will get the job done, but either downloading them or accessing them is hard, or we'll just start to see maybe even though we've managed to keep parity in open source land, we'll start to see maybe a degradation of quality relative to closed source because there aren't the right incentives for open source models, because largely when you centralize, you can build your own payment rails and you can build your own methods of distribution, but most importantly, you sort of keep the secret sauce or the weights in-house. There's actually like no good way to, one, do provenance for open source models, and two, monetize them, right? However, and I just talked about impact, censorship, weaponization, blah, blah. However, this is where crypto comes into play, right? What has crypto like definitively been good at, right? I think if I look at least my experience with the past few cycles, both being an investor and operator, crypto does a really good job at creating new monetization schemes for open source software. It does a really good job of providing a incredibly neutral layer for sort of like provenance, right? And it does a really good job of creating a general purpose layer for application development, right? Which is actually highly relevant, I guess, to the theme of modularity. But the idea is that when you have any sort of execution layer, right, you basically have one big open backend. And that means that the composability and the speed at which applications can be built are massive. So right now today, if you wanted to go use an open source model, you have to go to Hugging Face, download it, deploy it to GPU, build the application around it, right? In comparison, if you could write a smart contract over the model and access it natively, and that model is run somewhere in the network, then a bunch of applications go tap into that. All they need is Solidity or Rust or whatever the language of your VM is, right? So when you take those three things, there's a lot of things structurally that crypto can help solve in AI, right? It's not just like, okay, boohoo, we should decentralize AI because we want to give too much power. The reality is that you actually increase developer velocity in the design space when you can make AI accessible in a crypto-native way. You can open up payments, you can open up accessibility, you can open up incentives for open source model development. All of that can and will be solved. And, and this is primarily what Ritual is really focused on, right? When we started Ritual, we really came down to the question of how do we make AI accessible to all? Not just all in the sense of okay, we want to juice this nice narrative and have some crypto AI bullshit applications, but truly all, right? If you were to ask me today what my end vision for the Ritual network, I want every model that comes up, a new model, to be accessible on the network. And we realized that the only way to do this was to build dedicated sort of infrastructure around being able for users to be able to run models, make them available for end application operations, so things like inference, quantization, embedding, distillation, and also provide a general developer platform for people to go and access these models in a way where model creators are rewarded for it. So we wanted to build tooling that makes it, basically best-in-class tooling for allowing developers to coordinate sort of the best of crypto, the best of AI, and also fold in any of the financial and cryptographic primitives that exist in crypto into the AI supply chain. So our phase one, which is complete, and we have people building on our phase one, is Infranet, which is our decentralized Oracle network. This was really our first phase to see if people want to go and use models on chain and actually do this. So the way it works is you have a bunch of nodes. These nodes are running models. We have an on-chain set of contracts to let you, access these models via the nodes. We have payments. We have things like inference batching, et cetera. And we've actually started to see applications adopt them. They use them for everything from as simple as on-chain payments for inference requests to tying more elaborate smart contract schemes over their protocols, to using protocols to use models to parameterize various parts of their protocols. And as a result, and it's flexible with both on-chain and off-chain, you can do any sort of combination of on-chain, off-chain inputs and outputs, and you can pass in proofs if you care about verifiability. And as a result of all of that flexibility and just being able to expose, both models to smart contract developers, give them a clear monetization path, and fold in cryptographic primitives around verifiability, we've done a few million inference requests to date over the past few months, which is quite interesting, right? Because a lot of this activity is going to be tracked or is tracked on chain. And in building Infranet, we realized okay, this is really great. We're going to continue to support this. This is a really good way to have people call out to models and use them, but there's a way to build this better, right? And so we went to Ritual Chain, and I know you guys are real tired of infrastructure. I am too. But I promise there's a real good reason we actually built Ritual Chain, which is that when you have a lot of flexibility over the customizability of your VM, you can get a lot more done. And more concretely, what that means here is that we actually took a base Ethereum implementation, and we're building a custom VM on top of it. And a lot of that revolves around adding precompiles and safer precompiles. Think of them sort of like sidecars around AI operations. So when I go to the chain and I'm building an application, anywhere on the chain, as long as that model is provided for by one of the node operator set and they can access that model, anywhere on the chain, I will be able to write a single line smart contract call that does inference. And so suddenly, you, as any smart contract developer, anywhere on the chain, you don't need to do an Oracle, you don't need to specify anything, will be able to access models for inference natively and write smart contracts over them. And it's all made possible through essentially the development of sort of what we're calling the Ritual VM, and a lot of the work that goes into how do you make models atomic, how do you make inference atomic, how do you make that play well with consensus, which I won't bore you with. But what's actually possible with this, right? Suddenly you can have dynamically updated and I hate to use self-intelligent applications because it sounds really buzzword, but there really is no better way to describe it, right? If you're building a DeFi protocol and let's say it's a lending protocol and you need to set the loan-to-value ratio, the LTV ratio for a liquidity pool, before you would have to go to Gauntlet, spend months, get a governance vote, get that to go through. Now you can just pick, the best model available, have that set the LTV based on some sort of underlying features, and just have that, recurrently do that. That protocol is self-governing, self-autonomous, and just functions on its own, right? And that frees up governance to focus on more critical strategy things, right? And I think that's a very, very crypto native example. So I'll give you guys another example. We work with a number of consumer protocols that are building sort of things around like chatbots, own your own agent, right? So it's like there's some LLM, there's some persona that people create out of an LLM and a vector DB, and you can go own like part of that on it. Now this is really interesting because this creates dynamics that are, very, very important off-chain, because if I have like, someone goes and creates a persona that I really like, and I want to go and increase adoption of that persona so that the revenues going into that persona increase and my staking that goes increase, right? There's like now an incentive for people to like not just interact with these personas that LLMs create, but own a bit and get them adopted beyond just the primary place of content. But then the question becomes like, how do you reconcile all of the activity around like actually using the model inferences with ownership, right? Eventually that has to flow back. If you can link on-chain payments sort of in this trustless way and do the splits between all the people who like own part of this application or agent to like the actual metered inference request, then that's great, right? But it turns out that like we don't really have great financial infrastructure for doing that. It's actually like pretty annoying for like someone who's going and building this to like accept USD and then like do the splits automatically, and that doesn't even get into like a bunch of the implications around being able to do collective ownership, right, in Web 2 world. But it turns out people want this. We have applications that we're working with that have millions of DAUs, have done like millions in ARR per year, that are now moving to this ownership model, and their users are very receptive to it. And most of those users may not even know that they're using an underlying chain because of a lot of other work around account abstraction stuff that the application does on their end, right? And I think in the future, there's even more interesting things that we can do, right? There's been a lot of work around FHE, around ZK, et cetera, right? This will become important for models. This will become important in terms of giving certain guarantees around integrity or privacy, right, for use cases that care. But the reality is that, if any sort of proof is generated, you still need some sort of like arbiter or arbitrator to go and determine if that proof, is valid. If you give it to a trusted third party, they can easily be bribed and, do the verification, say this proof, is not valid, even if it is. However, a chain is a perfect substrata for that. Specifically within the context of AI, though, proofs can span a multitude of things. Skip that, skip that too. Where is it? All right, maybe not at this presentation. But proofs can do a multitude of things, right? And there's a lot of things to prove around the stack, right? Was the model run correctly? Was the model run privately, right? Can we do MPZ with ZK? One thing that we folded into the chain is actually a proof marketplace. So one thing that we'll be working on is basically like, if I'm a user, right, and I do care about a proof, right, how do I express my preferences about wanting that proof associated with my model? Usually that comes in terms of an economic preference, and that means that people who are running the models and are able to generate these proofs around inference, et cetera, will get additionally rewarded for the users who care about that, right? In a traditional system, that wouldn't necessarily be possible, right? There would need to be a lot of work done, pricing. You would have to do some weird things around like, try to build a model for like, how do you price like the value of a ZK proof based on someone's preference set. But here, thanks to like a lot of the innovations around like intent solvers, et cetera, we can actually build some of these systems. So that's, sort of a peak of what we do. But essentially, I think the way to conceptualize virtual chain is that you'll be able to write smart contracts over models. You'll be able to fold in all of your favorite cryptographic primitives as it relates to running models. So both building general purpose applications and building, AI-enabled applications will be possible. And I talk about that here. This is sort of like, an example of that where, we fold in a lot of the primitives around privacy. We have a proof marketplace, so everything from remote attestation to ZK. We work with storage layers to do decentralized model storage. And then we have on-chain semantics, right? You can literally specify and write agents as smart contracts, right? You can take payments cross-border. You don't need to worry about that. If you're running an open source model on the Ritual network and applications are using this, you will have payment flow come to you. And we're also working on some very interesting things around provenance with a few of our partners, like Story, to create IP, right? And actually create like a benchmark, like, okay, this was the first person to upload this model to the network. If people go and use that model, there should be a value flow back. And the very interesting thing is this, even though we do like to see open source, and we do hope open source will grow, our network is also flexible enough that if, yes, people do want OpenAI and Claude and Anthropic and whatnot, right, they can use that, right? The end goal for this is to just make a layer that anyone can go and just have general programmability over models, which does not exist, right? Which is why we consider ourselves the execution layer for AI. And that's our pillars. I mentioned a lot of these, but we do care about decentralization, privacy, integrity, and incentives, but in a practical manner. To the end that it actually betters the value proposition of the AI supply chain. And what could you build? So these are very, very crypto native models, crypto native ideas, I would say, because I think there's like a bidirectional bridge, right? There is where crypto is enabled by AI, which a lot of this covers, right? We can take existing DeFi landscape, reimagine it with models in the loop. There's a lot of really, really fun consumer experiments that are being done on chain, which I'll cover one that was built on Ritual early around like generating mass content, by AI, minting them, etc. You can there's a lot of rote tasks associated with on-chain governance that you can have agents take over. And then there's a lot of really interesting plays in gaming, right? We see applications like AI Arena, for example, where you train your own model, or Parallel Colony that learns from your actions in playing the game and learns to play the game for you, and then there's a reward system, right? These are, I think, like fun things that will drive users, are appealing to users, appealing to traders potentially. But I think what I'm personally very, very excited about is how do we enable AI with crypto, right? I talked a little bit about how you can fold cryptographic primitives. The reality is that like we have a lot of really good work being done around like verifiability, new proving schemes, etc. But the actual monetization paths for a lot of these are pretty slow. The actual number of like general purpose applications that are using this or need to use this right now are low. On AI, on the other hand, things like integrity and trusting a third party is actually becoming increasingly important, right? And so, if I'm trusting someone to run my model, usually if I'm going to OpenAI, et cetera, and I want to know they didn't fudge with it, or I want a TEE, I need to get like a very, very expensive, very, very hard to get BAA with them in Microsoft Azure, which may not even be possible now given that they've terminated their agreement, to ensure that like I can get some sort of remote attestation as an enterprise that they're running my model correctly, right? In comparison, if we have a good substrata for folding some of these cryptographic primitives into the running of a model, you can actually circumvent a lot of this, right? And you can make it composable with any open source model. One thing we're also very keenly interested in is data provenance, which is like, how do I measure how much my data contributes to the fine-tuning or training of a model, right? I'm sure all of us have used a model at some point. Maybe some of us have used open source models, and guarantee none of us have gotten paid for any of our data that's being used to train these models and improve them further. That's a really important feedback loop, right? Because I think as we start to see more and more models that are good at more and more things, what actually becomes more and more relevant is proprietary data and like personal data and user data, right? That's what actually becomes like very, very valuable, because models are good at learning how to do things, but they're not good at remembering things, right? And they can learn how to do things if they have more specific examples. So as you continue to see models evolve, being able to show them new environments, and thus that comes from having proprietary data, become important, but we also want to have good reward mechanisms. I talked about incentivization for open source and contributing to that. And the last part is governance. I touched briefly on how the processes that go into aligning these models are very, very opaque, right? It's not actually easy to say like over what value set like OpenAI is training its model on, right, and doing its alignment. And for that reason, like it's banned in most parts of the world, not because people don't want it or they think it's like telling them to do bad stuff, but actually because it's viewed as sort of like a lens for Western propaganda, or it's like too representative, like maybe a Silicon Valley mindset or value set, right? The reality is that we can actually use a lot of really interesting on-chain primitives to do things like incentivize people to do RLHF, right? Like vote on prompts out of like a unbiased model and capture a wider value preference set in order to essentially create better governance and alignment around these models. So these are all things that I'm personally very excited about, because this is where we can go, and there's actually utility in bringing cryptographic primitives and bringing primitives from crypto as an industry to AI, right? Like on that last point alone, we're already seeing that there are companies getting hundreds of millions of funding to build localized AI for countries in like India and Japan, and the UAE built their own project, right? There's a way to do this that scales beyond just countries or nationals, but around communities, et cetera. It'll be something that's quite valuable and quite interesting. This is a case study that we mentioned. It was a very, very simple case study, but back when friend tech was a thing, this was the first application built on Ritual. And this was to show really that like agents were good at coordinating on-chain payments and could handle real money. People who built this gave this thing like 10 ETH. You had to go convince it to like buy and sell your friend tech keys. And what it was accounts of LLMs that would read your prompt, decide if it was convincing, and then have like a classifier that would read the sentiment of that and then take an on-chain action. And to my knowledge, this was like the first time that there was an on-chain agent that was like handling this much money, right? And it worked. I mean, no one could convince it to like buy or sell keys, but we, in testing, we saw that that was able to move money around, take actions on its own. And so we were very excited because a lot of people bought the keys for FenRug, started trying to interact with it, and we were like, okay, cool. There's actually net new features, net new behavior that people are excited to use when it comes to both AI agents and actually how they interact with on-chain protocols. This is a very simple one, so we'll skip that one. And the last part I'll leave it on because I know I'm over time, is that we have quite a few open research directions that we're very interested in engaging with people on. Open model governance and ownership is definitely one of them. And I've talked a little bit about that, but like, how can we, collectively collect, data or opinions or value sets to change the way these models are fine-tuned? How can we reward people for doing that? We're very interested in efficient proofs of compute and efficient models as well. Specifically for larger models, how can we get stronger guarantees? Right now, your best shot with like a very large LLM is to like run it in a TEE. That feeds into further privacy improvements. We're very interested in sort of like open source, decentralized, transparent FMs. There's been a lot of good work on sort of like decentralized training or just open source labs like Noose Research that take existing models and make them available to the public. We're always interested in supporting that. We're very interested in routing. I think there's been a huge focus on like how do you evaluate AI models, but there's also things that you should be concerned about, which is like how do I know where my model is run? How do I know it's the cheapest? And how do you like reconcile all of those? Like I said, we're interested in data provenance, and we're always interested in extending agentic work. And how can you help? You can run an Infernet node. That's our phase 1. You don't need a GPU. It takes like 5 minutes. Even if you don't know how to code, we made it dumb easy. You can come build on us. Come talk to me. We've been working on a number of projects that are building natively on the Ritual chain. You can use the applications built on Ritual. We have quite a few. I'm happy to provide a list. We will be publishing this soon. You can contribute to our open source repositories. You can join our Discord. I don't even think people talk about AI and crypto there. They just want to play poker, so it's actually a pretty fun place to hang out. Thank you.
Okay. Yeah, so this was it for today, for this stage at least. So we still have an hour of talks at the other stage, including Mustafa from Celestia. So head on over there, I would say, and see you all back tomorrow. Thank you.